Sarah's joined, ma'am.
Good morning, Vignesh. What's happening?
Good morning, sir.
I mean,
Dinesh Babu, sir. Good morning.
Very nice. Speed up.
Sir, please. Yeah. Good morning.
Good morning, ma'am.
Good morning, sir. Good morning.
Good morning, everyone.
Good morning, sir.
Good morning. So perhaps, as I mentioned, I've slightly modified the title of my presentation, and perhaps I sent you, Dr. Sleva, the PDF version, so maybe I'll run through the presentation, and then, I did follow this, the sessions yesterday, so because of my other commitments, but how is it basically after the presentation? Do you have a Q&A session or something like that?
Yes, sir. Yes, sir. The participants, they will ask you if there is any query, you can answer.
Right. Sure.
Followed by that, paper presentation will be there. Technical
Understood.
that taken care by our faculty, sir. You don't worry.
Thank you. Sure.
And shall we start, sir?
Oh yeah, I'm ready.
Dr. Sangeeta, you can start. Even though it is 9:57, you can start because there must be some small introduction, no? Yeah, please start.
So should I share my screen, Dr. Silita?
Not now, sir.
All right. Sure.
It is a glorious moment to extend my warm wishes on behalf of Department of Marine Engineering and Ahmed deemed to be University on day 2 of the international level virtual conference on disruptive technologies in the maritime sector industry 4.0. May I now invite the conference chair, Dr. T. Sasilata, Dean Academics, Ahmed deemed to be University, to welcome the gathering. Ma'am, please.
A respected principal of our DGS courses, Professor Bhupati Bhaskaran, distinguished and honorable keynote speaker, Dr. Dinesh Babu, Director of KUM India Private Limited and Samhita Marine Private Limited, Chennai, dear faculty members and cadets of our Amat University, dear participants from various organizations, a very good morning to all. Let me welcome each and everyone present here for the 2 days international virtual conference on disruptive technologies in maritime sector, Industry 4.0, organized by the Department of Marine Engineering, Academy of Maritime Education and Training, deemed to be University, Chennai. Today we have the guest speaker and keynote speaker, Dr. Dinesh Babu, Director of KUM India Private Limited and Director of Samhita Marine Private Limited, Chennai. On behalf of the organizing team and the Department of Marine Engineering, Amat University, I would like to welcome you, sir. Welcome for this grand gathering. I welcome the other 2 guest speakers who will be joining the afternoon session, Dr. Moshin Raza from Edgell University, UK, and Chief Engineer I.N. Bose, the Great Eastern Shipping India, a group of companies, Mumbai. I welcome all the participants from various organizations who will be presenting their innovations and research outcomes during the 2 days conference. I hope this conference will provide ample opportunities to discuss and deliberate the disruptive technologies in maritime sector and how the industrial revolution, that is Industry 4.0, will automate the ships and the shipping industries. Once again, I welcome you all for the 2 days international conference on disruptive technologies in maritime sector, Industry 4.0. Welcome you all. Thank you, ma'am.
Thank you, ma'am. May I now request Professor Bhupati Bhaskaran, Principal, DGS Courses, Ahmed deemed to be University, to address the gathering. Sir, please.
Mic off la irukku. Mic off la irukku.
Thank you. I first, sorry. Yeah, sorry for the hiccups. Yeah, I first thank our Chancellor, Vice Chancellor, Pro-Chancellor, Pro-Vice-Chancellor, Registrar, and above all, I should thank Dean Academics, Madam Sasilata, for providing us this platform. I mean, this platform is a very important platform, whatever you can say in life, whatever we achieve. Now, here we have been coming across various speakers on various aspects and research, particularly last 2 days. I mean, the second day today, yesterday was full and full packed with research activities and the scope for more research activities to take place, which was very innovative. I first thank our AMET management. Now, coming to this program, yes, I thank our Dr. Dinesh Babu, sir. Sir is from KUM India Private Limited and Samatha Marine Private Limited, Chennai. First time I've heard of this shipping forum, sir. You're heading this team of company. I would like to know more about it in a short time later, so that we can have long-term relationships. We welcome you, sir, on behalf of AMET, with fullness and full hopes that our cadets will take something from this, your speech and this gathering here, so that they can, lay their foundation stones, for higher studies and various other aspects of researches and the technologies which are existing and to exist in future and so on. Sir, I hereby hand over the mic to you, because once I start discussing, and to a mariner, more and more I would like to discuss a lot. We have a long time to go on, so I hand over the mic to the organization. Please, madam, go ahead for the next stage, please. Your mic is off, madam. Your mic is off.
Sorry, sir. Thank you. In today's session, we have 3 tracks. Track 4, Innovative Underway System, Renewable Offshore and Future Technologies. Track 5, Industry Automation. Track 6, Marine Pollution. Now we will start with the technical sessions. May I now introduce Rifana to address and give a small brief introduction about the keynote speaker of track 4.
Good morning to all. I, Rifana N, of first year Department of Marine Engineering, feel extremely glad and overwhelmed to introduce the keynote speaker, Mr. Dinesh Babu SO, the Director of KUM India Private Limited and Samhita Marine Private Limited. Sir, I welcome you to the track 4. Track 4 on Innovation Underwater Systems, Renewable Offshore Energy and Future Technologies. Sir is a seasoned campaigner and has a vast experience in this domain. He is focused primarily on marine system, ocean bottom, seismometer, deep sea technologies and innovation and oceanography. Furthermore, he is a specialist in deep sea technologies handling system. I now request the keynote speaker to address the gathering. Sir, please.
Thank you, Rifana. So perhaps good morning, everyone. It's a pleasure joining you all on this auspicious day. And perhaps I think this is my second interaction with AMET. My first interaction was a few months ago when I was there with Dr. Silata and team for the Board of Studies discussion. And thank you for giving this opportunity to talk about innovative underwater systems and offshore energy resources and future technologies. Perhaps I want to focus on underwater systems, but because we are talking about energy and fresh and perhaps renewable energy and onboard ships, I thought I should also cover something from the offshore marine sector. So I'm going to share my screen. Are you able to see the screen now?
Yes, sir.
All right. So basically, welcome you all for my address on innovative underwater systems, renewable offshore energy, and future technologies. It was a pleasure talking with you all on the Forum of Disruptive Technologies in Maritime Sector Industry 4. As Colonel Dr. Dhruvaskar mentioned yesterday in his opening remarks, we're talking about the Annachi Kadai to the online innovation, what we are seeing today. Annachi Kadai, roughly translating in neighborhood store today, is the traditional way of making business in this country, in our country, and many countries in the world as we started. But today we have moved on to the online solutions. And this is what we see as a disruptive technology. And perhaps is this disruptive technology is going to be beneficial to the mankind, or is it going to be a different factor otherwise, is something which is left for any individual who is working on these solutions and experiencing these solutions to make a decision as they experience over time. So from the technology side, as we see this disruptive technology is going to be amply advocating advancements in solutions, we are more favoring towards adapting to the disruptive technologies and also augmenting newer technologies as we go forward. So as Rihanna and Sangeeta and Dr. Bhupati was mentioning, I am with KM India Private Limited and Samita Marine Private Limited. And Samita Marine was started in the year 2017. We came as a sort of a blanket organization which was transferred to us from my previous employer called Results Marine Private Limited. Results Marine decided to focus on oil and gas. So the Marine and Oceanography division, which I was handling, was transferred to us. And we bought over and took over the division, and we formed Samita Marine Private Limited in 2017. But I've been in this field since maybe late 90s. And so perhaps in oceanography, we have got a very good relationship, very good connect in the market, industry, and also with the customers. So with that background, I'm also introducing KM India Private Limited, which was started in year 2020 May. So are you able to see the full screen, or the top portion is a little bit muted?
Yeah, able to see, sir.
Okay. So basically, KM India Private Limited was started in May 2020. KUM is a company based in Kiel. It's a company called Kiel Umweltmeerestechnik. In German, it roughly translates to it's an offshore and environment research company. So basically, we produce technology, engineering, and customized products and solutions for science, academic research, defense arena, very many underwater systems. We work primarily on deep sea applications and technologies. And as I mentioned, KM India was incorporated in May 2020 to take over the Indian operations of KM in Germany, and also to work with Make in India program in indigenized manner, and also to provide integration and support services locally in India. So we work on innovative high quality products, provide professional services, we provide customized solutions for our customers, and we are present across the world. And also we're trying to work from India to look east, and also from India we want to work for India, and also from India to look at east of India and also west of India in the Indian neighborhood to take care of the operations for KM and KM India Private Limited. And perhaps I would like to start with the basic design evolution concept before we go into the real topic of today's discussion. In any underwater systems or any system which goes in the sea, the key is sustenance. Unless you make a design properly and it is implemented properly and deployed properly, you will not see the data. So for efficient application in practice, the technology should be made with, it should provide advantage to the science. So what it takes, any technology which is deployed in sea should be designed keeping in mind that it should be capable of taking longer measurements, and you should be able to take as many instruments as possible on the ship. And then you should be able to deploy the equipments faster and retrieve the equipments faster also, so that the ship time is optimally utilized. And of course, you should get high data quality, and the fidelity is all in about reliability. So this is on the left side of the screen is a type of ocean bottom seismometers with which KM started maybe decades ago. And this equipment which you see in the vertical standing position its mass was roughly around 380 kilograms, and it was capable of standing in ocean at around 6,000 meters, 3,000 meters water depth for around 3 months. And from there, the next evolution, which you see in the middle, it was around 400 kilograms, and it was, with advancement in technology and batteries, it was able to sustain in water for 12 months. And from there, what you see on that same slide on the left, on the right side of it, is what the latest generation ocean bottom seismometer is. It is roughly 50% the mass of the previous versions, around 200 kilograms, and it was still able to sustain in water at 6,000 meters water depth for 12 months. So what it takes in design evolution is that you need to make a product which is going to be least hungry in terms of power consumption. And it should be made in such a manner that the footprint has to be in one way or the other. It's going to be smaller. I'll come to that later. And perhaps if you come into the middle slide of it now, and you will see the power consumption in milliwatts for the initial version of ocean bottom seismometer, which was consuming 1500 milliwatts, and the next generation, which was consuming around half of it, around 680 milliwatts, and then the latest generation, NAMMU, which is consuming 300 milliwatts. So what it does, basically, in terms of design, this initial version of ocean bottom seismometer, we are able to carry 12 of them in one 20-foot container, which is capable of sitting in water for 3 months. And then the middle version, the mid version, which is called, this one was able to sit in water for 15 months, and we are able to take it around 50 numbers of these equipments. And then the latest generation of the equipments, in one 20-foot container, we are able to pack approximately 50 of these ocean bottom seismometers. They are capable of sitting in ocean bottom at 6,000 meters water depth of more than 12 to 15 months. And perhaps if we can increase the battery size, we can increase the time it can sit in the water. The memory is not a problem these days. The memory cost has come down. We can easily add gigabytes of memory. The only thing which restricts the time inside the water is about the biofouling, but in depths at 6,000 meter water, you will not find that type of biofouling. We have never seen these things. We have been deploying these equipments, every year in various parts of the world, various oceans at depths varying between 3,000 to 6,000 meters water depth. And we have not seen any of these ocean bottom seismometers affected by the biofouling or not being able to retrieve. Our retrieval rate is approximately around 99%. So almost 100% of these ocean bottom seismometers which you put in the water comes back when we retrieve after 12 months to 18 months. So now you can add more batteries. Now you add more batteries, the sizing is going to increase. The sizing is going to increase. The buoyancy needs to be made properly. And so the buoyancy has to be increased. That means the size of the equipment increase. So with all that in mind, the optimal design of this NAMMU ocean bottom seismometer has been kept in such a manner that we are capable of carrying around 50 OBS in 20-foot container, and between 12 and 15 months is where the battery sizing is optimally done so that we can deploy these equipments. Why we are keeping 12 months, 15 months, cannot be 3 months, every month we cannot go to the sea. It is possible, we can go to the sea, but it is going to be that much more expensive to go out to the sea. For instance, we are deploying an ocean bottom seismometer from India in Indian Ocean or Central Indian Ocean Basin. It takes around 10 days to go down to Central Indian Ocean Basin or even to the areas south of Maldives or in that region. If you have to go and deploy and come back, it is easily a month's cruise. So to do that type of deployment cruises, we need the right type of vessels, the right type of endurance, the right type of people, and also the right type of equipments. This is where the equipments are designed. The functional design of solutions are made with all these in mind. So I just want to give a brief introduction what it takes for a company which produces innovative technology and equipments to keep in mind in design stage to conceptualize a product which is going to meet the expectations of the customer, which is a scientist who is keeping the science in mind. So to make science, to make data, you need the right design. That's all about it. The key for sustenance at sea is evolution and then innovation and creating reliable products. This is what I'm trying to talk about. Of course, the experience counts for all this. And KEM had been in the market for so long. and we have offered more than solutions to more than 200 customers. We have served more than 150 plus universities. We have deployed more than 400 expeditions for offshore expeditions. We have completed more than hundreds of scientific projects, and we have more than 4,000 of equipment sitting in the subsea at various points in time. And we have consumed approximately 120 tons of titanium. Almost every product we make are made out of titanium because it has to sustain 6,000 meter water pressure. It should not get corroded. And so it's expensive product. It's expensive to manage, maintain, produce, but it's a reliable product. It works, and which is where we carry a reliability factor of 99.5 or 99.9%. So now coming to the topic of today's discussion, renewable offshore energy. So as we see, the renewable energies from marine primarily comes out of 5 or 6 factors, which is wind energy, wave energy, tidal energy, ocean current, and ocean thermal energy conversion. Water is very innovative, and it's a very long-standing thing, but it has been very less utilized because of the cost factor. I'll go one after the other. Perhaps as to say, the oceans are teeming with energy, and the tidal forces, so it creates immense masses of water, and it's a movement. And then the ocean creates very strong winds, which builds up the mighty waves also. And with all these things, so in almost 90% of global wind energy, it be offshore or to be on land, it's all because of the containment of turbulence over the world's oceans. And because of the world's oceans create waves and the energy and the winds, it's all about that, which is helping us to create the wind energy. Wind, waves, and currents together contain more than 300 times of energy that humans consume annually at this point in time. This is what we see in the open domain. And then we talk about the offshore wind energy, and perhaps the wind energy has been there in the market for quite some time. Windmills have been there on land, and now we are moving to offshore wind energy. This has been discussed for more than a decade now, and it's been adapted in very many countries. And if you go down to European countries, even in very shallow coastal waters, if you travel between Norway, you travel between Denmark and Sweden, between Copenhagen and Malmo, you will see between the sea, there's a sea bridge connecting these two small towns. And then you have a lot of windmills, offshore windmills, which is coming immediately after a few kilometers of this sea bridge. So wind energy is currently at it's the most advanced stage of development today. And so perhaps offshore windmills are also getting very, very much adapted, and you need the right construction techniques. And the estimation today is that we can generate approximately around 5,000 terawatt hours of electricity a year worldwide. And approximately this is a third of world's current annual electricity consumption. 1 terawatt hour is it's around 1 trillion watts. So it's so humongous energy which we have the potential from offshore. And there are very many wind energy projects implemented worldwide. And as I mentioned, the predominant countries which is exploiting this more is in the United Kingdom, Denmark, Netherlands, and Sweden. And of course, other countries are exploiting as well. And India is also trying to do our best part. And we have been studying this from our institute in Chennai called Center for Wind Energy Technology. And this is now called National Institute of Wind Engineering or something like that. Perhaps they've been doing a tremendous efforts to understand the wind energy offshore, and they are making studies off the coast of Gulf of Mannar and also off the coast of Gulf of Kambut in Gujarat. So these two locations, they are trying to do some pilot studies, and it needs more studies of wind patterns, more studies of floating platforms and offshore structures, moorings, and or anchoring these systems, whichever way, like if it's going to be a shallow water, it will be an anchored project, or if it's a deep water, it will be a floating platforms. So there are very many options coming in, and so as you see, it can be, the challenges of the offshore environment demands very robust technology. And of course, this is maturing at this point in time. We will talk about a little bit of understanding about what type of studies are required to do these things in combined with offshore wind energy or tidal energy or ocean current or the wave energy over the next slides. But we then talk about the wave energy. And perhaps the global wave energy potential is estimated around more than 11,400 terawatt hours per year. And the sustainable generating potential is 1/10 of it approximately, which is a tenth of a global average energy needs at this point in time. There are three types of wave energy possible, and of course, India has also tried this with National Ocean Technology and IIT Ocean Engineering Department, IIT Madras Ocean Engineering Department. A few long years ago, maybe 10, 15, 20 years ago, they've been trying this off Vizhinjam in Kerala. And the one you on the left side you see is basically there are three types of wave energy generating systems possible. One is oscillating water column, other one is overtopping, which is in the middle, and then the oscillating bodies, which will be on the right side. So the one on the left is oscillating water column principle. The water enters a wave capture chamber, and it is going through the rock face at the top. And then the tidal power forces the water into the chamber. And then the air, which is creating the push, is pushing the turbine on the top. So this is the principle of the oscillating water column principle. The water goes up and down, and then when it is going up, it pushes the water, it pushes the air, and when it is coming out, it sucks the air. So the turbine moves in both directions, and then it creates energy which can be tapped. In the middle, you see it's basically overtopping principle. So it is more like the waves which is coming into the reservoir, and then it is filling the reservoir. As it is filling the reservoir, it is pushing the turbine and the air down and the water down, and then the propeller starts moving, and so the turbine starts moving, and then it starts making current. So this is one type of principle. And the other one, which has been doing commercial studies of late, there are very many ways and methods in which the oscillating bodies principle has been recently doing in much furore in the market. And perhaps the one you see on the right side is picture courtesy from a company called Recent Waves in Denmark. Perhaps they make this oscillating bodies, smart buoys. So basically, it has impeller type rotors, and it's just floating on the water, and then the waves makes the rotor move on either direction. As it moves, then the impeller starts generating current, and then it is offloaded and taken through various channels to the landmass, and offtake of current is feasible. So the main challenge of any of these offshore wind or wave or current technologies is off-taking the energy which is created. You need sophisticated cables, you need sophisticated connectors, you need sophisticated long standing. You have to sustain robustly about these ocean parameters. It is corrosive, it is choppy weather, it's having tidal effects, the water is moving up and down, there's extreme force which is happening on these cables and connectors. So you need to have the bends are all supposed to have bend restrictors and fasteners, so it can sustain all these conditions. So the main challenge is about off-take of this energy which is created in the ocean to the mainland for consumption. Then we come about the tidal energy. Tidal power plant, it works very similar to the reservoir power plant as we see in the land. And it's just that the water mass do not flow downhill. It is moved back and forth with the tidal flows. So the tide comes, and then the tide increases, the tide decreases, the rotors move on either direction to create the tidal energy. So unlike the ocean energy, tidal energy has been commercially utilized for quite some time now. And it can be used between high tide and low tide. Water flows up and downstream through the large turbine, which you see. And the turbines move, and then it produces tidal energy. And there are enough power stations out there, and this output is similar to the gas-fired power station. And facilities have been constructed in Canada, China, and Russia in the last 2 decades. And they are much smaller in size. It's more about demonstration platforms. It's still not coming to the optimal sizing. And in Korea, some time ago, they have thought about constructing a system which is integrated with a reservoir, existing reservoir. so that the tide line which is crossing the reservoir up and down can create enough possibilities of putting as many tide current generation systems. The main problem with all these equipments is it creates a potential hazard to the biosphere, the flora, fauna, the creatures which is living in the seawater, the fish and other populations gets affected with these propellers. And of course, it does affect the environment because it's churning and it is creating more turbid waters, and that creates all the more condition with this, imbibing effect on environment. So, as I said, any disruptive technology has the plus points and also the negative points. The humanity today has to take a very cautious and informed decision after doing due diligence and also environmental impact assessment studies as to whether the benefits are commensurate with the type of potential situations disruptive technology can bring. So the world continues to study this, and we believe things will evolve over a period of time, which is much more safer for the environment. The other type of energy from ocean offshore is called ocean current energy. It is something similar. But as you see, we create a channel and taper down and then bring the water into the reservoir with force. And then that force is in a position to turn the turbines. So basically, it is more like the current which is coming and going, the ocean current. It is rotating the propellers, and then it should be able to generate the current toward the movements. And there are possibilities, can put more than one rotors, and we can create on both sides and up and down. We can create more of these things are being tested. As I said, every thing which is measured in the ocean, you have to face harsher environment. You do not have the design aspects which are controllable. Nothing is controllable with nature, by the way. So you cannot control the wind, you cannot control the waves, you cannot control the tides, everything. Tide, we know tide will come and go, but then you cannot beyond the point to predict the waves and or control the waves and or winds. So the wind create waves and the wind. Sometimes the tidal effects vary beyond the design aspects. These things are something which we can predict, understand, but we cannot control at any point in time. So when unpredictable or uncontrollable things happen, your system needs to sustain. Otherwise, these are high cost, high investment systems which is invested on the water, kept in the water. And if in case of surprising things like what we experience in tsunami or storm surge, like cyclone and all these things, despite our best plans, sometimes things can go wrong. So that's where it does bring a concept that any solution we make for ocean environment, offshore environment, will have to be extensively tested for endurance purposes, endurance parameters. Now coming to the very fascinating topic called ocean thermal energy conversion. WATEC utilizes temperature difference in ocean between the top layer warm water, surface water, and then the cold deep water, which is used. This temperature difference is used to generate the power. In order to drive the steam cycle in an WATEC power station, we have condensers, we have evaporators, and so basically we need a temperature difference which is at least 20 degrees centigrade. So what we do is we take the surface level temperature, which is approximately 27 to 28. These days we are even seeing 31 degrees at sea surface temperature. So we take surface sea water and we pump it, and then we utilize this to do steam condensation, and then the steam is produced. And now we also pump the cold water from depths of around few hundred meters, and then we get a cold water of roughly around 4 to 6 degrees C, and then this water is brought down to condense the steam, and then the steam is again made in water. The water is pushed back to the sea, so there is no pipe. There's no other adverse effects. And so this is the principle by which you create the steam, and then the steam is utilized to run the turbine, and then the steam is again cooled down using the cold water, and the water is flushed down, and then you can bring things up. And this cycle happens. So the main disadvantage of this solution, this has been there for very many years. It has been primarily pushed by US Department of Energy and some European countries, and also in India we have been trying for very, very long time. IIT Madras Ocean Engineering Department and the NAOT started working on this most decades ago. And they have tried this in off Tuticorin on a barge. They have tried in islands and in quite a few islands, including Kavaratti and Lakshadweep and in Andamans. They have tried this, and thanks to NIT, National Institute of Ocean Technology in Chennai, under Minister of Earth Sciences, Government of India, the power plants using low temperature thermal desalination. It is a version of OTEC. They have established these plants in Kavaratti, Minikai, and in various Lakshadweep islands. Almost 2 or 3 plants are there, and they're planning few more plants in the next years and next months at this point as we speak. And thanks to these LTTD plants, low temperature thermal desal plants, these islands otherwise, which is, cursed unfortunately with the sort of brackish water, saline water, they are now able to at least drink good fresh water. Their tea used to be so salty, and now we are able to drink a good tea when we meet these people, when we go to these islands. Thanks to NIOT for making these efforts. So these are all the societal advantages which comes out of the technology. And it is not very expensive as compared to the OTEC and or reverse osmosis. Reverse osmosis is something which really impacts the environment. It is using a lot of filters, and the water generated from reverse osmosis is also going to create more trouble to the ocean environment. And most of the ships use reverse osmosis because we need to generate water on board ships, and we use reverse osmosis process. That's the only thing we is available at this point in time. But the world is looking at changing to OTEC, and India is also trying to contemplate an offshore OTEC 100 MLD plant off Chennai coast, and it costs approximately Indian rupees 2,500 crores, if I'm right quoting Secretary Minister of Earth Sciences in one of his recent interviews, and perhaps it translates roughly to US dollar 330 million. And what we understand today is Minister of Earth Sciences, National Institute of Ocean Technology in Chennai will be, rather than investing 2,500 crores, because this is something no one else in the world has done, we are trying to do it. And if it does work, it's going to be very beneficial for the city of Chennai, which is facing starking, drought conditions in summer. So now they are planning to do a pilot study, which is at the cost of around 113 million US dollars, roughly around 100 crore Indian rupees. So this will be an offshore platform, which will have to be like, unlike in Kavaratti where the sea cliff falls very, very sharp immediately within few meters or few hundred meters or maybe less than a kilometer, whereas in Chennai, because of the sea plate, it's very, very flat. And so it's going to be more than few, maybe 30, 40 kilometers before we get this type of 4 to 6 degrees cold water. That means 100 meters or 150, 200 meters water depth. So you need to be going that farther out in the sea, and then you need to be deploying your cold water intake tubes to 100, 200 meters. And then you need to bring this water, fresh water, to the land. There are only 2 ways. You can fill it on the barges and bring it. It's going to cost more money. Or you have a permanent pipes, which is going to connect such long distance of 30, 40 kilometers. So it's going to be a challenging feat, but it's all about taking the challenge in offshore to offtake the new and renewable energies. This is all the arenas where the science and engineering is investing our efforts and time at this point in time. So the next thing, as I mentioned, all these things are augmented, and we need to understand how these things are conceivable, designed, utilized, constructed, adapted, and implemented, and then the offshore energy is taken on to the land. So apart from doing all these things, these ocean measuring systems can also help a country or a science to understand various parameters, including climate change, engineering, science, and various physical oceanographic parameters, biological parameters, chemical parameters, and so on and so forth. The one on your left side you see is the buoys, the ocean buoys, or the research buoys, which we put it in water with a lot of instrumentated moorings. So it goes down, the moorings are suspended at various depths in the mooring chain, and the buoy is a platform which is keeping it intact in one place, and then the data is collected, and then periodically this data can be stored and or transferred to the satellite, RF, or any other telemetry which is feasible. If it is far out into the sea, it is only satellite communication which is feasible. So you need moorings, you need winched profilers. Winched profilers are something similar to moorings, but then it's not visible to the surface. The moment a buoy is visible to the surface, it is vandalized by fishermen and or any other such folks, and so it gets disturbed. And then if it is vandalized, you will lose the data. And the people who vandalize do not understand the value of this data. They don't understand the value of the equipments. All these equipments which goes inside the water cost a lot. Every mooring costs approximately between 150,000 to 200,000 euro, in terms of 100,000 to 200,000 dollars, which is a few crores of rupees. And then perhaps deployment cost, then going by the ships, deploying manpower and all that. If you take, it's going to be humongous cost. Not just that. And these are all meant for going and deployed, and then it's going to generate a lot of data over a period of time. And if these equipment do not generate data for that longer time, what science and technology and the science, the country loses is the data. Invaluable data is lost. That cannot be filled up by any of this value. And so the dollars and euros and rupees, it is only factors. But what matters is the data, which is what is going to make us understand the oceans and also adapt to the oceans and deploy the equipments like offshore energy or whatever to be adapted appropriately. So we have moorings, we have winch profilers. So the winch profilers are the ones which is not visible to the surface. It can come to the surface, transfer the data, and then it can go back to the station, which is subsurface. And we'll show that picture over a bit of time. So that's the type of winch profilers are feasible. And on the right side, you have the type of equipment called landers, which will sit at the seabed. Over a period of time, it can measure various data, including ocean current, using acoustic Doppler current profilers, CTDs, and any biological measurements, any chemical measurements, and any other things which can work inside the water can be fixed on these platforms. It can be at the seabed. It can be over a long period of time, and then it can be retrieved. You can release the acoustic release, and then it comes up, and then it can be retrieved on the vessel, and the data can be collected. And then you have drifters, as you see on the right side. This is used for sea surface temperature and wind parameters, which is useful for climate change prediction. And then unmanned surface vehicles we talk about. We talk about mooring systems and geotechnical investigations, so on and so forth. For putting the offshore structures, we need geotechnical investigations. So in all, the solutions need to be simple so that it is easier for people to comprehend and utilize, but it needs to be very robust system, because these equipments are going to provide you some idea about what ocean is, what conditions are, and those ideas and conditions and measurements is going to help you to deploy your energy systems or wave systems or tide gauge, whatever you want. And those things can be done. The infrastructure can be built, including offshore platforms, only with these data. The ocean bottom seismometer is where KEM is focused on, but then this is not the only thing what KEM does. We do many things, but I'm not here propagating the company and our product, so we'll just talk about technology. As I mentioned, ocean bottom seismometers, these type of equipment we take in these type of ships. Sagar Kanya is almost 100-meter long ship, one of the pioneering research vessel of Government of India, Minister of Earth Sciences. It was with the Department of Ocean Development transferred to Minister of Earth Sciences, operated by NIO Goa and then with NCPR Goa, now National Center for Polar and Ocean Research. And so this ship takes these type of equipments. Maybe last cruise in 2018 and 19, we had this type of team of people with a German who came for deployment in 2018. And retrieval in 2019 and redeployment in 2019. Unfortunately, he couldn't come in 2020. So fortunately, in 2019 retrieval and redeployment cruise, we had Samhita Marine's engineers trained on board the cruise. So in 2020, when we were supposed to retrieve the second deployment, we couldn't bring the German experts because of the COVID situation. Samhita Marine's team managed, along with NCPR team, all ourselves, So it became a complete Indian mission to retrieve ocean bottom seismometers from the sea. So in this ship, we had a container on this place, and that container had around 17 of these ocean bottom seismometers and few spares of seismometers and other things. And then we used the ship's crane to deploy these seismometers. As you see, it is being deployed in the water. And then it is after retrieval, it is sitting on the deck. And this you see is all night operations being done. And now we talk about underwater vehicles. So we have various types of underwater vehicles. This is a manned submersible, and this is a remotely operated vehicle, and this is autonomous underwater vehicle. So all are underwater vehicles, but it changes in size, shape, and purpose. Manned submersible can take few people inside the pressurized chamber to depths of around 100 meters to few thousand meters. Now we are capable of diving down to 6,000 to 10,000 meters also. We have the technology and personal sphere which can take the man down to 6,000 to 10,000 meters water depth. It is more like if we can put a man in the space station, we can also put a man deep down in the sea is what we are trying to say. So remotely operated vehicle is meant for doing, sort of for intervention for various applications. It can be remotely operated. It's more like a joystick operated system from remote toys, but it is a remotely operated vehicle. It's a huge system. It has a lot of equipments, a lot of electronics, a lot of control systems, and also human type of hands, which can be 5 function or 7 function. The maneuvering systems, and we can go and pick samples from the sea or grab, or you can use these hands to simulate and create hand movements to adjust the walls in oil platforms or subsea platforms. An autonomous underwater vehicle is a replacement of all these things and also replacing surface vessel to a greater extent. It can go autonomously. This is tethered system, means this vessel goes from the mother vessel, the ship, to the top ship, and it is tethered. The power and the control happens from the mother vessel. And whereas the manned submersible has nothing, it's like an autonomous underwater vehicle. It goes on its own and it does the work and it comes back. And then the autonomous underwater vehicle is completely programmed system. There is no manual intervention. There is no one driving. You program, you give the waypoints. It goes to the depth and locations. It does the survey. You can do suite of equipments on board this. It can conduct the survey. It can come back from the water. It can transfer the data acoustically. So all that is feasible with this autonomous underwater vehicle. Now a little bit about history about various evolutions in underwater vehicle. The first revolution happened in manned submersibles in 1960s. So the one which you see on the left is called Alvin, the first manned submersible made by the United States of America. And of course, Russia has Mir 1 and 2, which is what you see here. And perhaps these type of manned submersibles, which goes now these days, the Chinese ones, the French ones, and the Japanese one, they're all made for 6,000 meters water depth. Russians have dived many number of times. The Chinese have dived many number of times. The Chinese Zhejiang. And then the Alvin has been doing almost multiple cruises every year. And now India is making our own manned submersible from National Institute of Ocean Technology, funded by Ministry of Earth Sciences, Government of India. Manned submersible Matsya 6000 is capable of diving down to 6,000 meters water depth. Samhita Marine and KM, we are supporting an AOT by giving them some key elements of this manned submersible. And we have supplied them batteries, lithium polymer batteries. We are supplying some navigation systems, some other equipment, so on and so forth. And perhaps the manned submersibles have been produced in numbers in 60s and until late 74. There were around 30 manned subs in the North Sea. But then, the second revolution is remotely operated vehicles, which came in 70s. In 1974, ROV was introduced. This came after the manned submersible. The first one to come in autonomous systems is manned platform, and then the remotely operated vehicle came. The reason because you are risking the man going down to that type of depths, 3,000 or 4,000 meter water depths. So instead of that, they said remotely operated vehicle is much far better. And so the driving force was offshore petroleum industry with a lot of money. And then in 80s, all the manned submersibles were eliminated in the North Sea. There were no more manned submersibles in North Sea in that point in time, except America had their own manned submersible, which is then designed for 4,000 meters water depth. The next one was now designed, or maybe it's being retrofitted for new Army is being made for 6,000 meters water depth. The prime criteria about the manned submersible is that the personal spear will have the forging and making this personal spear is very cumbersome. And only few countries in the world has it. The Americans have it, the Russians have it. And I do not think anybody else has it to the best of my knowledge, but then this is a debatable topic. I'm not getting into that. India has tried its best to get this technology for the personal spear forging and making from assets of America. And also with India is now talking with Russia to get it. India is also interacting with our own Indian Space Research Organization to create this personal spear indigenously. So these efforts are on at this point in time. And if and when we have the manned submersible, which we believe will be done in another year or two, or maybe in the next couple of years, we will be in the league of countries which are capable of making and manning a manned submersible, which is capable of diving down to 6,000 meters water. There is also a private entity in America which is managing manned submersible, which is diving to much farther depths like Mariana Trench, which is more than 10,000 meters water depth. And these manned submersibles operated by this private industry is called Deep Challenger, and they are diving down almost. They have dived almost every deepest point in every possible oceans in the world. They have been going good, and that all this proves that manned submersible is coming back. It's not that the man wants to create this massive equipments to go down and capture the dips, but it is because when you go down and do some experiment using this type of dummy equipment, which is doing what you want to do, and you are operating from the top, the manned submersible will be capable of taking down a man with the pilot, and he is able to see instead of getting it recorded by a video camera or a camera, you can see it visually, and then you can imbibe the science more, and the knowledge can be much more rewarding. Coming back to remotely operated vehicles, the ROV integrations, it borrowed the technology from the manned submersible, but then it added more computer power and video, and so it helped in making an ROV, and then it helped in making an AUV enabling technology subsequently. So ROV is just not a toy, it's not a vehicle, it's a system which comprises of the vehicle, a tether system, which is a cable, umbilical, and a tether management system, and then you have a crane, which is required to pull out of water and then deploy it inside the water. You also need a winch and control consoles and power to operate these equipment. You're operating at 3,000, 6,000 meters water depth, you need humongous power. Maybe around 3,000 or maybe 3 to 6 kilovolts power is what you require. So of course, each element you need equal attention in development, so it's involved properly. And then comes the ROV applications. It can be used in both military and science. And these are science platforms. Some of them are military platforms. And this is the NIOT's own ROSUP 6000, which is this is the 6,000 meter diving capable ROV developed by NIOT in Chennai in collaboration with Russia. And then this is the tether management system, which came from a company in Canada called International Submarine Engineering. So what it does is this guy goes down to 6,000 meter water depth from the ship. It can be tethered. And then this is having a top hat. This is called top hat. A tether management system is called top hat. When this reaches the desired depth location, now this vehicle can get detached. And there is another smaller winch within this tether management system. So this smaller winch can take this vehicle in a radius of approximately around 400 meters. So we have around 400 to 500 meter winch here. And this is all operated through the power coming from the mother vessel. And this is the mother vessel, the one which is deployed. And then there is a link here. And then this cable is holding this tether management system. And then inside the tether management system, the vehicle gets detached after a location, and then it can do further surveying 400 meters radius. So ROV as a platform, it finds use in benthic water measurements, real-time filter measurements, bio measurements, flora and fauna measurements in the open sea. and it can be used for physical oceanographic measurements, chemical oceanographic measurements, coring studies, and also for studying the thermal vents in the ocean. India is trying to do some of these studies in our hydrothermal sulfide plants, which we are going to monitor. And then these are all lying at around 3,000, 4,000 meters water depth in Central Indian Ocean Basin. And what it produces, these thermal vents can, spit a lot of minerals. And we can study this, and then if we can form these minerals, which is, going to be useful, we can start exploiting these minerals. As you all know, the mineral available in the land is going down, and we need to be starting to explore more of these minerals and polymetallic nodules from the Central Indian Ocean Basin. This is where Government of India has allocation of approximately around 75,000 square kilometers of area. So we are now exploring, we are still understanding, and we are also making a design in India itself. We are making a design for deep sea mining technologies. We'll be going for deep sea mining and augmenting and also excavating these resources and then bringing it to the mothership and then to the mainland for using these deep sea minerals. So ROV can also be used for oil and gas applications, offshore applications, for construction and intervention studies. It can be used for military applications, for harbor defense, mine countermeasures, torpedo recovery, and accident investigations. And they've been used by very many of these industries like Embari, Jamstack, and NIOT in Chennai. There are very many international institutions that have been using this. And then the third revolution is autonomous underwater vehicles. So 80s is where AUVs came into development in the right earnest. The concept had been there for a long while, but the evolution, the personal computing industry, it contributed immensely in developing autonomous underwater vehicles. AUVs are autonomous, unlike remotely operated vehicles. It is not tethered. It is completely autonomous. You can program, you can leave it, and then it can go and do the job, and it can come back. And then it can be retrieved onto the mothership. Data can be collected. Data can also be streamed acoustically if it is not small data, like state of health can be transferred, and then when the vehicle comes back to the mother vessel, you can retrieve the data. So in mid-80s, AUVs were made for doing the surveys. It can be used. It was used for doing obstacle avoidance investigations, and it achieved the full autonomous operations. And typical benefits of AUVs, as you see here, it can be built in very short time. Unlike you tend to make a vessel, it takes such long time to build a vessel, and then this can be built in shorter time. It can be used both for military and civilian applications. It's very low risk for the environment. It's much cheaper than the ship, and of course, it's very portable system. And it is capable, it can fit as many equipments, you can interchange the equipments after every possible missions, and then the data we can acquire and then store, and all these things can be done. You can control these equipments from moving away from the hazardous environment. You can do whatever. It can be given a little bit of intelligence also. It has an obstacle avoidance sonar here. So if you find, when it is cruising, if you find a sea mount, it decides and then it goes up and it cruises and then it goes down to the waypoint. So all these things are possible and feasible with an autonomous underwater vehicle. So as far as endurance is concerned, you see on this type of the vehicle had been used in Canada for more than 1,200 kilometers in one stretch. And it was surveying under the sea for more than 10 days in one stretch. And of course, it is raising up to the point where it can get recharged, because in those days, I'm talking about 90s, there were no way of making high energy vehicles, or the fuel cell technology was still in infancies in those days. At those points, it came to the surface. There were charging stations at every particular waypoints, and it got recharged, and then it continued the mission continuously. So that's how this was proved for long and sustained operations under the ice in almost a couple of decades ago. And now there are many more technologies coming today, high endurance autonomous underwater vehicles, which are capable of putting the vehicles in water for more than 100 hours is under preparation. And many number of days, fuel cell technologies are coming. High energy batteries are coming, lithium polymer batteries are emerging. So there are many things which is happening in the long endurance vehicles have been making between last decade and this decade. And commercial exploitations are happening. And most of the payloads, it takes approximately 80% of assumed duty cycle. with that in mind, if it can cruise at 3 knots speed, we are capable of using these vehicles, which are capable of diving to 3,000, 6,000 meters water depth, operate for approximately 24 to 28 hours, cruising to 150 kilometers in terms of distance. So then we have this unmanned surface vehicles, and this is unlike autonomous underwater vehicle. This is remotely controlled vehicles, and this is not something which is operating in controlled environment or near shore environment. This is meant for open sea. It can work in sea state 3 and 4 conditions. It can even work. It has been tried in sea state 5 operations also. It's from a company called Xploo in France. It has a complete payload. It's unlike the other autonomous surface vehicles. It has a gondola which goes down when it is actually operating. So the performance gets a lot better. The wave parameters affecting the measurements are avoided because it is retracting the gondola by approximately 1.5 meter. You can have AIS, radar, and a camera and lights, and it gets all paraphernalia or otherwise which equipment when you use using a survey-based, vessel-based hydrographic survey, you can get everything in this equipment. You have radio coverage, you have Wi-Fi, you have satcoms and offshore broadband. All these things are feasible. You can fit it with the propeller, and this has a propeller which is a diesel-driven engine, so it can then use 250 liters diesel tank, and so for 37.5 HP diesel engine, and with that it can go for even 15 days mission. So there are systems that can evolve for maybe for 15 days or 30 days mission is being conceptualized at this point in time. So anything what you do with the survey, hydrographic survey vessel, you can do using this type of thing. This is the type of gondola you see, and this is retractable gondola, so you can bring it up and down. This is semi-submersible like this. So this is always outside the water. This is inside. This is skimming, and the gondola is below 2 meters, 1.5 meters to 2 meters below the water line. So then we talk about dipnoi. This is the future of mooring systems. As always said, the efficient application in practice needs careful, innovative design. So you have protective cage. You have when it is surfacing, this profiler is surfacing. It has to have automatic detection systems, and you should have aquadynamic, hydrodynamic structures. You should have very efficient winch system, battery operated, and then you should have the system to go up and down. So what it does is, this is the subsurface platform, which is positioned at maybe around 100 to 200 meters below the surface. And then this is the surface body, which goes up and down. And periodically it comes up, transmits, it takes the profile and transmits the data, and then it goes down. And this is all anchored, and then there's an acoustic release after the period of measurement, maybe typically 2 months to 3 months. You release, and then the whole system comes up, leaving the anchor, and the equipment can be retrieved, redesigned, refitted, and then it can be sent back for the operations. So this is what about it. And then we talk about the autonomous ships. Autonomous ships is the future, basically. And few important companies are working on this. There is a product called AVA from Rolls-Royce, Revolt from DNVGL, and Yara from Kongsberg. And there are many other people who are doing these autonomous ships. See, basically, autonomous shipping is the future of the maritime industry. As disruptive as the smartphone, the smart ship will revolutionize the landscape of ship design and operations, said Michael McKinnon, the president of Marine in Rolls-Royce. So perhaps you can also go to the link and understand more about autonomous ships. Autonomous ships is going to be a disruptive technology. Autonomous ships are going to make the shipping line more autonomous. It can operate with the batteries, and the batteries can be changed by just pushing in and pushing out the containers. And like instead of doing fuel bunkering, you just need to do that. So you don't need to have people on board the ships. You can navigate yourself, and it's all done using the programs and controls. There is no need for people to sit on the ship, but rather they can sit at homes and navigate and control these ships. And now, yes, all these disruptive technologies, directly as we started talking, it brings advantage, it brings disadvantage. It can take off people from the job, but it can also give you, on the other side, if you see, The people need not be sitting in the ships and away from their families. They can sit in the comfort of their office and homes, and then they can operate their ships and do this. So there can be more ships, and there can be more people operating the ships. Of course, there is going to be a balance. And is this balance going to be beneficial, or is going to be otherwise? It will be taken over a period of time. So the future is going towards autonomous ships, and this will be happening. I think as a evolving system, we should also try to embrace and adapt to this type of evolving technology so that we are not undercut. We are well prepared to meet these conditions. So finally, I just want to brief you about Oceans 22. This is happening in Chennai between February 21 and 24. It will be a hybrid conference. This is the first time Oceans have been brought into India, and it is organized jointly by National Institute of Ocean Technology in Chennai and IIT Madras in Chennai. And we have given the website link and also the email. We'll appreciate anybody who is interested to take a look at the website and also get in touch with us. I'm one of the LOC member. I'm the publicity chair for the Oceans 22, and we'll be more than delighted to answer your questions and or to see you guys on Oceans 22. And say, let's start the unknown. Perhaps I've talked about underwater systems and solutions and future technologies and renewable energy. And the company, we represent focus on quite a few of these things, and we are also adapting to many new technologies coming. And we are trying to bridge the technology that is made in Europe and Americas to bring it in India and ensure that we from India can operate for India and also from India to outside countries. So anybody has any questions on any of these things? I'm not very well expert on these things, but we can definitely look at those things and I can address as much as possible. Thank you very much for hearing to me. Thank you.
Thank you, sir.
Thank you, sir. I mean, your lecture, PPTs were so acceptable and lively. Like every slide was giving a life in it. I can see the life in it, and definitely our cadets will take up this, and not only cadets, including myself, being very energetic. I would like to take up one or two projects on this one and start off with some research activities with you, sir, with your help. Really, underwater is something which we have never thought of that depth. Even on board a ship when we go, the underwater inspections, only up to that point only we were thinking. But of course, there was a thought in myself where how these underwater cables are being laid, and so much they speak about India, Singapore, and other places. The cables are laid and it's going on. I used to wonder how this the anchoring is done, and the holding to the the earth soil is made, and all these things. But something great, sir. Hats off, sir. I mean, we have got potential within inland waters also. Sir, I don't know how much of inland waters are utilized for this underwater system, and I think we can do a lot, sir. I think our government is now coming up more and more into inland water utilizations in connecting rivers and so on. And of course, you have spoken about the autonomous. The autonomous ship. Yes, yesterday's program also was that, and it's something great. Of course, though there is a feeling that manpower, we may have a little surge in the manpower, but of course the manpower as we accepted computer, when it came in the year 2000, the same acceptance will be there, and shore-based concerns and other things will develop with latest technologies. For your kind information, sir, I am running a farm for nearly 10 years now. 100 kilometers distance it is, and I switch on and switch off the pumps and valves operations, everything from my mobile phone. Just my mobile phone I'm using. Of course, when initially I brought up this, it costed me a bit of amount, but always saying this is not possible, it will not work out. This man is going to come to us anyway. And on 10 acres land, I have developed very good farm with just this mobile alone. I don't have any manpower inside, just the mobile alone. I do all my 18 valves of operations. The water, the sensors are there. which senses the dampness of the soil and gives me a feedback and accordingly gives me warning messages. It's something great, sir. Thank you very much, sir. We have got a lot to do in this. Sure, we will come back to you more and more, and we have to do a lot of collaborative work, sir. Thank you very much. We will do
Thank
it.
you. Sure.
Thank you, sir. Thank you, sir. Good day, sir.
Thank you, sir. Thank you, Dr. Dinesh Babu, sir. There are a few queries in the chat box. Can you please answer the queries, sir?
Ma'am, I have unmuted them, ma'am. They can ask the questions right now, ma'am.
No.
Sir, Commander, sir.
Oh, sir, you please, sir.
Yeah, very good morning to all of you, and very thankful to Dr. Dinesh Babu, who has talked about underwater vehicles and remote operations. I'm a submariner by profession, and I've been in Indian Navy for more than about 30 years, almost 28 years, commanded conventional submarines operating and underwater vehicles. And I'm very glad that such a topic has come in today for deliberations in this. I just wanted to know about all these developments which are being taken and what is the max cruise depth you can assign, and also how the pressure related aspects are handled for the design of the hull, which you are making it, or it is restricted only up to 100 meter or 10 kg pressure.
You're talking about AUVs, sir? You're talking about AUVs or any underwater systems? Any underwater systems?
Underwater unmanned vehicle which you are.
So we can go 6,000 meters water depth, sir.
Okay, very nice.
We can go 6,000 meters water depth, but as you see from the strategic requirement of the forces, the navies do not go beyond few hundred meters, maybe 400, 500, 600 meters water depth. But that's the strategic requirement for the nations. But for science and exploration and offshore oil and gas, we go much deeper. And you see from the west coast of India offshore and to east coast of India offshore, when we move from the western theater to the eastern theater, we are already talking about thousands of meters water depth. So we need to have intervention systems, like for instance, we put oil structures or oil platforms at thousands of meters water depth. You need interventions to go and operate. So you need a remotely operated vehicle, or you need an autonomous underwater vehicle to go and do the survey. So there you cannot operate out of 500 meters capable system. So you need to have 1,000 meters or 2,000 meters or 6,000 meters capable system. So the capabilities of making systems exist. I mean, the material sciences, you need to choose the right materials, and then you can do it. The typical material used for 6,000 meter water depth is titanium. For 3,000 meters, you can have special steel. And for a few hundred meters water depth, you can go with any other aluminum frame or whatever. So it all depends on materials you choose. India, if you ask, do we have mastery about 6,000 meters? We are getting there. So we will definitely do it. And we can bring collaboration. We can start with it also.
Thank you, sir. Thank you. And another point which I would like to, you might be aware of it, about propulsion, you will be looking at electrical battery related operations. Our Exide has developed indigenized batteries for submarines of Indian Navy. And they have various prototype models which are developed for even underwater vehicles. And to enhance the endurance I'm talking about, you said about 28 hours, speed of 2 knots to 3 knots. That is 1.5 meter per second. Is there any revolution likely to come in enhancing the endurance, sir?
Yes, and thank you for that question, Commander Venkat. Basically, the evolution is happening. Like 24 hours is the battery sizing. Now, you can increase the number of batteries, and that means you need to increase the size of the autonomous underwater vehicle. The more longer you make the vehicle, the more complicated it is for us to operate the equipment. Yeah, like you need more deck space, you need more capable handling systems, and that's where the design criteria comes into play. Now, all these things make a design, a characteristics of defining an element to make the design drawing board to where you need to go down to. So it's not about everybody wants to do like, okay, I want to do 10 days endurance. Of course, there is an RFI, there's a requirement, and make to plan. All this is happening today because everybody else is doing also. And India wants to also fill the gap and not to be left behind. We are also doing high endurance vehicles. And for instance, as we speak, National Naval Science and Technology Laboratory in Vizag, we work with them. We work with them a lot with the AUV group. There's a hydrodynamic research wing, and there's a AUV group. There's a separate team working there, and we have been working with them for more than a decade now, and we've been supplying equipments to them. And we are also looking at getting into the partnership with them as a technology or industrial partner to help with them in integration of these equipments. Because we have now more experience in autonomous underwater vehicles. We've been representing some companies from Canada, International Submarine Engineering, but we are also trying to see if we can bring indigenization of these technologies to the best extent feasible. To answer, NSTL also has a battery engineering division. They have been doing
I visited almost about some 40 times. I have been there. I'm a specialist in navigation as well as weapons of torpedoes.
Yeah.
For indigenous development of torpedoes, I was associated with the NSTL for trials.
Yeah.
In fact, the scientist, we have a scientist from NSTL working in Amit as head of the department for our, Professor naval architect, HODs from NSTL scientist. Yeah, and I have associated with NSTL many times while in active service. And
obviously, Navy has to be associated with NSTL and fuel in the country today.
It is a marvelous. It is seeing is believing. You can't, sitting here to imagine what is happening in the research front. An excellent facility, sir.
It's true. So basically, the batteries matter. The battery sizing is one thing, and then high energy batteries are coming, so that the sizing of batteries are getting compacted, and high energy and packaged for long time is also happening. Lithium polymer is the chosen battery nowadays for manned submersible because the lead acid batteries or gaseous, it can create fumes and it can create explosions. And on submarines also, we are trying to move away from the lead acid batteries to the high density batteries otherwise, so that we can avoid these fumes and explosions. And now we are also moving towards the next level of batteries, which is called fuel cell technology. Okay. This is still evolving. The moment we have fuel cell, it is more like, it's like a nuclear power plant. So it's unlimited. You just need just a fuel cell, and then you can generate power all you want it forever. So that technology is available only with few countries, and then we can take it from there accordingly over a period of time.
Thank you, sir. Thank you for clarification and nice listening to your presentation, sir.
Thank you.
Sir, good morning. I'm Jayasekharan from Petroleum Department.
Good morning, Dr. Jayasekharan.
Sir, very informative presentation. Actually, I wanted to know that ocean bottom seismometer is useful for checking that hydrocarbon prospects, sir.
You can do it basically for it can be used basically. Ocean bottom seismometers have been used for understanding seismics. It can be useful for picking the seismic signals. It can be used for picking the fractures. It can be used for even now we are talking about carbon sequestration studies. So you can have for any applications. It just picks the seismic signals, and then you can plot it, and then this microseismic can be plotted for understanding reversing the petroleum, and then you can map the petroleum well also.
Okay, sir. Many platforms, many offshore platforms posing microbial corrosions and a lot of microbial corrosions. And many platforms there are so many pigments and paints they used to use it. Still, we are facing a lot of problem in that microbial corrosions. That can also be detected?
I doubt. Microbial corrosion studies are done using landers in shallow water environments, but OBS, I doubt, can be used for microbial corrosion. I doubt.
Sir, one last question. Actually, all the oil, almost 1 million barrels of oil daily we are transporting from the offshore platform. Pipeline cracks or oil leakage also taking place. That can be detected, sir?
No, not using OBS. You can do it, but it is highly difficult to predict on a small structure like a pipeline. So for pipeline, you have, depending on where you are measuring, you can employ an ROV, or you can employ an AUV, or you can employ a sort of an inspection system, which can be a diver-based, or it can be a remotely operated vehicle-based system. So OBS for measuring pipeline is something, it may not be commensurate with the type of investments which you will be making.
Thank you very much, sir. Thank you.
Thank you.
Thank you, sir. Thank you very much.
Dr. Saslota.
presentation. Very good presentation. It's an excellent one. It is very useful to all our faculty members, research scholars, even our cadets also. Sir. Wonderful presentation.
Thank you, ma'am. Thank you. Have a great day. Thank you, ma'am.
Thank you, sir. Ma'am,
Thank
now
you, sir.
Dr. Siladas, I mentioned I may have to leave this session now. Maybe I will follow up accordingly. Thank you very much, sir. Thank you very much. Good day.
Ma'am, you can proceed further, ma'am, for the technical session.
yes, ma'am, sure.
So now we will start with the technical session. So first, I request the author of the paper, ICDT MS 0311, with the topic Security Bot Surveillance System using Raspberry Pi. And the name of the author is Mr. Praveen to present his paper.
Session coordinators, you please take over the session.
Arisha, please add smiling madam.
Okay, sir.
Hello, good morning to everyone. Am I audible? Hello?
Yes, sir, audible, but can you increase the volume of your speaker a little more?
Yes. Can you able to hear me now properly?
Yeah. Yes, sir, yes.
Yes.
Thank you.
Okay. Will you please kindly wait a minute? I'll share my screen.
Yes, sir.
Yes. Can you able to see my screen?
Yeah.
Okay. Okay. Yes. Good morning to everyone present here. I am Praveen, currently pursuing EEE final year at JPR Institute of Technology. Thank you for giving me a wonderful opportunity to present my paper in this international conference conducted by Amit University. I'm very honored to present in front of honorable dignitaries present here, and I'm moving forward with my presentation. My project title is Security Bot Surveillance System using Raspberry Pi, and these are our project team members. Our guide is Bhaskaran S. and Sabari Rajan, and myself Praveen, and Praveen Khanna and Pathsarathi SS. Yes. Yeah. An objective of my project is to provide platform for industries that requires inspection and surveillance in hard to reach and hazardous areas, and to reduce the number of trained personnel involved in the security sector, while still increasing the likelihood of spotting a crime or security breach at faster rate, and to detect unexpected dangerous events like fire accidents, gas leakage, high temperature, and electrical short circuits, and to safeguard the property of the industry by altering the registered owner through IoT in case any suspicious moment occurs. And abstract. In this project, we developed a bot which is made using Raspberry Pi through IoT, which an IoT-enabled system to send security alert to the user and register members through email whenever the intrusion detection happens in and around an industry, which can perform motion detection, obstacle avoidance, detecting leakage of combustible gas, short circuit of electrical circuit, and by using camera AI, we can able to detect the person can able to detect the person. And purpose of this robot is to roam around and send information from the given environment to the user whenever any suspicious moment detected by PIR sensor, and the image is captured by the USB camera, and the image is sent to the email notification alert to the user, and also by giving a GSM module, it also alerts through the SMS also. And this robot also uses various sensors that collects data and sends it to Raspberry Pi, which controls the robot behavior along with the obtained image output. User can also obtain the presence of smoke and high temperature using detectors, which could prevent fire accidents. In short, the design system provides security against intruders using IoT platform. And here is a literature survey I took it from. Yeah, first object tracking using security robot. In this problem identifier is surveillance camera is controlled manual, and camera surveillance using Arduino Uno. It uses only one sensor and used only for home automation purposes. And then smart monitoring system through IoT. It sends only the alert SMS to mobile, not the image. An existing system is designed and developed a security bot using Arduino. For transmitting audio and video, RF cam has been used. Only motion can be detected using PIR sensor, fixed in one angle and can move only up to 180 degrees. GSM model used to send alerts SMS. And our proposed system is the system is operated by introducing Raspberry Pi, and I have proposed Raspberry Pi based camera surveillance system because of its performance and power efficiency and interacting with the sensor and other modules. The system is highly scalable to include more sensors and increase the range of the system. Immediate alert through IoT. For transmitting audio and video high resolution videos, high resolution USB cam has been used. Camera can rotate up to 360 degrees, covering the overall areas around the industry. And the camera is monitored using the AI. And here's the flow chart. Yeah. When Raspberry Pi is started, uh, all the sensors are connected to the Raspberry Pi and PIR sensor. PIR sensor will detect the motion. If any motion is detected, even there is no light, camera can't able to see in a dark situation. So for motion detection, we are using PIR sensor. And if motion is detected, immediately the camera has been taken snap using the infrared light and take photos and send email to an user. And camera can also able, if a fire has been detected, camera can able to detect that is a fire, and by using the artificial intelligence, and it will take and snap immediately, and it will be alert to the registered user. And here's the block diagram. At Raspberry Pi, it is a credit card size CPU, which is easily portable. And also it has an inbuilt processor, RAM, and then Wi-Fi, Bluetooth, etc. And it even also having 4 USB ports and then HDMI port like that. So even though it is a credit card size CPU, we can easily power it up using our power bank. So it is easily portable to anywhere. And then motor driver, which is used to control the motor for the movement of the bot. And then by using motor driver, we can able to control the speed of the bot, and the rotation of the bot. And PIR sensor. PIR sensor is a passive infrared sensor which is used to detect motion. Its range is up to 6 feet. And then ultrasonic sensor. Ultrasonic sensor can able to detect any obstacle. If robot is moving, if any obstacle is detected, ultrasonic sensors can able to detect, and then it intimates the bot to turn left or right. And then infrared sensor. Infrared sensor is also for obstacle detection. Why? Even though there is an ultrasonic sensor for obstacle detection, I used infrared sensor because ultrasonic sensor has a blind spot of 2 centimeter. It can't able to. Ultrasonic sensor can able to reach maximum distance of 3 feet, but it having a blind spot of 0 to 2 centimeter. So infrared sensor can able to detect the objects in that blind spot. So I use infrared sensor. And smoke sensor. It is used to detect if any short circuit has happened or fire fire accident has been happened. It can able to detect the smoke and immediately intimate the registered user that it has registered user uh, to inform that there is a fire accident or an electrical circuit accident had been occurred. And DHT11 sensor, it is used to detect the room temperature and also humidity. If there is if the room temperature is very higher, for example, in a server room, we need only minimum degree of temperature. If there is a high temperature, servers will be getting heated and it causes a technical issue. So there might be unsustainable occurrences will occur in the server room. If AC might have been powered off, if anything happens, the heat will be the temperature will be increased rapidly. So the bot can able to detect the temperature and immediately alert the registered user. And if the details have been collected and which is sent to through the mail to the alert user. And Raspberry Pi can able to connect it through the Wi-Fi or for internet, also by using a GSM module like that. And hardware requirements. Yeah, these are the hardware requirements have been explained so far. And then Raspberry Pi 3 passive infrared sensor and webcam, ultrasonic and infrared sensor, DHT11 sensor, smoke sensor, buzzer, lead acid battery, and 12-volt DC gear motor. Now, this is my circuit diagram. As you can see, my brain of the bot is Raspberry Pi. It has been at the center, and two pair sensors have been attached here. And ultrasonic sensor has been at the front, and camera is also be at the front. And infrared sensors, two infrared sensors for detecting the short distance objects. And here is the DHT11 sensor and gas module and motor driver. This is 5-volt voltage regulator has been given, and it is a buzzer and it is a power source for the Raspberry Pi and for all the sensors and motors. This is a prototype design. Can display, and then advantages. They can operate around the clocks without getting tired or needing to take breaks, meaning you can get more reliable coverage when you need it. IoT and AI systems are also be able to rigorously analyze the footage through complex algorithms, allowing them to cache details that the human eye may just miss. The systems also for real-time responsive action, where many times CCTV footage is just used as evidence later. On system using IoT and AI may be able to stop crime while it's happening. Not only the USB cam has been installed, CCTV cameras also, I mean IP cameras can also be able to connect it to the Pi, and it can also be monitored. Uh, the the power of the Raspberries is can able to run all the algorithms. And applications where it can be used is paper industries, cotton industries, chemical industries, or PC manufacturing units, oil refineries, bank security, like that, etc. And future scope is face detection can be added to system which can sense the name of the person with their photo. Like almost everyone else, makers and hackers now use 5.3 boards, the camera of wide range of applications. There are many personal projects being developed to shoot outdoor infrared photos, automatic video capturing, security surveillance applications, and more. Yeah, there might be a question. It can be easily hacked or not. It is difficult to hack because it is running using a Linux operating system. Usually, the Linux operating system is somewhat difficult to hack. So the security is not an issue. And then, yes. And then the bot can able to move automatically or by command from the registered user also. It can work both the ways. And Raspberry Pi 3 packs a lot of power into a small frame that Raspberry Pi has always had. Compared to the Raspberry Pi model B+, this is a processor have been used in Raspberry Pi model 3B+, BCM2835 ARM V6 system on chip processor. The Pi 3 model B has a new quad-core BCM2836 ARM V7 processor, powering a single board computer running at 900 MHz. Yes, and then it provides a real-time video. We will pay more attention to reduce the strong capacity of the SD card. It is wiser to take images when it matches the predefined template using open programs and compress through images and send those images to the web page through GPRS sheet. The programming language used here is Python, and for AI, I used a library named OpenCV. And conclusion. In this review, we have presented a real-time surveillance robot using different system for human-computer interaction, the surveillance robot in context. Also, this paper contains detailed information for controlling a robot vehicle guided via internet. All these techniques can be used in any conditions and areas where it is difficulty for the security forces to reach, can monitor the areas. If you're doing an automation project, you want a cheap, easy solution, you can go. But if you want to build a larger project, we should suggest a Raspberry Pi to act as the brain of the project. It is concluded that the smart surveillance system using Raspberry Pi able to recording, capturing video, image, and transmitting to the smartphone. It is advantages as it offers reliability and privacy on both sides. It is authenticated and encrypted on the receiver side. The user can only able to control the bot by giving his authentication by login and which is encrypted, and hence it offers only the person connected to view the details. Necessary action can be taken in short span of time. In the case of emergency conditions such as elderly person falling sick, military areas, smart homes, offices, industries, and etc. And these are the reference I have been taken from. And thank you. If you have any queries, you can kindly ask me.
Thank you, sir. So participants can clarify their doubts now. The forum is open for questions, so participants may ask your questions if any. Okay, thank you, sir.
Okay, thank you.
So we will move on to the next paper. May I request the author of the paper, ICDT MS 0405, The Evolution of Indian Power Market Chronological Approach, Ms. Anushree T, to present her work.
Thank you, ma'am. Am I audible?
Yes, you're audible.
Okay, I will share my screen. The screen is visible, right?
Yes.
Okay. Yeah. Yeah. Okay, we'll start. So good morning, one and all. So first of all, I would like to thank my guide, Dr. Reshmi Ammar, for consolidating my literature work review. And I would like to thank all the organizers of this conference for accepting my paper. So my paper is based on the evolution of Indian electricity market. It's a chronological approach. So I have used a chronological approach here. So in this paper, I have made an attempt to get an overview of the Indian electricity sector. As we all know, the Indian power sector is gearing up to the competitive regime, and it is attracting as the largest flourished power market. So our government has planned installation of 175 gigawatt of renewable energy by the year 2022, and we have installed around 100 gigawatt of renewable projects as of now. So our government has installed 380 gigawatt of installed capacity in the present scenario. So the executive summary of today's presentation is, first of all, we will go over to the introduction. So in the introductory section, we will cover the regional grids in India, installed capacity, power supply positions, etc. Next is like acts and regulatory policies. What are the electricity acts that are implemented in India? What are the rules and regulations that are implemented in India? Schemes of central government, etc. So next section will be the power exchanges. Here I will talk about the power exchange products of India have different power exchanges, IEX and PXIL. Now third one is yet to come up. So I will discuss about the products of the power exchanges here. The fourth aspect will be the electricity market derivatives and portfolio management. In this part, I will be discussing about the deregulated structure of electricity market, what are the classifications of power market model, ancillary services management, etc. In the optimization of the power market portfolio, I will be discussing about the objectives of the power market trading platform, what is market power, bidding strategy, optimal bidding approaches, etc. It will be followed by short-term power market, what is the scenario of short-term power, what is the importance of short-term power trading and how it is relevant in Indian context, followed by summary and conclusions, novelty and applications of this proposed research work, followed by the references of the section. So we will move on to the presentation. First is introduction section. So as we all know that Indian power grid is divided into 5 regional grids. Before 1991, the grid synchronization started in the year 1991. So actually in December 2030, now it is one nation, one grid and one frequency. So is northern, southern, eastern, western and northeastern grids are synchronized into one grid. These are the peculiarities of regional grid. actually I have listed like what is the peculiarity of northern region. It is a deficit region. Western region is highly populated industrial load, and eastern region is low load with high coal reserves in Orissa and all. And northeastern region is very low load with large hydro potentials, and southern region is high load, and it is almost basically the agricultural load. It is largely dependent on hydro power plants. Now, what is the background of Indian electricity market? So I have taken the source from the Central Electricity Regulatory Commission website. So actually it has captured the information till 2020. So to show the chronological thing, like I have displayed this graph. So it starts from for the growth of the power market over 1 decade, that is from 150 gigawatt, it has moved up to 370 gigawatt in 2020. Now, as for April 2021 is considered, now the installed capacity is 380 gigawatt. Next table shows the power supply position in India. So it shows the requirement and availability with respect to energy and peak demand. So now we can say that the gap between supply and demand is narrowing. So we are experiencing only deficit of 0.5% with respect to energy consumption, and with respect to maximum demand, we are experiencing a deficit percentage of 0.7%. Now, this is the energy scenario in India. So I have mapped the energy consumptions and peak demand have projected till 2027 as a 5-year plan. So what would be the projected consumption of electricity, what would be the projected demand of power until 2027 I have projected. So here we can say that it is increasing drastically from 921 in initial 2016, it was 921 billion units with 162 gigawatt of peak demand. Now while moving to 2026 and 27, we can see projections up to 1743 billion units with installed peak demand of 299 gigawatt. So here now also we can say that like coal is largest supplier. We have 53.1% of coal reserves, and followed by large hydro, that is 12.2%. Now renewable is contributing to around 17% in the Indian power market. So these are the regulatory framework. We will go to Electricity Acts. So Electricity Acts, actually first Electricity Act were implemented in 1910. Actually it regulates a law relating to supply of electricity, then followed by Electricity Supply Act 1948. For it formed the creation of State Electricity Board, then Central Electricity Regulatory Commission Act, that is 1998. So there we established different regulatory commissions, CERC, SCRCs, etc., rationalization of electricity tariff. Then goes to Electricity Act 2003. So it consolidates a law relating to generation, transmission, distribution. So actually new term has come up in the electricity sector, that is trading. So Electricity Act 2003 paves the way to promote the competition in the electricity sector. So now consumer policies are also implemented in
Ma'am, your voice is not audible, ma'am. Ma'am, can you hear me? Okay, I think ma'am has left the session. We'll just wait for 1 more minute.
I think some network issue seems, that's why she left the session. Shall we wait for another 1 minute?
Yes, sir. We'll wait and I'll then start with the next paper, sir.
Smiley ma'am, please text it, not text, just copy and paste the order of the papers, ma'am.
Yes, ma'am, I'll post it, ma'am.
Thank you.
Ma'am, please add S. Vignesh in panel list, ma'am.
Okay, so we'll move on to the next paper. We can give ma'am the option next after this paper is getting presented. I call upon the next paper ID ICDTMS 115 to be presented by Vignesh. for the paper fabrication of wall climbing robot for wall cleaning by negative pressure adhesion method. Please, sir.
Ma'am, he's not having the option to share their screen, ma'am.
Okay. Okay, ma'am, kindly wait. Harish, sir?
I'm already added, ma'am.
But he's not having the
Please,
option to
sir.
share the screen.
Let him check right now, ma'am.
Okay. Sindhuja, ma'am, kindly ask him right now, ma'am.
Yeah, yeah.
Sindhuja, ma'am, is it okay? Okay. Okay, we'll move on to the next paper. I request ICDTMS 304, author Ramamurthy sir, to present the paper on experimental investigation of frictional stir welded dissimilar alloys of aluminium through fugitive entropy gray relation analysis.
Yes, madam, am I audible?
Sindhuja ma'am, you're presenting your paper? Your screen is on.
Hello, excuse me, madam.
Sindhuja ma'am?
I will call her just a minute, ma'am.
Okay. No, you can inform Smiley ma'am because ma'am announced the next paper.
Yes, ma'am, I have announced the next paper, but still.
No issues. They can go ahead with the presentation.
Okay, sir.
Just a minute, ma'am. A small announcement to all the participants. The duration for your presentation is 10 minutes and 5 minutes of time will be given for a query session. Totally 15 minutes of time will be taken for your presentation, including your query. So kindly make up your presentation within that time limit. Please do.
Harish sir, please, I want to see the list of papers, sir, the chat box. Maybe if Shanti ma'am can paste it, it will be helpful. Thank you, sir.
Sorry, ma'am. Sorry for the interruption. This is science phase, so I was presenting the papers. Immediately power cut happened. So Wi-Fi got restriction was there. So when should I continue?
Madam, you please proceed with your presentation.
No, this is not my paper. Like ID 405.
Sindhuja ma'am is not picking the phone also, ma'am.
40.
Ma'am, I think they have muted the thing, ma'am.
I think she is presenting, but voice is not audible. You please inform her.
Mr. Vignesh is presenting, ma'am.
So Vignesh, kindly unmute yourself and start your presentation.
Can you able to hear my voice, sir?
Yeah. You're audible.
Good morning to all. I am here to present.
Go to slideshow, please. Go to presentation.
Okay, sir. Sir, and I am here to present my paper fabrication of wall climbing robot for wall cleaning by negative pressure adhesion method, sir. And these are all the overview of my project. Today we are facing the big challenge of cleaning the wall roof in high buildings, like we are in working places like colleges, companies, wherever we were. It is difficult to clean the roof of the top up, so we can use this project to clean the roof like high buildings, etc. These are the literature survey we are taken for this project, sir. Introduction of this project is, in this equipment we decided to overcome the problem arises in the cleaning of wall by applying the section concept to move that equipment over the wall. The motion of the equipment is performed by a controller after it reaches the wall by cleaning brush with the beginning to rotate by motor, and it removes the dust in the wall. What it means, the robot will goes to the wall and clean the roof surfaces, and these are the it is the diagramic representation of our project. This is the vacuum cleaner or brushes, something the cleaning equipment is fixed here. It is the EDF fan that it is used to stick on the robot is stick on the wall, so that only it is able to move on the wall and clean the surfaces. It is the controller of the wheel and the EDF fan and motor or other cleaning equipments, etc. Components means electronic duct fan, DC motor with wheels, control unit, vacuum unit, chassis for robot, power supply unit, jumper wire. DC motor with the wheels. In this equipment, we are using the wheels like DC motor wheels. The motor is fixed to the wheels so that we can able to control the equipment. This is that wheel we can use it for that robot. Electronic duct fan is used to stick on the wall. It creates the vacuum on the wall surfaces, and it will stick on the wall surfaces and goes to the top of the roof and clean the surface of the wall. Maximum weight is of the ED fan is we are used to in this project means 100 gram of weight is used in this project. Electronic speed controller is used to how it rotates the in which speed we can control on the electronic speed controller. Cost of the speed controller electronic duct fan is 2500. This is the electronic duct fan. It only creates the vacuum on the surfaces of the wall, and it fixes the robot on the wall surfaces and goes to the top of the roof and clean the surfaces of the wall. Electronic speed controller, it speeds the control of the electronic duct fan. In this fan, speed is controlled by the electronic speed controller. This is the electronic speed controller we are used in this project. Arduino is used to move the robot on the surfaces of the wall by the use of Bluetooth module, which is controlled by by our mobile phone, etc. This is the cleaning brush we have used in the wall. Here we can use the vacuum or other cleaning equipments like brushes, etc. Here we are using the brushes, cleaning equipment as brushes. It is the basic model of the wall climbing robot using EDF fan. Here the EDF fan is rotating. When it moves on the surfaces of the wall, it will stick. And the movement of the equipment is controlled by our mobile phone. It is the negative pressure adhesion principle. It creates the vacuum. It sucks the air from the wall. It rotates at very high speed. Like it is like a drone fan, etc. It rotates at high speed. It sucks the air from the wall and creates the vacuum, and it sticks on the wall surfaces. It is the negative pressure adhesion technique formula. How the pressure is in what amount the pressure is should be maintained is what pressure the main pressure is maintained is calculated by using this formula. It is the 3D model. It is the top view. Here we can see all our equipment sets. EDF fan, controller, Bluetooth module, and wheels, etc. It is the right view of right side view, front view. These are all our cost estimation of this project. And this is the model we have created in this project. Here we are using the cleaning equipment, electronic duct fan, LiPo battery, because other batteries are heavier. So we are using LiPo means it reduces the weight so that the robot can easily goes to the top of the roof. Here we are using the DC motor wheels, four DC motor wheels, electronic speed controller. Here you can able to see all. What we concluded about that, the fabrication of wall climbing robot by applying the negative pressure adhesion principle has been performed. In this wall climbing robot, negative pressure adhesion technique is performed by the running the EDF system. The locomotive system is performed by interacting the Arduino UNO, motor driver and Bluetooth module. After connecting this module, the Bluetooth module is paired with the mobile application RC Bluetooth module controller, and the locomotive functions performed so that we can perform this action by our mobile phone. Finally, the cleaning of the wall is performed by the cleaning equipment using the cleaning brush. These are all our reference. Thank you, sir.
Thank you, sir. It was a nice presentation. The forum is open for questions right now. Thank you, sir. We move on to the next paper presentation. I request author Anushree to continue with the presentation on ICDTMS 405, the evolution of Indian farm market, a chronological approach. Please, ma'am.
My screen is visible, right? Hello. My screen is visible, right? Hello. Hello.
Ma'am, you're not audible, ma'am.
Am I audible?
You're not audible, ma'am.
Not audible. Okay.
Anushree, ma'am, are you hearing us?
Kindly increase your volume, ma'am.
Hello. Am I audible now?
Yeah, now you are audible.
Yeah. I'm extremely sorry for the inconvenience. Actually, there was some network
Okay, you can proceed. You can proceed.
issues in my home due to power fluctuations. So sorry. So we were discussing about the Electricity Act. So Electricity Act 1910, 1948, Electricity Regulatory Commissions Act, Electricity Act 2003. Now Indian government has implemented like Energy Conservation Act in 2001. So I was discussing about the Electricity Act 2003. So Electricity Act, like in 2003, we have separate provisions for the generation, transmission, distribution, and trading of the electricity sector. Actually, there are 18 sections in the Electricity Act 2003. Each section describes about generation, transmission, and distribution of the electricity. So we have provisions for the appellate tribunal. So in section 110, so trading also 76 to 77 CERC regulations. Now coming to the regulatory policies, so APDRP, that is Accelerated Power Development Reforms Program. So it was implemented in 2001. So APDRP was implemented to promote the distribution sector in India, to improve the power supply reliability in the distribution sector. Now trading license open access regulations was introduced in 2004. It allows the open access. National tariff policy was introduced in 2006. So it was discussed in consultations with the state government. So REP's rural electrification policy, it was actually for promoting electrification of the rural villages. Now power market regulations was introduced in 2010. So actually this IEX and Power Exchange India Limited come at the year of 2008. So to promote the power markets in India, regulations was introduced in 2010. So ABT is availability based tariff. It was introduced as a 2010 along with the Indian Electricity Grid Code. ABT is frequency based pricing scheme to maintain the grid discipline. So in ABT scheme, we have schemes for energy charge, capacity charge, and unscheduled interchange charge. So IEGC's Electricity Grid Code that was defined in 2010 for the optimal operation of the power grid. So we have separate codes for the planning, operation, connection, scheduling, and dispatch of the electricity. CERC will produce the timely revisions of each of these revisions. Now, these are of India. So UDAY is Ujjwal Discom Assurance Yojana. That is to improve the financial turnaround Discom revival packages for the distribution company. IPDS, that is Integrated Power Development Scheme. It is for the revival of the transmission and sub-transmission, and SAVAG is used for the rural electrification to revive the electrification packages in the rural area. And DDU-GJY is Deen Dayal Upadhyaya Gram Jyoti. It is also related to the rural electrification. The power market design in India. So Indian power market, as I mentioned earlier, divided into two parts, like short term and long term. Short term, it is long term power. Actually, now all the power transactions are happening, almost 9 to 90% of transactions are happening through the long-term power purchase agreements. So long-term power purchase agreement as executed through the PPAs, power purchase agreement. Other mode of transaction is short term. Short term can be divided into different parts like direct, bilateral, traders, exchanges, unscheduled interchanges, etc. Among the short term transactions, exchanges will play a dominant role here. So around 40% of the transactions, 34 to 40% of the transactions in short section is happening through the power exchanges. So exchange, India has two major exchanges, that is IEX and PXIL. So third one is yet to come up. So they are discussing on that. CERC is discussing on that. So exchanges have generally, it is a generic products. Actually, like IEX and PXIL will have its own kind of products like DAM, day-ahead market, renewable energy certificates, energy saving certificate, intraday, any day, etc. Now, actually, Indian energy exchanges taking the leading role. Actually, it has different product other than DAM. Real-time market was introduced in June 2020, and GTAM, Green Term Ahead Market, was also introduced. So actually, now dynamic pricing is becoming more relevant in Indian scenario. Now we will go to the electricity market derivatives and portfolio management. So here we will discuss about the deregulated power market structure. Actually, initially, all the power transactions, or all the power entity in India, actually vertically integrated structure. Actually, all one electricity board will be there. It will be giving, it will be playing the multiple roles like generation, transmission, distribution, and trading. Everything is handled by the state electricity board. After that, deregulation has started coming up. So section become unbundled. So so here, like it will from the vertically integrated structure, we are moving to horizontal. horizontal structure. Now from here we can say that generation, transmission and distribution sector is there. So we can say energy flow, information flow, money flow. So the three types of flows are occurring in this deregulated market structure. In energy flow it is by unidirectional, and information flow is bidirectional. Now the concept of smart grids are becoming more relevant. So money flow is unidirectional. So here deregulation is happening in the Indian power market. So when we are going to the classifications of the electricity market model, it is divided into three types of market, that physical, financial and balancing. So here physical is physical flow of electricity is happening. So we have discussed about exchanges and its products. So here physical transactions of electricities are happening. So high market volume, there price volatility and risk are the disadvantages of this physical market. Financial market, actually here physical transactions are not happening. Actual energies will not be traded in this market. So here we are trading this risk hedging instruments like forward, option and future contracts. Now we will go to the balancing market. It is gaining more momentum. So here we will take care of the generation mismatches. It is UEI market. So ancillary services market are the types of this imbalancing market, balancing market. Okay, now we are comparing this global power market with Indian scenario. Actually max approach and min approach are the two approaches used in US and in Europe. So we are comparing with the Indian Energy Exchange, which is the prominent exchanges in India. So we are comparing the market nature in terms of participation, market offering, bidding type, balancing, pricing, time block and risk management with respect to Indian power market. Now we are the classifications of the electricity market model. Electricity market model can be divided into different classes based on energy trading, contractual model, system operator model, number of suppliers, ownership of the transmission network and time of operation into different categories. So in India, actually TOU is not yet implemented. Our aim is to go for a power market model which takes into account of the value of this transaction based on time of unit pricing, TOU pricing, based on a pool exchange based model. Now, ancillary service management, as explained earlier, it is based on the UI market. So those services are needed to support the capacity and transmission of energy. So different types of ancillary services are there. So reserves is a type of ancillary services. So scheduling, control and dispatch, that operating reserves, reactive power supply control services are a type of ancillary services market. So I will quickly rush through that ancillary services market. So ancillary services market can be classified into three different categories, that is sequential, simultaneous and simultaneous co-optimization. So here in sequential market, so energy market, regulation market, contingency market, each of this market are treated separately. Now while moving to simultaneous market, we are unbundling this ancillary services market from the energy market. So regulation and contingency offer is differentiated from the energy market product, while we are going for the simultaneous co-optimization market, that is the most advanced types of this market. All this market will be clubbed together, that is energy, regulation and contingency offers will be clubbed together in simultaneous co-optimization market. So while discussing about the electricity markets, attributes like forecasting, transmission pricing, congestion management, LMP pricing, FTR are becoming more relevant. So the price forecasting is based on the prediction models to know exact price and demand of at each location. Transmission pricing also, different schemes are there. Like we can, while reading the CERC regulations and all, we can see that like interstate transmission charges, wheeling charges, banking charges, etc. It's different methods for calculations of this transmission pricing. For example, like megawatt mile method, like postage stamp method, or etc. Different types. Congestion management, if you are exceeding the flow limit beyond that ATC limit, congestion will occur in the system. So we have different congestion management scheme. So while going to the locational marginal pricing, so it is like energy price, transmission congestion cost and cost of marginal loss are accounted separately, that is LMP calculation. Our aim is to implement a market model with LMP pricing. So FTR is directly linked to that locational marginal pricing. Here we will treat the contract for differences in terms of the difference in the locational marginal price in the different locations. It can be used as a hedging instrument. So while discussing about the power trading portfolio, the objectives of the trading platform should be we can say that electricity should be treated as a tradable product. Actually, other commodities are trading in the market. Similarly, electricity will also become a tradable product. So we should design a system which is equitable, efficient, affordable. So there should be a provision for the new market participant to enter into the market. Design a market based on the time value of energy concept. That's right, the value of energy that is accounted in the market. So we have to avoid the monopoly should not be admitted in the market. So market power can be measured in terms of different indices like HHI index, entropy coefficient, Lerner index, etc. HHI is a market concentration index. Entropy is directly linking to the uncertainty in the market. Lerner index is also related to uncertainty. So market power mitigation is, it can be done with the demand side bidding of the. So here we can see that bidding strategy. We have to design a bidding strategy that is most optimal. That plays an important role here. So we have to place the bid close to the cost of electricity to maximize profit. So bidding formulation, the game theory, acquisition process, genetic algorithm, different papers are available to design optimal bidding approaches. So now we go to the short-term market. Actually, what based literature survey that I have conducted to define our problem with the help of Dr. Rashmi. So here we will discuss about the short-term power market. So as I said earlier, Indian power market is based on short-term momentum. Short-term is refers less than 1 year period will be contracts less than 1 year period will be traded under the short-term power market. So bilateral transactions, power exchange transactions, IEX transactions are part of the short-term market. In 2019-20, we can say that it is contributing to 10% market share. For short-term power market, we have to obtain certificate for the short-term power market from the load batch center in order to trade the energy to the this as it is, it's a pool. So we have to after obtaining this provisional, final settlement has to be carried out. These are the different stages. With lack of time, I'm rushing through these stages. So we have to go for this short-term power market analysis. So to design an electricity market portfolio, we have to go for this analysis of the existing short-term power market. So we have to go analyze the power sector based on yearly, monthly, and daily trends in the short-term transactions of electricity, and we have to derive the time of day variations in terms of volume and price of electricity traded through the market. We have to analyze the trading margins charged by the trading licenses for bilateral transactions. We have to analyze who are the major buyers and sellers, effect of congestion on the volume of electricity traded, etc. Now we'll go for the summary and conclusions of this. So based on the literature survey, whatever we have conducted, we found that short-term power market is yet to be set up in India. So we have, our objective is to design an optimized electricity market model that has to be built in to enhance the short-term power trading in the dynamic pricing has to be implemented in India. So our novelty and applications of this research work is, so this if we are able to conduct this research work effectively and efficiently, we will be able to address the major challenges in the present electricity sector with respect to price aberrations, open access, electrical vehicles, peer-to-peer energy trading, open access, market economy, market efficiency, etc. So our research will be analyzed. Starting point of our research work will be the static analysis of price and volume of electricity traded in India, which help. So it should first help us to understand the price dynamics from the exchange websites. Later, we have to leverage our research work to build and design an optimized electricity market model to enhance the short-term power market trading. So these are the references. So we started our literature work in 2017. So most of the papers are from 2016-17, and going back to, actually we have taken around 5-6 years literature. So this is recently a relatively new area because exchanges has come up in 2008. So we have referred some of the papers from the IEEE transactions for carrying out this literature. Thank you.
Thank you, ma'am. It was indeed a clear and brief and elaborate presentation. Thank you so much. The forum is open. The forum is open for questions right now. Okay, thank you.
Yeah, thank you.
There's a question in chat box now.
In chat
Yeah,
box.
India has Indian Energy Exchange. Can you explain about that?
Okay, so India has two trading platforms. That is, one is Indian Energy Exchange, other one is PXIL. So Energy Exchange is basically a power trading exchange. So all participants can submit our bids. Generators who wants to sell our electricity in the exchange can submit the bids there, and participants who want to buy the electricity can place their offers there. So exchange, actually there are different types of products for the energy exchange. At present we have a DAM, that is day ahead market. So here in DAM, like it is the basic fundamental product. So here like participants will be allowed to submit the bids for the next day period. So bids and offers will be submitted for the next day, and exchange will calculate some market clearing price based on the intersection. There will be some algorithms running behind that. So exchange will be able to calculate the market clearing price, and they will be publishing these results. So whoever has submitted the buyer can buy this electricity at this MCP and sell the electricity at this MCP. So DAM, it is the functioning of DAM. Actually the scheduling time steady interval will be 1 day for DAM. And so actually in DAM, we will have like 24-hour period. For every hour, this sellers and buyers can submit the bids and offers in the market. So while going to the other product, that is RTM, we can say that in June 2020, like RTM has introduced in the power market. Though here, like we can submit bids and offers in a 30-minute interval. It will be more realistic. So prediction model will be more accurate because we are able to forecast for the next 30 minutes. For DAM, it was for the next day. So similarly for TAM, like that is term ahead market. Up to 11 days period, we can submit the bids and offers. So renewable energy certificates are also there to promote the renewable energy. Actually, SCRC is giving some regulations like RPO. We have to submit we have to produce 10% of our energy from renewable energy. Some states will be deficit, so they won't be having this much of resources. States can buy this REC from this platform. So like this, exchange is a very vast topic. Like we can refer to that IEX website. We will get a lot many informations. So they will give some statistics also how they are traded in the market. Hope that is okay.
Yes, ma'am. We would like to hear a lot from you, but because of time constraints, we are.
Okay.
Thank you. Thank you, ma'am.
Yeah, thank you.
I call upon. Everybody. Yes, thank you, ma'am. I call upon Mr. Ramamurthy sir to present the next paper, ICD-TMS 304, on experimental investigation of friction stir welded dissimilar alloys of aluminium through Tagetti entropy gray and relation analysis. Please, sir.
Yes, madam. Am I audible?
Yes, sir. Anushri, ma'am, can you please stop presenting? Yes, sir. Now you can present.
Yes, madam. The PowerPoint is visible to you?
Yes, sir. You're audible and clear, sir.
Good afternoon to all. I feel very happy to present this in maritime sector industry 4.0. My paper title is Experimental Investigation of Friction Stir Welded Dissimilar Alloys of Aluminium AA6063 and AA2014 through Taguchi entropy gray relational analysis. Abstract of my paper is the present work is to optimize the input parameters and analyze the mechanical properties in the joining of aluminum alloys AA2014 and AA6063 through friction stir welding process. The input parameters which are being considered are tool rotational speed, tool transfer speed, and tool tilt angle. The parameters were designed by L9 orthogonal array settings using factorial design of experiments. The output responses which are being measured are yield strength, ultimate tensile strength, percentage of elongation, and viscous micro hardness. The optimum set of parameters were calculated by using Gray relational analysis with entropy measurement. The importance of each input parameters was evaluated by ANOVA technique. Introduction about friction welding process. It is a solid state joining process that uses a non-consumable tool to join two facing workpieces without melting the workpiece material. Heat is generated by friction between the rotating tool and the workpiece material, which leads to a softened region near the FSW tool. While the tool is transversed along the joint line, it mechanically intermixes the two pieces of metal and forges the hot and softened metal by the mechanical pressure which is applied by the tool. So this is the methodology of my project, of my paper. We have to initially prepare the sample for the experimental work, and then I have the selection of parameters. There are various parameters which can be considered. That is, my consideration is tool rotational speed and tool transfer speed and the tool tilt angle. My process, welding process is friction welding. After the experiments were done according to the L9 orthogonal array setup, I have to go for tensile test and micro hardness test. Through tensile test, I measured yield strength, ultimate tensile strength, and percentage of elongation. Through viscous micro hardness test, I find out the viscous hardness. After getting these experimental readings, I optimized these parameters using Taguchi analysis with the GRA and the entropy measurement, and also find out the significance of input parameters through ANOVA test. In my experimental work, I taken as dimension of 100 into 73 tool steel. I have taken 3 levels and 3 factorial levels. The speed, tool rotational speeds varies from 560 to 900, and tool transfer speed ranges from 120, 160, 200 mm per minute, and my tool tilt angle is 0, 1, 2 degrees. So I find out the experimental setting through L9 orthogonal array arrangement, 3-factor 3-level design, and I am going to experiment 9 set of feedings according to this set of design of experiments. Tensile testing. After the experiments were done, I am going to done the tensile testing according to the specification ASTM E8 by conducting the tensile test in the universal testing machine. The values of mechanical properties like yield strength, tensile strength, and percentage of elongation were found. The readings, the output responses were being recorded like in this table column, and I also find out the signal to ratio using Taguchi method of signal to ratio method through using Minitab software. Taguchi method. Taguchi method is based on design of experiment and orthogonal array testing, through which reduced variation can be achieved for the experiments with optimum set of control parameters. This method is helpful in reducing the time spent for obtaining the optimum values. Signal to noise ratio. There are various types of signal to noise ratio calculation. They are larger is better, smaller is better, and nominal is the best. In this experimental work, all the values, that is mechanical properties like yield strength, ultimate tensile strength, percentage of elongation, and hardness should be in a higher value, that is larger value. So I'm taking the larger is better signal to noise ratio formula for finding out the signal to noise ratio values. Then after finding the signal to noise ratio, my next step is going to Gray relational analysis. A decision finding tools that relies on Gray theory established by Deng is Gray relational analysis. Consequently, there are two different data are available. One is unknown and other is known data. These data are considered as white and black in theory of Gray. Apart from this, there are information that are incomplete in all experiment conditions that are timeless gray. In this study, 4 outputs, ultimate strength, yield strength, elongation, and hardness are maximized for better mechanical strength. So in this gray relational analysis, we have to do the normalization, sequentialization for the output responses we have got. After that, entropy method. The method to compute the weightage of individual quality characteristics, that is output responses, was multiplied with each weight of the quality characteristic was multiplied with gray relational coefficient. The weightage of each response found out are 0.2494, 0.2510, 0.2495, and 0.2501 respectively. This is the table shows the normalized condition of output responses, then sequential values of output responses. Then I find out the gray relational coefficient. Then I found out the gray relational grade, and I ranked the values, output responses from larger to smaller. In this gray relational grade, I find out that the rank 1 comes under the parameters of 710 root RPM of tool rotational speed, 120 mm of minute for tool transfer speed, and a tool tilting angle of 1 degree. The gray relational grade value is the largest value, that is 0.8287. Then I am going to find out the significance of each input parameters in determining the output responses through ANOVA test. The necessity of ANOVA test is mainly to analyze the percentage contribution of each input parameters which affect the output response variables. In this investigation, I find out the ANOVA table for gray relational grade. In this from this ANOVA test table, I find out that 55.51% of contribution is having tool tilt angle is the major contribution. Then comes the tool transfer speed of 25.05% of contribution, and tool rotational speed of 19.06% of contribution. So this is the order. First one having the major significance, that is tool tilt angle. This is a graph showing the gray relational grade with the input responses, tool rotational speed, tool transfer speed, and tool tilt angle. With this graph, I inferred that gray relational grade is increased with the increased tilt angle, but for tool rotational speed, it attains maximum at middle level and decreases to lower value at a higher level. Increasing transfer speed, the grade value decreases initially and increases subsequently with higher transfer speeds. The optimum input parameters for joining dissimilar AA2014 and AA6063 plates are tool rotational speed of 710 RPM and tool transfer speed of 120 mm per minute and tool tilt angle of 1 degree. Prediction of output responses. So I substituted the values of tensile strength at the second level and first level of tool tilt angle. So the value find out is comes 135 meter value, and the experimental value is 134 megapascal. There is a the experimental value with a deviation of 0.09% only. Conclusions of my project: experimental work is done in friction welding of dissimilar aluminum alloys AA2014 and AA6063 to find the effect and importance of input parameters and the various mechanical properties are measured as per the test conducted. The values of optimum level of parameters are identified as 710 RPM, 120 mm per minute, and 1 degree. It gives a tensile strength of 134 megapascal, yield strength of 89 megapascal, elongation of 19%. The optimum parameter setting is applied in the prediction calculation, which shows only 0.09% deviation. ANOVA analysis shows that tool tilt angle contributes by maximum 58.51%, followed by tool transfer speed and tool rotational speed. The friction welding of dissimilar alloys of AA2014 and AA6063 is new and innovative one, and the results over time will be useful for further research. My references are shown here. Thank you.
Thank you, sir. If there are any questions, you can ask me. Thank you all. So I next call upon Mr. Ashok sir to present his paper ICD-TMS 205 Design Modifications of Heavy Vehicle Plastic Component Using Molding Process Simulation. Please, sir.
Madam, I am audible. Hello. Madam, I am audible.
Yes, sir. You are audible, sir.
I'll share the screen, madam.
Yes, sir.
Please,
A minute,
please
sir.
check and tell me.
Yes, sir.
Screen visible, madam.
It is loading, sir. Still not visible, sir. It's loading.
The file size is little bigger because of some animation in there. It's taking time. Visible, madam.
No, sir. Not it, sir.
Oh,
No, sir.
no. There is a message telling that the screen sharing is paused. I don't know what is the reason.
Okay, sir. Can you please come? Can you please come out and again share the screen, sir? Stop sharing and again share the screen again, sir.
Okay,
Now,
okay. Just wait a minute. Just wait. There is a problem, sir. Just I'll share it again.
Yeah.
Smiley, ma'am. Very proud. This is Stalin, ma'am. Am I
Yes,
audible,
sir.
ma'am?
Yes, sir. You're audible, sir. I can see Stalin, sir, also on the screen, sir.
Yeah, thank you.
Madam, my paper is visible, madam. My screen is visible.
Yes, sir. Your icon is visible like marine pollution PPT. That icon is visible. Sir.
Yeah. Okay, madam. Screen is shared now. Now I am open my PPT.
Oh, okay. Sir, are you finding any technical issues, sir?
No, no. Is it visible now?
No, sir. Not it, sir.
Madam,
sir, shall I share your screen?
Yeah, madam. What is the problem?
Participants, kindly.
Now the paper is visible, ma'am.
Yes, ma'am. Yeah. Thank you. Thank you for that.
Continue.
Thank you.
Continue, sir.
Thank you, ma'am.
Thank you, madam. Thank you, madam. Good afternoon to one and all. Madam. So in the today's
sir,
class,
we are here to help. You can
madam,
continue. No problem.
No problem, madam. Okay, I'll okay. In today's presentation, we are going to see about the marine pollution causes and prevention. Myself and Chandrasekhar sir and Elumalai, we are
we are working on this project. Next slide, madam. So the pollution in the olden days is mainly due to the three major pollutions. One is the air, and another is land, another one is water. So if you take previous 200 years back, you may see that the pollution is very little. You see in the air or land or water, the pollution is very, very little. Now, because of this modernizations, like industries and vehicles, household items, and non-degradable item, the pollution is causing. So if you see that before, if you take 200 years back, there is no such no industries, no vehicle like two-wheelers and four-wheelers and household items, because a lot of household items are there, and it is all are manufactured by the biodegradable, non-biodegradable item, especially plastics. That is not at all biodegradable. It takes almost 200 to 300 years for degrading. So once it is very, if it is taking more time to degrade, so it will have a pollution all over the place, like air, land, and water. Next slide, madam. So as I told that it is the pollution is happening all over the places, especially in the land. If you take it, if you take a land, in the land you can see the pollution, solid pollution, and the water, that is a river, that is also because of the sewage. There is a pollution over there. And if you take air pollution, if you take an industry, because of the chimneys, the air is polluted. So these are the main three types of pollution that leads to this, whatever that is there in the seashore. So suppose if you take a Chennai seashore is made up of a lot of solid waste. It is going into the sea. The solid waste lying nearby the sea, or sometime what will happen, the solid waste that is there in the river water, it will go into the sea. And also the chimney, because of the industry, you find a lot of chimneys there. Every industries are producing some sort of furnaces there. So from the furnace, that all the smoke will be generated and spoil all the atmosphere. And this smoke also, what will happen in the sea breeze or land breeze, what will happen? This smoke will go inside the ocean. So these are the three types of major waste that is generated, that is going to the marine. Next slide, madam. So the marine pollution, as a marine pollution, it is a undesirable material. That is the material in the ocean environment, directly or indirectly by the human. So directly or indirectly by the human, that waste is affecting the biological resource. If it is affecting a biological resource or human right, it is called marine pollution. So see, if you see this slide, it is very clearly indicating that the pollution is only created by the human being, not other creature. So the human being is the only source person that is creating the pollution all over the world, especially in the ocean, whatever may be. Next slide, madam. So the marine pollution, you can see, as I told, that the pollution is happening in the land. So in the land, there are three forms. It will have in the, as a river, as a solid waste near nearby river or nearby ocean, or the pollution is happening in the air, that is smoke. So in this, the second part of the pollution that is happening, that is lead to the ocean, is sailing. Sailing is in the marine, it is sailing, oil spill, and ocean mining. So in the sailing, the ship, you can see in the next slide, it's clear picture, I assume. So in the sailing, now in the olden days, they use the coal as a fuel. Now they are using as a diesel fuel. And because of this diesel, we find a lot of smoke coming out of the ship. And you can see in the marine also, the marine, they used to do the mining. So as you know that we are taking petrol in oil countries from the land. So we can take petrol in the sea, as well as you can take a lot of petrols, other minerals that you can take from the seashore, that is beneath of the ocean. And the third picture, you can see in the here, you can see that it is oil spillage. So oil spillage is happening because of whatever the ship. So you can find this oil spillage, a lot of oils are spilling out in the ocean. Okay, this will create a lot of impact to the marine animals. Next slide, madam. So how to prevent the pollution? So pollution prevention is the main thing. You can take as a marine and land are both the same. Whatever happening there in the marine land, it is same like in the ocean also. So you won't feel much difference. Only thing is there, it is water. Here is the land. So the land, how to reduce the pollution? If you attack the land, how? If you know how to control the pollution in the land, you can easily control pollution in the marine also. So there is no much difference. It is especially for marine, we have to do something special to control the pollution, not like that. If you very well know how to control the pollution in the land, you can do same activity in the marine, and you can have a clean marine space. In the land, we can say we can reduce the usage of toxic material. So first, there are so many ways to prevent the pollution in the land. So in the land, we can say we can control by using a avoiding the toxic material. So toxic material, it is better to avoid instead of using and cleaning and again going to back. It is better to avoid. There is prevention to avoid all the toxic material, whether in the form of the fertilizer, whether in the form of any pesticides. So we are using a lot of chemical without knowing the harmful effect. So it is instead of using and then preventing that, you can prevent it at the starting stage itself, avoid all the toxic material. Use the organic material and recycle. We have to recycle the materials such as not biodegradable, and also you can go for a paper or a metal piece or aluminium. So anything we can recycle. So the generation, you have to see that the generation of plastic weight, plastic, how much quantity that is coming out of the house or in a particular industry, we have to reduce that one. Next slide, madam. So pollution preventing in sailing. So as I told that the sailing also, there is a pollution is happening that any ship, it is having a engine having that, because of the running of the engine, you will get a smoke. So this smoke is called emission. That emission, what are the way we can control? We can directly we can see that the alternative fuels. What is there? We are also using the same alternative fuels in the land. So if you take, you can find that diesel, petrol. Apart from diesel and petrol, some places we are using CNG and LPG, like Hyderabad and Delhi. We are using CNG and LPG, and very in the future we are going to very soon. At least I think in another 4-5 years, you can see the two-wheeler vehicle coming with a battery electrical vehicle, and after another 5 to 10 years, the four-wheeler industry is going to be electrical, and then the hybrid. There are so many things, even solar vehicle also. So the final one will be a solar vehicle with a lot of research is going on. So the same way we can apply there in the marine for the ship. Only thing, our vehicle is very small. If you take a ship, it will be very big, like it will have a 4-5 times or 6 times of like a LIC building, 6-7 times. So only thing the quantity will vary. Next slide, madam.
So, sir, sorry to interrupt you. Almost it's time, sir. Could you just close it by soon, sir?
Yeah. Another
Still,
2 slides, sir.
Still more participants are waiting over here.
Yeah, sir. I'll finish it in another 2 minutes.
Yeah.
So the million tons of garbages and wastes are produced. So every day in the ship. So shipping is one of the industry. So in the industry ship, you find a lot of waste. Millions, tons and tons of waste are produced. And how to control that? So how to control the wastage in the shipping? Next, madam. Next slide. So the overseas shipping industry, to how to control this waste generated by the ship, how to control it. So controlling is done by international law. We have to obey the international law. So it is not because it is covers a whole nation, a whole world, so multi-nation. The water shares to multi-nation. So everybody will worry. Something happen here, it will affect Singapore or nearby China and other place. So there is an international law. We have to obey by the international law and the garbage management plans. Every ship should have a garbage management plan. So in order to reduce the waste, so every year we have to reduce the waste. Every decade we have to reduce the waste. Suppose last year we make a waste of 50-40 tons. This year we have to bring it to 2-3 tons. Like that, we have to make a plan and then we have to go further. Next slide. So this is almost over. Only one slide is there. So seafarers should be active in effective shipping operation and reducing the garbage. That's what I told in the last slide. And the waste material like plastics, metals, glass, batteries, medical waste. So many this type of waste you should not scrap it in the river or in the sea. So this will give a harmful effect. So whenever the ship reaches the shore, there you can dispose with what are the guidance will be there. So according to the guidance, you have to scrap this material in the shore side. Next slide. So food waste, you can discharge the food waste in the sea. There is no problem. It's not harmful. If you have a food waste in the whatever the coming out in the kitchen and whatever the after dining, you can directly discharge in the sea, no problem. And oil waste and sludge cleaning. So oil waste and sludge cleaning, we have to take some preventive action to make it environment friendly and then dispose in the sea. Next slide, madam. That's all. So reducing. So as like there is a quality management system that is QMS. Like that, there is a system called environment management system that is applicable for all the industry. It is applicable for any ships or the vessel what we are using, and it should be obeyed by this system. Thank you. Any doubt you can ask.
Sir.
That's all, madam. Tell me, madam.
No, sir, I don't have a doubt, but what is actually the objective of this paper, sir?
The objective of the paper is what is the recent trend to prevent the pollution, prevention and the pollution.
Correct, sir, but no, is it based on any survey or basic informations?
It's based on the survey, madam. Survey. How much is what are the system they are going to introduce for prevention of pollution? What are the system they are going to implement in the management, environmental management to control the pollution happening all over the ocean and marine, ship and other what is the nearby seashore. The future, what will the type of fuel is going to come? This is about this paper.
So it is like one awareness concept, correct, sir?
Yes, madam. It's awareness and the future, how it will be affect the. It is a paper to create awareness about the marine pollution.
Okay, sir, got it. Thank you.
Thank you, madam.
Good afternoon, sir. Sir, this is Talil, and I also have a question.
Tell me, sir.
You have taken the service based on the passenger ship or the cargo ship?
Passenger ship or
cargo ship, sir?
Sir, see, it's not a question about cargo or passengers, sir. It is a question about how much pollution it is creating. So suppose, sorry, obviously you're telling what is the point is correct, because there is a difference between cargo and passenger. Almost you know that very few are very passenger, negligible. We can tell nobody is traveling in the sea for a long distance. Even if it is a common, sir, it is a common for passenger or whatever the cargo, but the wastage will be more in the. I feel it is more in the passenger, because the passenger, as I told, the human being are creating a lot of pollution. So they will create that whatever the pollution will be more in the passenger compared to cargo.
Yes, sir. Thank you, sir.
Thank you,
sir. Thank you, sir.
Thank you.
I call upon our next author, Ms. Sindhuja, to present the paper ICD-TMS 406 on clock pulse micros level shifter design for system on-chip applications. Please, ma'am.
So, very good afternoon to all. Myself, S. Sindhuja, Assistant Professor, Department of Marine Engineering. I'm at deemed to be University. I'm going to present the paper on clock pulse energy efficient level shifter design with empty CMOS technique for system on-chip applications. And these are the content I'm going to present, and my objective of the paper, I'm going to do it by using empty CMOS technique. So we can minimize the leakage power, we can increase the speed of the level shifter. So the level shifter circuit is added between two components, two circuits. Okay. So they are transferring, the level shifter is used to transfer the low level to high level and high level to low level. So in that level shifter, we are using empty CMOS technique, means it can reduce the leakage power. So the overall power consumptions of the level shifter will be optimized without affecting the conversion speed of the level shifter circuit. So in our paper, in system on chip, why we go for system on chip applications means, so in any electronic device, we have many modules. Okay, so all the modules no need to require the same power. Okay, so every modules have a different power. So system on chip, all components of electronic system in a single chip. So we can go for the voltage islands. Each module have different voltage. So then we go for a voltage island. So voltage islands scaling to meet the power and energy requirement for each and every modules. So increasingly we can use it in many applications. Okay. So multi-supply voltage domain. Okay. So multi-supply voltage domain means, okay, so time critical domain, we can divide in time critical domain, non-critical domain. So time critical domain means we can have a higher power supply voltage for some of the modules and lower power supply for some of the modules. For example, if you take any laptop or if you take any cell phones, we have different modules. No need to require same power in all modules. So we can divide the time critical, what are all the time critical domain and what are all the non-critical domain. So we can apply the multi-supply voltage in the circuit. We can apply the multi-supply voltage. So differential voltage domain communicate with each other. Okay. The next, the problem of without level shifter. If you don't have level shifter, what are all the problems we face? If low voltage directly drives the high VDD. So voltage translation, we can have some translation mismatch, and also we can have some more leakage. So we have some low speed. So that's why we go for the level shifter circuit. An efficient level shifter circuit, it requires interfacing these voltage, all these voltage domain. The level shifter interfacing or connecting all these voltage domain. So it should be fast and consume low power. Okay. Then these are the literature surveys I have made, and what are all the, I don't have time to explain all those things. I just explained what all the modules are used in these literature surveys. The first literature surveys, they are using a logical error correction circuit, logic error correction circuit. They are using a low voltage level shifter with low voltage. They are using module with logic error correction, and low level error corrections, high level error correction, they go with error correction circuit. And advantages and disadvantages. So this disadvantages of this paper, the implementation problem, routing multiple supply voltage, there is implementation problem is a, and delay overheaded is there, and the lack of design tools is there in this paper. And the next paper, the literature survey, it's a cluster voltage. They go with a cluster voltage scaling. They are using a flip-flop for level converter. So it minimizes energy delay penalties due to level conversion. The based on the circuit, they implemented with single supply, the pass transistor, and the pre-charge circuit. And disadvantages of this paper is a reduction in supply voltage and is applied only with circuit outside critical paths. Okay. And save power without sacrificing through the throughput or latency. And the next literature surveys, they are using novel level shifter circuit. They are using only half latch circuit, and they supply voltage 100 millivolt to 1 volt. And the drawback of this paper is circuit increasing static power dissipation. It goes with the propagation delay, does not scale well. Okay. And next paper, they use for multi-supply voltage scaling algorithm. They used a greedy approach and entered improvement optimization approach. They are using data path operations, dual path operations on a single supply voltage and single frequency, single supply voltage, multiple frequency, multi-supply voltage, and dynamic frequencies. So this disadvantage, they are using dual supply voltage. Okay, the total power consumption is only 28%, it shows. Okay, I'm using a differential level shifter circuit. So differential level circuit is a differential cascade voltage level shifter. In my paper, they are using differential level shifter circuit. I just explained the differential cascade voltage switch. Here there are two circuits. I'm connecting one level shifter in between these two component. So I'm connecting the inverter in the input side. I'm connecting one inverter, and output side I'm connecting the inverter. I just connected connected the level shifter circuit in between these two components. So for example, I will explain with some logic level. Suppose if it inverter, inverter output is 1, I'm applying the low level logic 0. So automatically the inverter input inverter is 1. The same 1 will be applied to the MN3, okay, transistor. So the output of the MN3 reaches to MP2. So automatically the MP2 is turned on. Here the 0, here the input of the inverter, the value is 0, output of the input inverter is 0. The same output value is given to the 0 is given here. MN3 0 is given, means here MP2 is turned on. Okay, here the input is 1, logic level is input is 1. I'm applying the same input is applied to MN2. So the transistor is in on condition. If the transistor is in on conditions, automatically the MP3 is turned on. Okay, it's like that, low level to high level. The same here, 0 volt, 0 here. If it is MN2 is off condition, the same 0 is applied to the output of the transistor. Automatically you can get the output value 1. Okay, so here why we are using the level shifter means it's balancing the circuit, it reduces power consumptions because of this cross convention MP2 MN3 and MN2 MP3, because of PMOS transistor and MOS transistor. It's balancing the circuit. Okay, balancing the power. Okay, and so I'm going to introduce the empty CMOS. In that circuit, I'm going to introduce empty CMOS. Here I'm introducing the empty CMOS. Here MP4, MP5 is empty CMOS, multiple threshold voltage domain. So it pulled down the, if you are applying a different voltage level, it's pulled down the voltage, because empty CMOS is a high threshold. Okay, to balance the same logic, I will explain the same logic. So input is 1, input is 0, or output is 1. I'm applying low level voltage, low level logic 0. Output you can have 1. The 1 is same applied to this AN. Here the 1 is here the output of this inverter, because the two this is PMOS transistor and MOS transistor. Output is you can have 0. Okay, if it is 1, it's 0. This is 1. and one is applied to AN. The same, the low level, again we can have the low level. Low level is applied to the MP4 transistor. The transistor, this empty CMOS transistor is in off condition. Okay, and automatically MP5 transistor is in on condition, because here the A is applied. Already we have applied 0 level. So 0 level voltage is applied to A here. Here output you can have 1. So 1 is applied to the MP5. Automatically the transistor is in on condition. Okay, the same voltage, the same output will only it passes to the MP2 as well as the MP3. Okay, here it balancing the circuit. If there is any leakage between MP2 and MP3, if there is any leakage, the empty CMOS transistor will reduce all those leakage. Okay, so that's why we are using this technique here, empty CMOS technique. And so in problem formulation, we had done conventional circuit needs operate steadily, because of it dissipates static current. So it can increase the power dissipation. Existing proves impractical to use. Okay, design of level shifter in difference. I'm going to design this level shifter with a different circuit. Okay, here additionally I'm added one flip-flop circuit. I'm using with multiple level shifter and single supply and multi supply. Okay, these are all my a level shifter design by I'm using in Cadence design tool. I'm designing this kind of circuit. This empty CMOS circuit, and this is the level shifter. This is input and output. Okay, this is dual supply. I'm connecting supply here. So input, the transient input, these are all the input, and output we can have the different level supply, different stage of level. We can have the different output. Okay, and time delay we can, I'm calculated. This is the calculations for time delay. And and the flip-flop, I'm using flip-flop circuit. In between a flip-flop circuit and inverter, I'm connecting these level shifter here. And multiple, I'm using different level shifters. I'm using different level shifter. This is a part 1 and part 2 and part 3. And the power analysis, I can have the power analysis. So we can, the power prediction, the single supply level shifter, I'm using 1.5 millivolt, and single supply level shifter with flip-flop circuit, the same 1.5 millivolt. Multiple level shifter with the multi-supply voltage, we can have 320 microvolt. Okay, that's all. To present, is my conclusion, energy efficient level shifter suitable for robust logic voltage shifting between two voltage domain, exploits proper design strategies to limit static power dissipation. So these are all my reference. Thank you.
Thank you, ma'am.
Thank you.
So as the time is short, we are going to go with the last paper to be presented. I call upon Mr. Stalin sir to present the paper ICDTMS 418, ripple analysis of FLC based DCFC. Please, sir.
Yeah, thank you, ma'am. So, yeah, ma'am. So very good afternoon to one and all. So myself, Stalin, and my authors are Mr. J. Harish Kumar, Mr. M. Vimal Raj, and Dr. M. Kamila Rishi. And my paper ID is ICDTMS0418. So this paper particularly based on the ripple concept. So what is ripple, and what is the fuzzy logic controller that is used here, and we are going to discuss about the boost controllers and the fuel cells. So the paper title is Ripple Analysis of FLC based DCFC. So where FLC stands for fuzzy logic controller, and BCFC is boost converter in fuel cells. So in this presentation, so we are going to discuss the comparison of fuel cells, and we'll be listing the working of operation, and we'll be discussing about the boost converter, and under continuous mode and in discontinuous mode, and we'll be discussing about the fuzzy logic controller with the boost converters, and we are going to compare the 5x5 fuzzy rules and 7x7 fuzzy rules, and we are going to predict which would be the better for this converting. To the abstract, so we are going to use the source of energy for the DC-DC converter is the PEM, that is the polymer electrolytic membrane So that is the fuel cell we are going to use here. So the reason for using this PM is it has got high power density and also it has got less emission, almost to zero. So this makes it as a very good source of energy for the fuel cells, and also it is renewable, and also at the same time it is going to be a sustainable power source which can be generated from other solutions like formic acids and from hydrogen fuels and from ethanol we can able to produce this the supply for the fuel cell. And the next thing is the fuel cell FC corresponds to fuel cell. This is going to be high efficient where the power supply design is having the DC-DC converter, that is direct control and direct control converter. And also in this paper, the characteristics of the various types of fuel cells are studied, and also we are going to use the various control techniques. So the control techniques is PI techniques and PID techniques. So that is nothing but a proportional integral control and the proportional integral derivative and FLC controller. So these are the three types of control techniques that are being adopted in this paper. And also I was talking about the fuel cell. So the fuel cell is based on the polymer electrolytic membrane, or sometimes it is called as proton exchange membrane. So in the boost converter. So ripples. So what is a ripple? So it is nothing but the periodic variation of the DC voltage within the power supply, and it will be repeating at regular intervals. So therefore, the source of ripple is going to be generated from the PEM. And also, we are going to compare the fuzzy logic based on 5 cross 5 rule and also 7 cross 7 rule. So already the papers are in 3 cross 3. In that also, it has been revealed that the 5 cross 5 has better output voltage when compared to 3 cross 3. So that is what we are going with directly 5 cross 5, and then we are going for 7 cross 7 rules. And also the validation of the modeling and simulation of the polymer electrolyte membrane fuel cell based on the boost converter using the MATLAB Simulink and Fuzzy Logic toolbox. So introduction. So as we all know that the major power sources in aircraft or in any airport utility vehicles and in some industrial areas and in vehicles, nowadays they are being replaced by fuel cells because of its high energy production. At the same time, it is going to be zero emission, and also it is working at very low temperatures. So it will not get heated up. So that is the main reason for replacing the main auxiliary systems, which is in electrical format, are going to be replaced by the fuel cells. And also there are various types of fuel cells are available, out of which we are taking the polymer electrode membrane fuel cell because of its very good efficiency, and also it is going to have a very quick response to the voltage changes, and also it is going to have high power density, and also the improvement of the output voltage of this polymer electrolyte membrane fuel cell is achieved by implementation of the fuzzy logic controller control system. So as I mentioned, the control systems can be PI method and also by PID, that is proportional integral and proportional integral derivative. Out of all these things, the fuzzy logic control system is being used and it is showing better result when compared to that. And also in the FLC, that is fuzzy logic controller, we are going to use the Gaussian type membership. So the reason for using this is, so this Gaussian type has got very smooth curves, and also it is going to have good noise reduction in that. So that is the reason why we are selecting the Gaussian type. And also we are going to use the maximum minimum interface method and centroid method. So we'll be discussing where we are going to use all these things in our fuzzification and defuzzification. So fuzzification, it is nothing but a process of converting a crisp input to the fuzzy value. So that is, even though we are going to have many inputs, in that which is the most suitable one that will be selected by the fuzzy logic controls. So this is a comparison between the fuel cells, and what makes me to select polymer electrolyte membrane is, so it has got a good power output, and also the working temperature is less when compared to the methanol type and alkaline type, and also the phosphoric. So these are high voltage DC fuel cells, so which is not suitable for our operation. So we are going to go with polymer electrolyte membrane. So you can able to see that the cell efficiency is 50 to 60%. So because the reason is it is going to work under very less temperatures. So this is the construction and operation of the fuel cell. So as we all know that the fuel cell has got two chambers. In one chamber we are going to have the anode, and then in another chamber we are going to have the cathode. And here we are going to use the solutions as formic acids, methanols, and we are going to use the what is that? So hydrogens. So these are used as the fuels for this fuel cell. And when the reaction is taking place at the cathode and anode, we are going to continuously produce hydrogen and the other ion. So the ions will be attracted towards anode, and that will be given as the output, and the hydrogen will convert it into water, and that will be getting out from the fuel cells. So this is a boost converter. So as we all know that the boost converters are useful for stepping up the input. That is, the input voltage is going to be an DC voltage, and that will be step up. So it will be acting as a transformer. And here the DC to DC power conversion is possible, and also it will step up whatever input is being received at the receiver end. So the input is being given by the fuel cells. From the fuel cells, the electron will continuously get discharged, and that will be connected here. And because of the stability and for boosting up, we are using this booster converter circuit. And this is the continuous mode and discontinuous mode. So where you can able to see that in continuous mode, the pattern is not a zero value, and here in discontinuous you can able to see that always the input current is starting from zero, and it is falling to zero, and once again it is starting from zero. So because of this, we are going to use the continuous mode booster converter. So this is the operation of our FLCs with the boost converter. So this block diagram will explain how the fuel cell is going to produce the required energy, and they are going to be boosted up, and it will be used for the applications. And here we are using the fuzzy logic controller. So this will maximize the number of output that is going to be obtained. And here we are going to use the linguistic variables, that is the variables which are going to be used in the fuzzy logic controller. So that is the error changes are going to be from negative large, and the negative small, and the negative small, and the negative big. So there are, since we are going to use 5 linguistic variables, it will be starting from low, very low, high, very high, and an average, or it is sometimes called as zero. So these are the various variables we are going to use in the fuzzy logic controller. And based on the simulations, we have obtained certain results for the membrane function of the 5 values, which is B negative, that is the change of error, which is in negative big, and the S negative small. And based on the membrane functions, we have got 5 functions, and also we have got 7 functions. And this Gaussian curve will be very smooth. And here you can able to see that for the input, we are going to have a reasonable output, and this is the boost converter output. So when the input is not used with the boost converter, this is my membrane function output. And if I'm going to use a boost converter, then the output voltage is drastically changing. So this is the fuzzy rule which I have followed in this paper. So here you can able to see the member functions. We have taken 5 linguistic variables from a small value from a medium value, and this is the average, and it goes with high and very high. So based on this fuzzy logic system, we have got certain outputs, so that you can able to see here that in the ripple, as I told you earlier, so the ripple calculations are being made by comparing the outputs without the controller and with PI controller and PID, that is the proportional integral controller and with proportional integral derivative controller. So here we are just making a comparison how the ripple calculations are based on the boost converters. So you can able to see that when we are using the boost converter without any controllers like FLC or PID and PI, we are going to get it as the 0.9 voltage. So similarly, you can able to see this is not 0.9, it is 0.19, and then if I am going to use PI, it is going to be 0.05, and if I'm going to use PID, that is derivative based boost converter, it is getting reduced. And if I'm going to use FLC, it is going to have much reduced. So that means the ripples, that is the periodic variations, are going to be minimized. So therefore, it shows that when we are having less variation in the DC voltage, therefore we are going to get a good output. So likewise, we have calculated for the input current and also for the inductor current. So from this table, we can able to observe that the FLC based boost converter is performing better, and also here the periodic variation is minimized, and also it has got less noise. So this is the simulation results which has been obtained from MATLAB Simulink software. So based on the boost converter output and boost output voltages and the input current ripples, so we can able to see the simulation results. And so here we are just comparing the 5x5 rules with the implementation of the FLCs with 7x7. So as you all can see, apart from the low value, that is average, we are going for the low values, and also we are going for higher values. So low, medium, and high. Similarly here, low, medium, and high. So this forms the 7x7 rules, and in this also we can able to get better output fuel cell voltages. So from the comparison, I can able to see that the 5x5 has better advantage when compared to the 3x3 rules. And from the literature survey, it has been understood that the 5x5 is better when compared to 3. So in this paper, we are just going one step ahead with 7x7 rule, and we are calculating the same ripple comparison, that is the disturbances or the periodic variation. So when we go for higher and higher rule, that is the fuzzy logic rule, we can able to produce less variation in the output. So therefore, from this we can able to understand that the 5x5 when compared to 7x7 is performing lower. That means the variation will be less. Similarly, if you use 7x7, that is going to give a better output. So to the conclusion, we have done this study based on the fuzzy logic control system using the MATLAB and Simulink software. And the output voltage, the input ripple, and the inductor currents are compared with 5x5 and 7x7 fuzzy rules. And out of this, we can able to come to a conclusion that when we use fuzzy logic with linguistic values 7x7, the fuzzy rule system has better control technique to control the output voltage of the polymer electrode membrane fuel cells based on the boost converter. So I have not shown any reference. So thank you. And if any queries is there, you can please post.
Thank you, sir. Thank you, participants, for your patience. We will now break for lunch, and we will again join in the same Zoom link by 1:30. Thank you all.
Yeah, thank you, ma'am.
Thank you, madam.
sir.
Thank you, madam.
Thank you. Thank you, sir.
Thank you, sir.
Thank you, sir.
Good afternoon to all.
Good afternoon, ma'am.
Yes, ma'am.
Good afternoon, ma'am. Good afternoon.
Good afternoon, Harish. You please check whether Motion Raza is joining.
Yeah, I'll just check it right now.
Accordingly, you please add him as panelist.
Sure, sure. Sir is it now?
Welcome, Dr. Moshin Raza from your.
Hello, good afternoon.
Good afternoon. How are you?
I'm doing fine. How are you?
Yeah, we are all fine here.
How's the session so far?
Yeah. Organizers, could you please start?
Sangeeta ma'am.
Yes, sir.
Please, ma'am.
Good afternoon to all. Now we will have the technical session for track 5, industry automation. And the keynote speaker for track 5 is Dr. Moshin Raza, Department of Computer Science at Edge Hill University, England. Sir, we are very overwhelmed to introduce you as the keynote speaker of this particular track, industry automation. Dr. Moshin Raza obtained his undergraduate and post-graduation in electrical and electronics engineering from Muhammad Ali Jinnah University, Islamabad. He got his doctoral degree in wireless networks from Northumbria University in 2018. Dr. Moshin Raza is currently working as senior lecturer in Department of Computer Science at Edge Hill University, England since July 2020. He also served as lecturer in Northumbria University, England from November 2019 to July 2020. He was research associate at Middlesex University, London, and his research work involves 5G communication systems for safety and emergency services for a period of January 2018 to November 2019. He worked as lab administrator and associate lecturer in Northumbria University, England from August 2016 to December 2017. He worked as lecturer and also a joint lecturer at Muhammad Ali Jinnah University, Islamabad from November 2010 to October 2015. He also worked as a hardware support engineer at Unified Secure Services Private Limited from October 2009 to November 2010. I now request the keynote speaker to address the gathering. Sir, please.
Hello, everyone. First of all, I would like to thank you for a very detailed introduction, and I would like to thank the organizers for putting together such an event and providing me the opportunity to speak to all of you, the panelists. Thank you for joining, and all the participants. So I hope this would be something that would interest you. So I will try to share my screen. And we'll continue with the discussion on industry. I have been working on Industry 4.0 related solutions for past 8 to 10 years. And I will try to encompass some of the projects relating Industry 4.0. So I believe you can see the slide.
Yes, yes, sir.
Okay, so the topic I will try to cover is industry automation, the pathways and enabling technologies for Industry 4.0. I have given my email ID here if later on anyone would like to contact me. Okay, so when we are talking about Industry 4.0, so we definitely kind of looked for a vision for this one. And the vision is basically to kind of look for a solution for. Are the slides moving all right for you? Are you using, just to confirm, are you looking at the main slide?
Yes, sir, it is visible, sir.
Thank you very much. Thank you. Okay, so when we are talking about Industry 4.0, so we definitely look into a futuristic technology which is kind of dealing with the industrial automation in a way that we have cyber physical transformation of the industries, so that we have automation of each and individual part within the industry. And we are looking towards an automated process which is capable of handling all the aspects of manufacturing, process control. And with respect to that, it is, when we are talking about Industry 4.0, we are talking about the connected manufacturing, and we are talking about the intelligent systems. So Industry 4.0 is basically envisioning the scope where we have an industry which is capable of not seeing one particular operation and optimizing that, but rather it is seeing the entire pipeline of manufacturing and transforming that pipeline into an effective, productive environment. So how different pipeline entities, different blocks within that pipeline can be optimized to offer more productivity, higher efficiency, and how we can use those to produce a system which is capable of not only giving us higher outcomes, but also predicting any downfalls in the future, any maintenance in the future, and preemptively adopting within the changes which are happening within the industry. So when we are talking about Industry 4.0, we are basically looking at the digital transformation, self-sustained manufacturing. We are looking at the predictable environment. We are looking at a fully connected manufacturing, which is capable to analyze one part and the other and correlate how to optimize the pipeline, how to optimize the manufacturing. So this is the basic vision for Industry 4.0. And it is a very interesting idea, and there are work going on to actually achieve an industry which is capable of doing all this. But reaching here was not an instant leap. Rather, we started from very basics and we gradually moved further. So what paths we have taken to actually reach to Industry 4.0 and the developments that are currently going on. So what I will try to do is just cover some of the aspects which define the pathways that are being taken to reach where we are at the moment, and what kind of developments are going on within different research groups, within the industry, and how these are working towards realization of Industry 4.0 and the optimized industrial optimization. Okay, so when we talk about the industrial revolution, it's quite similar as the wireless communications, to be honest. So if we think about wireless communications, the first thing that comes to mind is basically fire, because in the earlier times, we kind of managed to use fire to communicate information over longer distances as a signaling or in other ways of communicating. One such representation is basically the Wall of China, where what we are trying to do is, or where they try to do is to communicate any kind of attacks by lighting up different towers and then propagating that information across the wall to just preemptively inform those who are not viewing any attacks. So this was very initial steps towards the communications. Later on, we kind of developed the lighthouse, we developed the Morse code, considering that all of these kind of mainly worked on the communication, a very preemptive communication. And when we look at the milestones, we realize that Marconi actually established a transatlantic communication from Cornwall across the Atlantic Ocean. And we see that this was a major milestone because the Atlantic Ocean was thought that it would be not possible to communicate across Atlantic Ocean. But this was a major milestone. But it required very high-rise transmitters and some very high-powered generators, massive generators just to do that. Now, the world has transformed into something where you can pick up a phone and you can call anyone anywhere in the world. And this is how the technology has grown over the years. When we are talking about the industry and industrial revolution, we see that it kind of began in a very similar way because we are looking at an environment which was trying to do the very exact thing, trying to relax the effort that was put by manpower, by the efforts that was put in to the system, by inventing the mechanisms which can actually do the heavy lifting. And it started with the first industrial revolution, which is attributed to the steam-based machine, which kind of helped in some mechanisms to actually speed things up. Later on, we kind of managed to transform all that steam-based energy into electrical mass production. And that was basically what the second industrial revolution was, where we included a lot of human beings to perform the tasks that we wanted to do within the industry. But we also kind of managed to establish certain pipelines so that we have mass production, and all the power needed for this work was kind of provided by the electrical, thanks to Edison and Tesla and their efforts in kind of developing the DC and AC powers and so on. The third industrial revolution, which kind of lasted quite recently, and quite a lot of industries currently kind of work in a similar environment, where we have used programmable circuit boards, we have used application-specific integrated circuits to build small optimized processes. And these small processes are capable of performing certain activities repeatedly with high efficiency. And we have microcontrollers, microprocessors, where we are integrating different parts together. And this was mainly a computer-based automation, which came later in 20th century, and that was the third industrial revolution. Now, when we are looking at the next step, so basically what we have achieved so far is an industry which is capable of doing small processes very effectively. We have machines which are capable of performing repeated tasks, and they perform these repeated tasks with much more efficiency, much more accuracy. We do have certain pipelines where the communication, where the processes, manufacturing processes are carried out in different steps, and each step is performed by machines. There is some human intervention still present within the industries at the moment, but quite a lot has been moved to the automated processes, which are developed with FPGA, ASIC, microcontrollers, microprocessors, and some sort of processing mechanisms which can actually decide how to perform the activities more effectively. And there are certain optimizations to these. Now, when we are looking at the next generation of industry, we are definitely looking at something which is not only capable of optimizing individual processes, but can optimize the entire industrial infrastructure. So first things which comes to aid this kind of a revolution is the communication of different sensors, the information that is being produced. Because whenever we look at a process and we think that how this process can be optimized, the first thing we need is the information. So the IoT, Internet of Things, is one of the key enabling technologies which can enable the realization of Industry 4.0. Similarly, the artificial intelligence, because when we look at the previous generations, they are no doubt doing operations which are repeated, which are efficient, which kind of have certain preemptive measures, which can deal with certain known factors. But when we are talking about artificial intelligence, we are talking about embedding a mechanism which can allow the industrial process to change according to the needs. For instance, if within a pipeline, one particular unit stops working, so could it be possible to schedule everything around it? Can industry do it on itself without kind of involving the human aid, without kind of resolving these issues by someone else? Similarly, if certain parts needs maintenance and there is a degrading efficiency, so can machines itself tell that, okay, this particular part needs maintenance after 30 days or after 40 days, and how we can incorporate that? So all those decisions and all those intelligence kind of comes from the information, and that information comes from the big data, the data that is being collected. And to establish all this, some of the key technologies, Internet of Things, cloud, and big data, are basically the key to establishing an environment which is capable of handling all these aspects with respect to greater efficiency and incorporating processes which can change depending on the demand, which can change depending on different failures, and can maintain different variations quite effectively. Similarly, autonomous robotics, decision support systems, these are some of the other technologies which are quite common in current industry, but also enable the industry 4.0, because autonomous robotics are enabling the AI systems to work efficiently, to work around the problems. And these automatic robotics, the autonomous robotics, is capable of scheduling things accordingly. We can optimize the pipelines, we can increase the efficiency, we can increase the productivity within certain environments. And later on, I will try to give one particular case study, which is basically targeting how to optimize different processes within the industry, which is a collaborative work going on with IIT Silicity, and this is funded by UKIERI. So I will discuss that on later on. So one thing which some of you might be familiar or might not be is the digital twin. So just for those who don't know much about digital twins, let me just phrase it as a way. So digital twins is basically a digital replica of the physical system. So when we are talking about the industry 4.0, the digital twins has the potential to build an environment which is capable of handling very complicated processes with higher efficiency and higher accuracy, can embed artificial intelligence, and can make future decisions. So how the digital twins fit in is that digital twins are basically the digital replica of a physical system. So what it does is it creates a digital fingerprint, digital carbon print of the physical system, and it is connected to that physical system. It actually replicates the physics and dynamics of different processes, different objects, different elements within the physical system into a digital world. So we have a digital replica which behaves exactly like the physical system. And through the involvement of continuous data feed into this digital system, we enable it to produce similar results as the physical system. So for instance, if we want to optimize a process, it's much more efficient to actually try it on the digital replica, which is basically giving us a very good idea that optimizing, let's say, one particular process with improved productivity by 10%, improved productivity by 20%, reduce energy consumption by 10%. So all those scenarios which we want to test, we want to optimize, or even the scenarios which machine thinks that can optimize the processes could be tested on the digital aspect, on the digital replica, the digital twin, to actually implement within the Industry 4.0. So just coming to all these enabling technologies and the ability to shape things, it is very important to realize that Industry 4.0 is not limited to just the industry itself, just what is happening within one factory or within one particular industrial setup where we have production, we have manufacturing, and all these aspects. But rather, we are looking at something which can be expanded to much larger scale. And here is one representation which was kind of provided by Liblium. And I share this because it kind of very efficiently represents the environment in which we live in and how the AI, how the intelligent systems, how the IoT will transform the environment we live in into something of a much intelligent, much efficient environment. And we are looking at different aspects. For instance, here there are certain representations. And if you see, these are the smart buildings. And then we have a mechanism to evaluate what are the requirements, what is the demand. And we have some factory, which is also kind of connected to this demand of the supply chain and how to establish balance between the demand and production by optimizing the processes, so that you don't have to store the extra products, extra goods that are produced. You have to be very connected to actually achieve this kind of environment. And it's not limiting to just this, it's actually the supply chain which is being managed. So if you look at the industry, so any supplies of the raw equipment that is coming in, all the information that is coming in from different parts, all the pieces that are coming in to create certain products are being tracked and connected so that we can optimally schedule the things within the industry so that we can manage any delays within the shipments, within the delivery of the raw materials, and we can work around what is needed at the moment and what are the requirements, especially for perishable things. So the whole concept is very interesting, how we see the world and how these technologies can actually jump into building something which is very intelligent, very specific, and very sophisticated, and is able to manage not only the production side, but also with respect to the pollution, with respect to the supply and demand, with respect to the supply chain management, with respect to transportation, and so many other factors which are being happening. Okay, so just moving further from what we discussed, here is one representation. This is a work, as I told you, with respect to the Vesta system. So this is a replica for Industry 4.0. So this is a project which was carried out in collaboration with IIT City, and it was the optimization of the product development. And I will share a couple of videos if I can as well during discussion, just to show you what is happening and how these are interconnected. So with respect to the system that we are trying to optimize, so the funding particularly kind of was looking for a digital twin for Industry 4.0. So how you can establish a digital replica of a physical system to optimize the processes within that physical system. So here is basically a chain of event, a cycle of development of a product and different stages it goes to. So it kind of starts with order assignment, and then different stations actually do different processes. And if you look at the first three, you would see that there is a product, and that product is being moved on the conveyor. Different fuses are placed on that product, and then it is inspected using image processing techniques. Later on, it will actually provide the covering, the casing for that product, and then move this one to pressurized closing of that product along with the heat chamber base sealant, which actually fixes the product, and then it is further tested for whether the product is up to the requirements and does it meet the certain criteria, quality checks criteria. So the overall process for this one is, let me just show you one of the parts first, and then I will come back to what the process is happening. So this is basically a faster Industry 4.0 solution. And now the project which I'm talking about is in collaboration with Festo. So they have one replica of an industrial process where you have a conveyor belt here. And as you can see, different objects are working to actually create different effects. Different processes are completed throughout these ones. And this is one section of the industrial process that is happening. And just moving back, this is just the representation of station 1. Let me just show you what station 1, station 2, station 3, and all 6 stations, which are necessary for the completion of the product do. So in the very first aspect, in the very first representation, you have an order initialization. So what is done is that an order is assigned. Then there is installment of the base, RFID-based recording. There is also a blockchain-based evaluation that the product is authentic and so on. So there are blockchain-based keys assigned to each product to check its manufacturing cycle. Excuse me. The station 2 is basically with respect to the verification and PCB placement. The 3 is the inspection station, which kind of uses the image processing to check the configuration is accurate or not. Station 4 similarly kind of performs certain tasks. 5 and 6 do these tasks as well. So this is the entire system that we are looking at. So the basic objective was to create a digital replica which can replicate the processes that are happening within this one. So if you look at this, this is the original recording. And this is a digital replica which is connected through data, and it actually kind of performs the same activities as well with respect to the different elements which are taking place within this. And so the physical system actually kind of places the lower casing here, and then in the digital system, you have the same mechanism operating. And it also takes into account the different sensors. For example, we have IR sensors, we have RFID-based tracking, we do have pneumatic sensors. So what the basic objective was to, one, evaluate the overall time taken by each of the process and how efficiently improve this process by doing analysis within the digital aspect. So if there is, because there is a continuous feed between the physical and digital system, so you can see if certain pressure is going down within pneumatic sensors, and you can basically implement AI to predict when there is a maintenance needed so that this can be scheduled preemptively and doesn't offer any restrictions or any hurdles in the regular manufacturing. So that was one of the aspects. And the primary objectives with respect to this one was, here is kind of another representation, which kind of shows the 3 stations. So in the first station, it is again the digital replica where we have a PCB board placed on the conveyor, and then that PCB board is assigned certain fuses at certain places, and then it goes to the inspection station, which actually checks whether it is approved or not. So by establishing a digital replica of the physical system, what we managed was to optimize these processes, how these processes can be run more effectively. If one part where, for example, the inspection station fails, how you can reroute it back to the original casing, how that can be performed. So the entire project kind of worked on using the digital replication of all the sensors within it, and there are around 16 to 18 sensors which are being monitored, and these sensors actually provide the information about the working of each and individual part of this equipment, and with respect to how these parts can work more effectively towards better optimized solution, and how we can use different testing techniques to actually optimize it. So there are LSTM-based solutions which are predicting different sensor outcomes and are predicting that when certain maintenance are needed, so that that hurdle is eliminated from the way, and we can schedule it according to our ease. Okay, so here is a full representation of digital twin, and this one is basically, well, my apologies, I am kind of feeling a bit of sore throat, so I think it won't be that enthusiastic as I started, but I will try to continue with what we are trying to cover here. So this is basically the whole block of digital twin development for Industry 4.0. And this is the FESTA system, which is also a partner for this project. And this is the digital twin product. So basically, we are using the Siemens-based MindSphere to communicate the data, communicate the information from the physical system to the virtual product to the digital system, and optimizing different processes with respect to the design and performance optimization, with respect to device diagnostics and prognostics, with respect to predictive maintenance and optimized operation. So all these aspects are kind of fed to the real system from the virtual system after a thorough analysis, which is basically creating a chain to optimize the real system using the different machine learning based analysis, statistical analysis on the digital twin. So what we are actually communicating between these two, so from the real product, we are actually communicating the history, the operational history. We are communicating the data, the sensory data, the real-time data, which is being produced by the real product, by the physical system. And then using this all this information and using the transfer learning from other systems, which are quite similar to this one, to produce a solution, produce a model which is capable of improving the overall efficiency of the real product by analyzing the digital product. So this is a self-optimizing process where different bottlenecks are evaluated, different machine learning algorithms are incorporated to actually do all these processes. Okay, so when we are talking about this digital world, so we kind of seen one example which was particularly focused on Industry 4.0 and how that works. So this is just another representation, which was a work carried out in collaboration with partners from Vietnam, and it was the use of similar technologies, because we are talking about the transfer learning and implementing all these to different domains, and how effectively we can manage the optimization processes within different aspects, within different domains, and how that development can actually impact, for instance, if we want to build a smart city, smart bridge, how that information can actually be used, which is basically a building block for Industry 4.0. So here is another project which is running, which was funded by the Newton Fund and the British Council, and it was on the structural health monitoring. So with respect to this one, it again kind of replicates the processes, the design of the physical entity, the system integration, the data that is being coming from this one and the numerical model, and with respect to that, the diagnostics, all this information kind of used to actually create a digital replication of this process. So how the physical system that is being represented here is transformed into a digital twin. And with respect to this digital twin, what we can do is we have a digital replica, which we can test for high winds, we can test for floods, we can test for storms, and how the information coming from the physical entities is helping us to test different features and to establish mechanisms to prolong the lifetime of the physical entity. One thing which is again and again a key in any kind of optimization process is basically a mechanism which can establish communications. So here comes the Internet of Things and AI, which basically establishes the data communication, and based on that data, the recommendations running different scenarios in the digital world to optimize the physical environment, how to prolong the life, for instance, in certain cases, by reducing the overall load on the bridge, the number of vehicles that can pass, maybe allowing closing the bridges for during the storms, during the high wind, and so on. So this is one representation with respect to this one. And now this is quite the same as Industry 4.0. And if you see that you don't have just a one system working, but you have several systems, so you have several bridges, and all these bridges have different data sensors connected to it, and you can use the transfer learning to optimize your model by learning from the other environments. So the industry or any other domain where we are trying to optimize the processes, we can actually see that machinery, for instance, is also working in 1,000 other places. And we have a much longer history of that machinery. For example, you have recently placed in one of your manufacturing plants, but in actuality, it is working in 10 other places for past 10 years. So you have 10 years of history, and you can use machine learning, artificial intelligence to predict how your machine will behave depending on what information you can gather from those 10 years of experiences from 10 or 100 different cases. So this is just another representation for how this was transformed, and this is basically our team taking some data from one of the bridges. So this is just the placement of sensors within Vietnam to actually evaluate the bridge, and it's working. Now, just moving a bit further from those projects, so this is a British Council HEC funding grant proposal, which is basically dealing with the smart agriculture. And when we are talking about the industry automation, it is not limited, as I said before, to just what is happening within the industry, but it's kind of, for instance, if you have an industry which makes cereal, so most of the outcome of your industry depends on the input from different farms, maybe from dairy products that you are creating. So you need to expand when we are talking about Industry 4.0. So this Industry 4.0 need to expand beyond just the industry to wider processes where it can manage the supply chain, manage the communications, manage the other transformations within how we can minimize the carbon footprint, how we can do the disease monitoring, how we can actually look at the water microbiology, how we can look at the pollution factors. So all these are basically a connected environment, and this connected environment is the resultant of Industry 4.0, which is kind of which is offering a solution, a much optimized and much effective solution for the prevailing problems, how to do the things more effectively, how to manage the needs. I think I will just complete this one here. And let me just quickly discuss a couple of aspects of this one before I move it over to the panelists and the organizers. So here it is again one of the concepts which is kind of a work for Horizon 2020 RISE project. And this is the cognitive decision support system within Industry 4.0. What this system is doing is, it is basically creating the computational models for the physical models. So basically a digital twin realization of the physical model. And then it is actually using the Internet of Things, Industry 4.0 concepts, and artificial intelligence, machine learning to formulate predictive analysis of different processes within the industry and providing a decision support system. So what this decision support system does is it actually keeps us, the human intelligence on the top by making decisions more effectively. For instance, with respect to a factory which has more than 5,000 sensors, which have more than 100 pipelines, we are looking at a production which is capable of producing tons of material within every single day. And keeping up with all that data just by looking at that data is, I think, not feasible at this stage, especially when we are moving towards more advanced industries. So in such environments, how we can use or we can develop a system for Industry 4.0 to establish a decision support system. So for instance, the industry kind of evaluates different processes using AI techniques, using different artificial intelligence algorithms, machine learning algorithms. It uses the sensing data, it uses the insight from machine learning, it uses maintenance data, it uses the databases from different companies, it uses the transfer learning. And with respect to all that information that we have gathered within one industry and from other many similar industries, how can we optimize the processes? So the basic intention is to actually give very specific outcomes and support in making certain decisions. For example, making change to certain processes could result in 10% increase in productivity. So the machine will provide the data in a form that is comprehensible for humans to actually make more effective decisions based on that data. They can evaluate the cost and how much time they would need to actually complete that cost to cover the cost that is being going into optimizing that process, and how long it will take to actually get the profits out of what you have achieved. So for instance, if there is a 10% efficiency increase within the productivity, and you have to spend maybe 1 million or 2 million, so would it be a wise investment or not, depending on the overall return over the period of next 2 to 3 years. So that's where I kind of see artificial intelligence, machine learning kind of going at the moment, but we are moving towards more and more Industry 4.0 and different benefits that Industry 4.0 offers. So I guess that's all from my side. Thank you once again for listening, and thank you for the organizers for giving me this opportunity.
Thank you, Dr. Mohsin Raza. Really, it's a wonderful presentation, and hope the participants, they have got enough expertise after listening your session. So I would like to thank you very much from the Department of Marine Engineering, Academy of Maritime Education and Training, deemed to be University Chennai. Already our university is having a very good tie-up with Edgel University. So on this occasion, I would like to extend my gratitude to Dr. Nick Bessis, head of the Department of Computer Science at Yale University, for organizing this wonderful opportunity to interact with you. Thank you very much. Thanks a lot.
Thank you.
Thank you, sir. Now I would like to invite the keynote speaker for track 6.
Good afternoon to all. I, Yagivresh Shekhawat of First Year Department of Marine Engineering, feel extremely glad and overwhelmed to introduce the keynote speaker, Chief Engineer Indranath Bose, Advisor, the Great Eastern Shipping Company Limited. Sir, I welcome you to track 6, Marine Pollution. He is responsible for performance monitoring of fleet vessels between 2007 and 2014. He was the designated person and head of QST department and was responsible for quality, safety, occupational health, and environment protection standards of the company and training of floating staff. He is a member of the governing board and chairman of the Academic Council of Great Eastern Institute of Maritime Studies. He has been representing Government of India at Marine Environment Protection Committee, PPR Subcommittee, and other forums of International Maritime Organization for over 2 decades and has been closely associated with the development of various marine environment protection measures, specifically reduction of GHG emission at national and international levels as Indian National Ship Owners Association representative. He has contributed significantly in implementation of IMO codes and convention in IRS class vessels and assisted the National Maritime Administration in implementation of International Safety Management Code, International Ship and Port Facility Security Code, etc. He is the current chairman of Technical Committee of Indian National Ship Owners Association. He has authored 2 books, one in 2012 titled Energy Efficiency and Ships, which has been highly acclaimed by professional bodies nationally and internationally, and the other in 2018 titled Guide to Data Collection System, Reduction of GHG Emissions from Ships. He is currently Vice Chairman of Technical Committee of Indian Register of Shipping and member of India Technical Committees of Bureau Veritas, Class NK and DNVGL. I now request the keynote speaker to address the gathering. Sir, please.
Thank you very much for that kind introduction. Good afternoon, ladies and gentlemen. First of all, I wish to thank Amit for inviting me to deliver the keynote address in this session on marine pollution. I wish to congratulate Amit for organizing this online seminar on disruptive technologies in maritime sector, Industry 4.0, despite all the challenges of the current pandemic. I thought it is best I speak on decarbonization of shipping, as it is going to introduce significant changes to shipping technologically, operationally, and commercially over the coming years at a very, very rapid pace. Greenhouse gas emission is not actually a marine pollutant, though I'm talking in the marine pollution session. It's not a pollutant, it's a global warming agent and is causing climate change. It has been included in MARPOL Convention, Annex 6, dealing with air pollution prevention issue, since it was found to be the most expeditious way of legislating reduction of greenhouse gas emission in shipping, considering the urgency of the issue. I mean, developing another convention would have taken a very long time, and we would have wasted time in that. If there were, now what is greenhouse gas? I mean, most of us understand that, but I just want to go into, give a perspective. If there were no greenhouse gases in Earth's atmosphere, the Earth would have been a barren lump of rock and ice, on which the average surface temperature would have hovered around minus 18 degrees centigrade, with the same sunlight as it receives today. the sunlight would have been re-emitted back into space as infrared radiation from Earth's surface. The greenhouse gases absorb outgoing infrared radiation, thus warming the atmosphere, and in so doing, the surface below. The result is an average surface temperature of some 15 degrees centigrade, warm enough for open seas and oceans and a vibrant biosphere that we have. However, since we started using fossil fuel, the greenhouse gases generated are far in excess of naturally occurring sink. In the late 1950s, when systematic monitoring of the atmosphere's CO2 level began, it stood at around 315 parts per million. And we were told sometime in 1980, 95, that 340, 350 ppm is very bad. But currently the ppm level is 410, and a far warmer Earth and increasing adverse impacts of climate change, which we can see the number of storms that we are facing on east coast of India, west coast of India. So, and various other climate change related problems, that rising sea level and Arctic ice is getting melted. So in Paris Agreement, the government agreed to restrict the Earth's temperature rise up to 2 degrees centigrade from pre-industrial level. Pre-industrial means before fossil fuel were discovered and we started using it. And better still, 1.5 degrees centigrade. So in 2018, before that, in 2011, Marpol Convention was amended and 2 new regulations related to greenhouse gas emission was introduced. Energy Efficiency Design Index for new ships. It's like an energy efficiency standards, which all new ships have to meet. It's like in the automobile sector, we have got Bharat 5, 6, etc., something like that. And that all existing ship must have a ship energy efficiency management plan, which will tell the ship how it is to reduce its emission or contain it. So that is all we had. Then in April 2018, IMO adopted an initial strategy for reduction of greenhouse gas emission from international shipping industry to ensure that we remain, our emission reduction in international shipping remains in the same trajectory as has been agreed at Paris UNFCCC Conference of Parties. So broadly, the initial strategy directs the shipping sector to peak its GHG emission as soon as possible and decline its annual GHG emission by at least 50% by 2050 compared to 2008, and try to phase them out as soon as possible during the second half of this century. But now it appears that there is going to be a review of this strategy in 2023. And we will see a lot of changes in this. I mean, more ambitious reduction of greenhouse gas emission. Also, the second thing that was agreed was reduce the carbon intensity for the sector as a whole by 40% by 2030 and 70% by 2050 as compared to 2008 level. Just a week before last, we had Marine Environment Protection Committee 76 session, which I was fortunate to attend. And we have adopted 2 new regulations. One is called Energy Efficiency Index for existing ships. Even the existing ships has to meet the standard which is applicable to new ships. This rule will come into force from 2023. And in 2023, ships have to meet EEDI phase 2, which means that they have to be 20% more energy efficient than the ships built in the first decade of this century. So existing ship has to meet the same standard. So how do you achieve that? it is possible that some amount of propulsion energy saving devices can help in reducing the emission and meeting those targets. But in our fleet, and I also know about my colleagues in other shipping companies, we have fitted various kinds of energy saving devices like new stack, change the propeller with high efficiency propeller, change the lighting system to LED lights, and we have reduced our CO2 emission. But it is not enough to meet that 40% target for most of the ships. So most of the existing ships, they have to limit the power of the main engine by locking the fuel lever at the governor. And that how much power limitation to be done, that depends on the same formula as used for EEDI. So this is a massive changes which all the ship owners are facing now, industry is facing now, administration is facing now to prepare for that kind of changes that will happen. But that is not all. We also have something called, so this is you will get a certificate called EEXI. I mean, it's in the International Air Pollution Prevention Certificate that will be added. So that's a ticket to continue to sail after 2023. And this compliance has to be achieved during the first annual intermediate or renewal survey that happens after 1st January 2023. So at the end of calendar year 2023, around 30 to 35,000 ships they have to meet with this particular requirement. And they contribute almost 90% of world's GHG emission. Smaller ships have emission, but not so much. And after that, ships have to meet certain carbon intensity reduction target. What is carbon intensity? Is grams of CO2 emitted per mile of cargo work. For most of the cargo carrying ship, it is dead weight, which is going to be used. And for passenger ship, etc., it is a gross tonnage. So in a whole year, whatever CO2 you emitted, in the numerator you have that, and in the denominator you have got the ton mile of cargo carried, or cargo work done. So you will get a figure. That figure attained CII has to be less than required CII. So now most of the ship owners are now doing the exercise to find out whether they are going to meet it. Majority of them will not be meeting it after certain, and this gets tighter and tighter. Every year it gets tighter and tighter. From 2023, it's get tighter by 2%. Until it is agreed up to 2026, it will reduce by 2%. And then in 2025, it will be decided that whether the shipping industry's CO2 emission reductions trajectory is in line with Paris Agreement or not. If it is found, yes, it is in line, then this reduction rate of 2% per year would be remain unchanged. And if it is found it is not enough, it is going to be made much more tighter. And there, the lot of changes will require to achieve year by year 2% reduction. And you have to look at various energy saving devices that can be fitted on ships, existing ships. Today, many things are being tried out, like kites, sail, etc. I mean, just to give you an example, Katishark, it was a sail ship. It used to do 17 knots, carrying around 12,000 tons of cargo. So if those ships could do it, they have very fine hull lines. So we will be going back to that particular era. Initially, we will be supplementing the wind energy to our main propulsion using fossil fuel, etc., until we have zero carbon fuels in somewhere in the horizon. So a lot of research and developments are going to happen in developing zero carbon fuel. In fact, today we have a meeting at about 4:30 today. Indian government, IMO, and Norwegian government, we are going to discuss about, it's something, India is a pilot country with respect to Green Voyage 2050. I mean, transition to zero carbon fuel. That what can we do in India to transition, get into that? What kind of, we have to be independent. We have to reliant on having zero carbon fuel. There are so many possibilities. I mean, is it going to be hydrogen? Is it going to be ammonia? Is it going to be methanol? And see, I'm just talking of not a, I had a prepared text, but better I discuss with you these things to get connected to the cadets and other faculty members and others who are listening to this. There is various way of producing the zero carbon fuel. You can produce it from fossil fuels. You can produce it from LNG. I mean, for example, methanol, you can get from coal and then use it in your engine. But it's not a very energy efficient way of doing it, because to make methanol from coal, you spend energy. So actually, you will be emitting more CO2 than you are using gas oil or diesel oil and burning in the diesel engine. That's more energy intensive. It doesn't make any sense. But if you use the methanol through a process where you generate the methanol from the coal, but the CO2 that is emitted, you capture it, carbon capture. You capture it, and then you find a place to store it. Mostly they are doing it underground through empty wells. They are putting it down, capture. And the methanol you produce is called blue methanol. So you must be knowing about it, and these terms will become more and more used. So the blue methanol has got less CO2 emission. So that's good. That if you use, it's far less CO2 emitting than using fossil fuel. The other one is, actually, what is hydrocarbon? It is carbon molecule, hydrogen molecule, all these combined in various configurations. So if you use renewable energy, I mean, say wind turbines, or you use solar cell, there are a lot of wind turbines are being used now, or solar power. And from that, in through the water, you electrolyze the water and produce hydrogen. And from atmosphere, you capture CO2. It's called direct air capture, DAC process. You capture CO2, mix these two, CO2 and hydrogen, and you can make methanol. And that methanol will have very little, I mean, it is made from renewable sources of energy, zero carbon emission, almost zero carbon emission, that you can use. But this process is right now not available and extremely expensive to produce it. So only by having more and more use, the cost of production will come down. I'm just giving you an example. So this methanol which you produce is called green methanol, green. There is no CO2 emission when you burn it in the engine. Today, methanol engines exist, and there are product tankers sailing on methanol fuel, because they carry methanol. Methanol is one of the most traded commodity. And from the cargo, they take this methanol and burn it the engine. These are medium-sized range tankers, and they're operating, and it's available. So if you can get an infrastructure, and another thing about this, I mean, because your term is disruptive technology, so I just wanted to talk about this, that 85% of the investment in having zero carbon fuel will happen ashore. So ship owners can't do it, shipping industry can't do it alone, administration can't do it. We need the energy producer, we need the energy processor, suppliers. So everybody has to get together to transition into zero carbon fuel. And the investment, as you heard, is 85% of the investment is going to happen in shore and 15% on ship, because the ships, the fuel system is going to be different. We have, so this is one. Then another way is ammonia. Ammonia is also a promising fuel, but same way ammonia also can be produced from water and air. And in some of the ships we are talking about, the CO2 that is coming out from the funnel in a ship, capture that CO2, liquefy it, keep it in the tank, and then discharge that liquefied CO2 when you go to a port. This is another capture, is carbon capture, storage, and discharge. Your CO2 emission to the atmosphere will be less. So these sort of carbon capture and storage process will happen until and unless we have zero carbon fuels in abundance at an affordable rate. And these are quite a disruptive. I mean, we are going to see huge changes in next 10, 20, 30 years. And some of the research institutes, they are saying, if we are to meet 2050 target of IMO, that 50% reduction in CO2 emission, irrespective of fleet growth, and fleet is definitely going to grow. That's a projection they have given in the fourth IMO GHG study. So we have to transition into zero carbon fuel. So if you want to transition into zero carbon fuel, you have to have all these things. And at least in 2030, 5% of marine bunker fuel sold must be zero carbon fuel. That means zero carbon fuels should be sailing on board ship. The easiest way to transition into that is, one of the companies are doing it, is that they are saying that, okay, methanol engines are available, methanol ships are operating, so they are going to run their methanol on methanol sourced from fossil fuel. It could be blue methanol. I mean, they are capturing the carbon and keeping it. And these ships are going to be container ships running on fixed route. And if that happens, then by then, the other technology will develop, that how to make methanol from renewable sources of energy by then at an affordable cost. Then the same engine, the same ship can run on this green methanol. That transition, I mean, it is foreseen the transition will happen this way and step by step. So that, I mean, you don't, hydrogen is another potential which can replace, and not in a ship, but also ashore. And very much hydrogen is a possible solution. But there are a lot of safety concerns, etc. So we have to see how that particular develops. So going on this, my time was around, I think, 20 minutes. I've already used up 20 minutes. Yes, I must say something. In MEPC 76, we also adopted a work plan for midterm and long-term actions, that how to promote uptake of zero carbon fuels, what all things we need to do. So this process of getting proposals from member governments will happen from this year, from 2021 to 2022. Whatever proposal you want to give, that how to promote use of zero carbon fuel, what kind of fuel is possible, etc. Then between 2022 to 2023, that exploration will start, that which is better to easier, which is cheaper. And yes, there is a very big political dimension in this. The greenhouse gas emission, the climate change was mainly created by the developed worlds because they were the mostly using CO2 emission. Their per capita CO2 emission is far more than what it is in developing countries. So developing countries are saying that you created the problem. Now you spend the money to do all the corrective measures and technology transfer, etc., etc. So in IMO debate, this is very much part of it, that whatever measure you decide, you must do an impact assessment before that rule is implemented. Impact on economy of state, trade, living, on the developing countries, smaller than countries, etc. So now the rule that I explained about energy EEXI and CII impact assessment has been done. And it has been found that distant economies, they will have some adverse impact. So that has to be addressed. How that has to be addressed, through what kind of technological assistance, etc., these are being worked out. So whatever in midterm measure, whatever proposals are given to IMO, it comes, that has to be followed up with an impact assessment between 2022 and 2023. And then 23 onwards, you have to make the legislation, etc., to give a clear timeline that by which regulation, which fuel will come into force. Because today there is a big vacuum. Ship owners are not going into the yard, not readily going into the yard to build ships, because their fear is that maybe 15 years down the line, fossil fuel ships will be obsolete. Nobody will want it. There's a CO2 emission rules, and charterers may not want it. Already charterers are looking into CO2 emission profile of individual ships before chartering it. So all these changes are coming, and we need to be prepared for that. And the cadets who are listening to it, you are going to see a very, very what should I say, transformatory phase in your life. We haven't seen it at our stage. We lived with diesel engine all our life, and some of us have seen shipping, what you call steamships. So what is the way forward? Investment in land-based energy infrastructure that is required to decarbonize shipping holds a potential to drive substantial development gains. A study by the Energy Transition Commission and University of Maritime Advisory Services for the Getting to Zero Coalition estimates the cumulative infrastructure investment that is needed in the next 20 years for shipping to make the transition to zero carbon energy source to be approximately $1 to $1.4 trillion. The industry needs regulations that provides a level playing field and a compliance framework that is technically proven, safe, and commercially sustainable. Without these key criteria, there is a huge regulatory risk looming between 2030 and 2050. Actually, it should be 2020 and 2050 because we are already facing the effect of EEXI and CII. So collaborative approach, as I said, that everybody needs to be energy producer, supplier, renewable energy source generators. You must have heard that the Reliance is spending big money on renewable sources of energy. So all these, a collaborative approach among all stakeholders is needed in finding solutions in achieving IMO's greenhouse gas reduction goal for the shipping industry. So thank you very much for your kind, patient hearing. So thank you.
Thank you, sir. Thank you very much. It was indeed a very eye-opening session for all of us to understand about the industry standards better. I request Principal Sir to say a few words.
Sir, you are muted.
Bhupati sir, I think Professor Mangesh also has a comment or a question in the chat box.
Yes, sir. The query is, the development of fuel should be a collaboration between producer and consumer. Low sulfur fuel production consumes more carbon in refinery.
Okay, yes, your observation is quite correct, but I will give you the background to this, why IMO decided to go for low sulfur fuel. see today, in automobile sector, the sulfur is some 0.0 some percent of it. It's far ultra low sulfur fuel. And in marine, we were using 3.5% sulfur fuel. So it was having a lot of health impact. I mean, especially which is near coast, people living on the coast, Chennai, etc., and other places, high sulfur is bad for their health. So we had to reduce the sulfur emission. And I fully agree with you that while reducing the sulfur, in refinery, more energy is wasted and more CO2 go up. It is a balancing of two ills or good. So it is a balancing act. But nevertheless, I must tell you that when we told from our shipowner side to the Indian refineries, IOCL, HPCL, BPCL, that from 2020 we need low sulfur fuel. So we need 0.5. They told us that to meet Bharat 6 requirements, we are upgrading our refinery in any case. IOCL said that they will stop production of heavy fuel oil. Then we begged to them that please keep it going until 2020 because ships are still running on heavy fuel oil. So they said, okay, we will continue. But others, they want to stop it to meet the automotive sector, land-based sector. So it is, your observation is correct, CO2 go out more, but you also have to see the human health. So that is how it is. Thank you.
Thank you, sir. Thank you very much for your valuable inputs regarding zero carbon emission and also the carbon capture and storage. And also, it is useful to all our research scholars who are available in our university and also the participants who are available in the particular 2 days conference on disruptive technologies and maritime sector industry 4.0. At this juncture, I would like to thank our placement director, Mumbai, Mr. Anand Tripathi, for the support rendered in bringing out the chief engineers like you, Ian Bose, sir, and it is very useful to all of us. Sir. Thank you all. Thank you once again, sir. Thank you.
Thank you, Professor Bose, for agreeing to grace the occasion. We look forward to more such opportunities. Very incisive indeed, and I think the cadets, it is the best for the cadets because they will, start for the future with a clear vision of what is in store right up till 2050. Thank you, sir.
Thank you, sir.
Thank you very much. Thank you. It was a pleasure.
Ma'am, can we start the session?
Sangeeta, you can proceed with the technical session. Thank you.
So my request participants for the track 5 and track 6. Track 5 will be continued in the Zoom link, and track 6 you will have to join in the Google link. So which will be displayed in the chat box. The Google link will be displayed in the chat box.
The session coordinators, you please take over the session. Yeah, Dr. Suresh.
Etna.
Yes, please take over.
Informed. So now you have to add the panelist. Harish.
Can you load the link in the chat box so that participants can join that link?
Dr. Muthu Bhaskaran, sir.
Yes, sir. I will.
So 5th track is ready?
Yes, sir.
So kindly call the participants to join in this Zoom link.
Myself, Ramamurthy, Assistant Professor.
So kindly permit them, the panelists, so that they can start their presentation.
So, sorry, sir. Once they call out the name, I'll be just letting them in. No worries about that. Let them start with the track.
Yes, sir.
Okay, Muthu Bhaskaran, sir. So kindly call the first presenter for your track. Yes, sir.
Santosh Kumar. Mr. Santosh Kumar, paper title is Design and Development of Quadcopter using Arduino.
Kindly enable them for presentation.
Enabled now.
Santosh Kumar is in attendees list actually.
Sir, I have enabled him.
Okay, fine.
Yes, Santosh Kumar, you can present. Mr. Santosh Kumar.
Santosh Kumar, you have muted.
Sir, you just call upon the next speaker, sir. Next question.
Yes, sir. Mr. Prabhu, design and analysis of rear spoiler, a case study on a high-speed car. Mr. Prabhu.
Hello, sir. I'm Sanjita from the batch Santosh Kumar D to present here, sir.
Okay, madam. Please
Okay, you can start your presentation.
Yes, sir. Hello. Hello, can you hear me, sir?
Yes, Prabhu sir, we can hear you. Kindly wait for a few minutes. Let the first presentation be done, and then you can you can start yours. Sorry.
Okay, ma'am. Okay, ma'am.
Shall I share the screen, sir?
Yes, madam.
Hope my screen is visible, sir.
Yes. It should be in the full screen view. Okay. Press FIR.
Hope it's visible, sir.
Yes, now it is visible.
First of all, good afternoon, sir. Thank you for this opportunity to present my paper. I'm Sanjita. In behalf of my team, I'm here to present my paper, Design and Development of Quadcopter using Arduino. And the content of my presentation is to explain my abstract introduction, block diagram, and the components which we are need to develop the quadcopter, and the testing of the quadcopter which we have done manually, and the applications of quadcopter. And this is what the abstract of quadcopter. Quadcopter is nothing but an unmanned aerial vehicle which can be work autonomously as well as remotely manually, which can be used for several applications. As we have several copters like bicopters, tricopters, and everything, but quadcopter is more efficient in usage, so we have chosen quadcopter. For more efficient and robust control, we have used Arduino as a controller and a quadcopter. And my next next is introduction. Quadcopter is nothing but an unmanned aerial vehicle which can be capable of flying without any pilot or any manual system. They can be controlled remotely as well as by an operator, which we can be pre-programmed as the parts can be pre-programmed. And the next is the quadcopter configuration is really simple, and which could be capable of maintaining autonomous. So we have choose quadcopter, and there are quadcopters, several quadcopters. The efficient of quadcopter is much more than unicopters, bicopters, and tricopters. In the position, in the name of position, we could not able to handle that more efficiently, but quadcopter is such friendly to work, so we have choose quadcopter. And quadcopter is also known as drones and quadrotors, which has 4 rotors and which has an independent speed variation. Each rotor has an independent speed variation to control its flow. And this is my block diagram of quadcopter, where we have 4 speed controller as well as 4 motors for controlling it. And the explanation of block diagram is, as I said, that we have 4 channels, and as well as we have 4 speed controllers only for the purpose of controlling the speed of motors. In term to control the speed of motor, we have used speed controllers, and which is interface between the quad controller and the motor. And these are the main components for developing the quadcopter: frames, motors, speed controllers, propellers, batteries, and IMU's Arduino board and RC controller. And first thing is frame. In frame, which we can choose any type of frame. We can use aluminum frame or wooden frame or carbon board frame, where it has 3 main parts: holding plates, arms, and motor brackets. And this is our quadcopter frame, which we have took during the design process. And next important thing is brushless motors, which is same as an traditional DC motors. Without the brush on the shaft, it is termed as a brushless motors. To change the direction of the power goes through the coils. It is used. And also we should need a motors that to rotate in a counterclockwise, so they contract the props torque effect, so they could contract between the torque effect. And this is the brushless motor we have used. And the next one is propeller, which is the main thing. Propellers will generate the thrust of each motor in terms of quad to make fly. According to the size of the frame, propellers need to be chosen, and it should be clockwise direction and anti-clockwise direction. Based on the usage of the quadcopter, the RPM of the motor can be changed. For high RPM motors, we need a smaller or mid-size propellers. According to the RPM of motors, the propellers can also be size of the propellers can be changed. In case of if we are using low RPM motors, we need to choose large propellers to design quadcopter. And to achieve the perfect balance between the motors and the propellers and usage of the quad, the motor RPM of the motors should be predefined. And these are the propellers of quadcopter. And next is electronic speed controller. The device that is a charge of controlling the speed of the motor is to control the speed of the motor. We have used this to run at a constant torque, and we have chosen 10 amp or higher than electronic speed controller, and we need each motor and each separate speed controller. And next is battery. We have used a lithium ion polymer battery, and it's not heavy and the current levels are also ideal, so we have chosen this type of battery. And depending upon the step up maximum voltage, we can vary the battery's choice. And next is IMU, which is initial measurement unit, which is used to measure the quad's orientation, velocity, and the force of the gravity. This allows the electronics that control the amount of power sent to the motor and to adjust their motor speed according to that, to provide an acceleration and orientation of the data that can be used to calculate the position and velocity. According to that position and velocity, we can able to adjust the motor speed. And next, the important thing is Arduino. It is we have mentioned that flight controller known as an Arduino. We can either choose a controller board also. Because of its robust and flexibility, we have choose Arduino, and we have used an UNO with an Arduino software. And next is RC transmitter, the most common way of programming and controlling the quadcopter by an RC transmitter. For controlling the quad, acro mode, there is 2 types of mode. So we have chosen acro mode, and the another is static mode. We have chosen acro mode, which is used to sticks to control to its angular velocity. It sticks to its angular velocity. So we have chosen that. Release the sticks, and the vehicle will maintain at the current altitude and will not return to the level. Actually, it will maintain the current altitude of the vehicle, which means quad. And next one is testing. We have to test the motor thrust. So by using brushless motors, we have generated maximum weight lifting capacity of 3.608 kg. According to the usage, it can be used. It can be planned. The battery provided to the quadcopter should be charged. And this is the testing pictures of our quadcopter. And the few applications of quadcopter is surveillance and recognitions of by military, and in any search and rescue operations in urban environment, and more on monitoring agriculture and environmental condition, and in any live streaming events to capture photographies or videographies such that, and marine rescue operations and disaster zone mapping. And thank you so much for this opportunity.
Hello.
Sir, yes, sir.
Yes. Any questions from audience? Hello. Yes. Next the speaker is Mr. Prabhu.
Yes, sir.
You please present.
Yes, sir. Good afternoon, everyone. I am Prabhu, a research scholar of Madras Institute of Technology, Anna University. Today, I'm going to present about the one of my work, the computational fluid dynamic analysis of aerofoil section. So these are the contents of this presentation: abstract, introduction, aerofoil section, CFD methodology, analysis, results and discussion, visualization, conclusion. The aerofoil plays an important role in any aircraft. It chooses whether the lift power is adequate to adjust the heaviness of the body or not, and also the amount of drag power is being connected on the body. The main objective of this investigation is to analyze the flow behavior around the airfoil body and to calculate the performance coefficients at higher Reynolds number and the angle of attack varying from 0 degree to 10 degrees. The section lift and drag coefficient of the airfoils are operated by analyzing the measured pressure distribution on the airfoil surface. The simulations are computed in the software OpenFOAM based SimFlow, and the advantage of SimFlow is that the SimFlow software screens the surface weight and gives a visual presentation of the element changes connected with shifting approach. Yes, so this is a general introduction about aerofoil. Aerofoil is a cross-section area of a wing of a plane. Its fundamental occupation is to give lift to the plane amid departure, keeping in mind the flight. Yet it has likewise a reaction called drag, which restricts the movement of the plane. Heavier planes, the measure of the lift required by plane relies upon a reason for which it is to be utilized. Heavier planes oblige more lift, while lighter planes oblige less lift than the heavier ones. Aircraft wings, which are horizontal and vertical stabilizers, helicopter rotor blades, propellers, fans, compressors, turbines are all have aerofoil designs. Even sails and swimming flying creatures also have kind of aerofoil in their wings. An aerofoil shaped wing can create downforce on an automobile and other motor vehicle, improving traction. The laminar flow wing has a greatest thickness in the center camber line. So this is the basic terminologies in the aerofoil section. So this is a aerofoil section where we can see the point where the maximum curvature at the front of the aerofoil is called the leading edge, and at the rear end of the aerofoil, the maximum curvature is present, where we call it as a trailing edge, and the surface which with higher velocity and lower static pressure is called suction pressure, which is on the upper surface of the aerofoil, and the lower surface of the aerofoil is the pressure surface, which will have comparatively high static pressure than the suction surface. And also there is a, straight line which connects the leading edge and the trailing edge, which is called the chord line, and the length of the chord line is called chord. Now, moving on to governing equations. So we have to give the input to the computer in form of a mathematical equation, right? So that for that purpose we need to utilize some of the basic equations from the mathematics. So that these are called the basic equations. So here we have considered three equations. One is the consideration of mass, and the consideration of momentum. The momentum equation for inviscid flow are known as Euler equations, and the momentum equations for viscous flow are known as Navier-Stokes equations. And the conservation of energy from the first law of thermodynamics. These three unknowns will be found out simultaneously using the equations are velocity, pressure, and temperature at various points along the flow. So this is a basic procedure in CFD we will follow. The three stages of this methodology is pre-processing, solving, and post-processing. In the pre-processing, the geometry or the physical bounds of the problems are defined. The volume occupied by the fluid is divided into discrete cells by a process known as meshing. The mesh may be uniform or non-uniform. In order to analyze the fluid flow, the domains are split into smaller subdomains. The governing equations are discretized and solved inside each of these subdomains. The process of obtaining an appropriate mesh is called mesh or grid generation. So in solving, it is a process in which a problem is solved in a non-interactive batch process to produce the result. So the partial differential equations are all integrated over the control volumes in the region of interest. This is equivalent to applying a basic conservation law to each control volume. These integral equations are converted into a system of algebraic equation by generating a set of approximations from the terms in the integral equation. The solution process requires no user interaction, and this therefore is usually carried out as a batch process. The software used for solving, known as a solver procedure, as a result file that has been then passed to the post processor. In post processing, various flow properties at various locations of the model have been found out. We need to visualize the result obtained from the solving process. So the flow properties are used to plot the contours and the vectors that give us a visual representation of the flow field. Standard algorithms are available that generates this visualization. For software, we have used this open form block mesh. Block mesh is a general purpose preprocessor for CFD analysis. Block meshes automated tetrahedral, hexahedral, and hybrid meshing function improve the quality of the mesh. Fully automatic and high quality meshing can be achieved in open form block mesh. It supports many industry standard formats, including this Pro-E, ACIS, IGES, STEP, and Parasolid. So this the figure A, which shown here, is the airfoil designed with which has been taken into the study. The geometry defined here shows there is a wing and a two-segmented flap, which is deflected downwards, and also the meshed view of the geometry is shown in this figure. This view was generated from open form meshing process. Fine boundary layer is produced around the wing model. So after that, the model is brought into open form environment using SimFlow tool. The meshing process was carried out and solver was selected, which is simple form. The turbulence model we used was SST K omega for turbulence closure. The lift coefficient and the drag coefficient were presented here. The lift coefficient is presented in this figure A. The graph shows a slight linear increase from 0 to 8 angle of attack. Then it decreases rapidly after 9 angle of attack. The drag coefficient from 0 to 6, the angle of attack slightly decreases, then suffers a switchover from 6 AOA. Further increases in AOA result in decreases of drag coefficient up to 9 AOA and shows a sudden increases around 10 AOA. Moment coefficient and lift to drag coefficient. In this figure, the moment coefficient is presented. The graph shows a slight linear increase from 0 to 8 AOA and then decreases rapidly after 9 AOA. Here we can see the lift to drag coefficient is almost linear until 3 AOA and shoots up to higher value and then drops down to lowest possible value before it increases to steady state again at 8 AOA. So visualizations, the visualization of the airfoils are we divided into velocity, magnitude, and pressure counter. So in this figure, you can see the velocity magnitude over the airfoil. The color red on top surface shows the maximum velocity, and the color blue at the trailing edge shows the minimum velocity. Here you can see the pressure. Color red on the bottom surface shows the maximum pressure, and the color blue at a few positions show the minimum pressure exerted. So this figure shows the streamlines for the wing surface. The deflection of the flow is clearly seen at the trailing edge, and the deflection of the flow is clearly seen at the trailing edge along with the direction of the flow. This figure shows the vector over the wing section. The deflection of the flow is clearly seen at the trailing edge along with the direction of the flow. So in conclusion, the analysis of many different types of angle of attack after selecting a particular model of a problem is done. Analyzing the special cases of the problem gave an insight to magnitude of lift production under different boundary conditions like AOA. So we can use aerodynamic simulation can be simulated by open form via SimFlow software. Thank you.
Any questions? Okay, thank you. Next speaker, Mr. Dhanavaran. Design and analysis of rear spoiler, a case study on a high-speed car. Mr. Dhanavaran.
Sir, Dhanavaran panelist add பண்ணுங்க. He is waiting.
Yes, sir. Yes, sir.
Please ask Harish to add Dhanavaran.
Sir, Harish, sir. Is it possible to add him? So Dhanavaran.
Dhanavaran has come in.
Yes, sir.
Good afternoon, sir.
Good afternoon, Dhanavaran, sir.
Just a second, sir.
So kindly take 10 minutes for your presentation.
Okay. Yes, sir. Just a second. Is the content I'm sharing visible, sir?
Yes, it is visible.
So my paper is about design and analysis of rear spoiler in a high-speed application. And the authors of this paper are Mr. P. Mani, teaching fellow, Madras Institute of Technology, and Mr. M. Prabhu, teaching fellow, Madras Institute of Technology, and me myself, Mr. N. Dhanavaran. I'm a teaching fellow and also a research scholar in MIT Anna University. And the author number 4 is Mr. Dr. E. Edison Chandraseelan, Professor Marine Engineering, AMET University, Chennai. And the contents which are going to be presented in this paper is in this presentation is abstract introduction and CFD methodology, analysis, result and calculations, and finally conclusion. So the abstract is nowadays demand of high-speed car is increasing nature, in which vehicle stability is of the major concern. Aerodynamic characteristics of the racing car are of significant interest in creating negative lift for stability and in reducing drag for achieving higher speed. In a bid to improve on the aerodynamic of the car, rear spoilers or wings are increasingly be using both on race and passenger cars. So one of the design goal of a spoiler is to reduce drag, thereby increasing our fuel efficiency. So this project employs computational fluid dynamics to investigate the aerodynamic effects of rear spoiler on drag and lift of a car. So in a car, you should be having lower drag and lesser amount of lift. Okay, which lift in turns increases our stability. So the modeling of our spoiler is made using SolidWorks 2014, and CFD analysis is done by using ANSYS Fluent software. So the result includes determining the more suitable aerodynamic spoiler by comparing these models. So the performance, handling, safety, and comfort of automobile car are significantly affected by the aerodynamic properties, which are discussed in the above slide. So extra parts are added, which is also discussed above. In case of that, many aerodynamic aids sold in the market. So main fixing location is at the rear portion, and there are also other accessories which are used to reduce the drag and also increase the road traction and also and also to reduce the side drag or basically the pressure difference between pressure difference between the two parts of the car has to be stabilized. Okay, so that is the use of our spoiler. So in this we have designed the two spoilers and also made CFD analysis on that. So a spoiler is an automotive aerodynamic device whose intended design function is to spoil
unfavorable air movements across the body of a car in motion, usually described as drag. Spoilers on the front of the car are often called as air dams, because in addition to directing airflow, they also reduce the amount of the flow underneath the vehicle, which generally reduce the aerodynamic lift and drag. So spoilers are often incorrectly interchangeably confused with wings. So automatic wings are devices whose intended design is to actually generate downforce as air passes to them, not to simply disrupt the airflow patterns. So spoiler generally work by disrupting the airflow over the car. The disruption has a primary purpose of reducing the amount of lift naturally generating the shape of the car. The result is a negative force occurred on the lower part of the car, and it will increase the contact between the tire and the road surface, thereby increasing the traction. So another design goal of the spoiler is to reduce the drag and also increase the fuel consumption. Many vehicles have a fairly steep downward angle going through the rear end of the roof down to the truck or the tail of the car. Air flowing across the roof tumbles over this edge at higher speed, thereby causing flow separation. The flow of the air becomes turbulent and low pressure zone is created, which means pressure difference is being created, by increasing the drag. So adding a spoiler on the very rear of the car makes the air to see a longer gentle slope towards the roof of the spoiler, which helps in eliminate the flow separation, thereby decreasing the drag. So the main advantages of the spoiler is maintaining traction, increasing fuel efficiency, added visibility, and also reducing weight, and also creating a stylish look, and also increasing the braking stability. So in this CFD methodology we have proposed, we are designing two spoilers and creating a wind tunnel, which are of same dimension and same properties, and also material property and boundary conditions are also being created. Then coefficient of lift and coefficient of drag is also generated, and finally calculation is being made. So this is the design of our first spoiler, which is a normal spoiler, and these are the dimension which we used, and the surface, we created the surface group, and we have inlet, exit, and wall free slip symmetrical plane. So finally the generated wind tunnel looks like this, or the enclosure looks like this. Then the material properties of the spoiler or for the spoiler model is being listed here. So material is basically air, and we have given the properties of air here, and the boundary conditions of the spoiler is being mentioned here. So the inlet is 25 meters per second, and outlet is 0 PA, and wall spoiler is no slip, symmetrical plane, no slip, and also wall free slip is specified here. So this is the design of a second spoiler, which is of the same dimension but curved in nature. And this is the dimensions of the tunnel we created, and the same surface group is being created here, and the final volumetric mesh is being generated here, and the same material which is air, the dimension, the properties are shown here, and the boundary conditions is being same, and this is the result we got. And as you can see, the coefficient of drag has come down, and also the coefficient of lift has also come down. So this is some of the calculation for the drag force and also the lift force. So by comparing these two, we got into these conclusions. So the two models of the spoiler, horizontal and curved, were designed the cross section of the car and NACA standards. Enclosures were created for each spoiler, and flow analysis was carried out in the order to determine the coefficient of drag and coefficient of lift. The spoilers were designed by using SolidWorks 2014 and then imported. Then the flow analysis was carried out using our ANSYS workbench. And the coefficients of drag and lift are determined from the report plots obtained, and the values of the drag force and the lift force are also calculated. It is also important to note that the lift is in the negative direction, which is also known as down force, which is more important in passenger cars having increased down force. So the increased in this, the final conclusions are, this increases tires capability to produce cornering force and also stabilizes vehicles at high speed. The third advantage is improving braking performance, and it also gives a better traction. So thus reduced drag force and an increased down force are favorable criteria for a spoiler. It is seen that the horizontal spoiler has a higher drag compared to that of the curved spoiler, whereas the curved spoiler has a higher value of down force. So the curved spoiler exhibiting better properties with respect to both drag force and downward is more favorable compared to the horizontal spoiler. That is our conclusion here. So with that, that is the end of my presentation.
Any questions?
Good evening, sir. Can you hear me?
Yes, sir.
Can you hear me, sir?
Yes, sir. I'm hearing,
Loud
sir.
and clear, sir.
Okay. Thank you very much. Now all the three gazettes are working, I believe, in my system. I'm extremely sorry. There has been some common problem. The two laptops and one mobile cannot fail at a time. And I lost a very important guest, our Great Eastern managerial director. I lost him. But anyway, I'll keep it up with him in the later emails. Thank you, sir.
Okay, sir.
So this boiler topic, is comfortable and needs more trimming.
Yes, sir. Please stop your
You can go to the next, sir. You can go to the next participant.
Mr. Joel. Mr. Joel.
Joel is driving his motorbike, I think.
No, sir, he's a out peak.
Yes, you are driving your motorbike. I can see that.
Good afternoon, everyone.
Yes.
Oh, can I share?
Yes.
Yeah, of course. You can.
So good afternoon, everyone. I would like to thank you for the opportunity to present a paper on wireless power technology in EVs, electric vehicles. So my name is Joel Rodrigues da Costa from Triple Department, final year. So the objective of this paper is to introduce a new analysis concept for power flow in electric vehicles by wireless power transfer using the principle of magnetic induction and magnetic resonance to make charging secure and convenient. So the content talk about wireless power transmission, benefits of electric vehicle, types of charging system, why electric vehicles and why not wires, the motors commonly used in electric vehicles, wireless charging system, dynamic and static, the construction of e-roads, battery management system, advantage and disadvantage, and design and wireless system and PSIM software. So wireless power transmission is a transmission of energy from one place to another without using wires. Conventional energy transfer is using wires. However, the wireless transmission is made possible by using various technologies. Inductive charging works by creating a magnetic resonance field between a transmission pad on the ground and a receiver pad on the other side of the vehicle. This image how we can transfer energy from one pad, the transmission coil, to the receiver coil, one pad to another. So AC supply is AC supply energy is sent to the transmission coil, that is primary coil, and due to the inductive induction or magnetic induction is transferred to receive coil to the load. Second. Yeah, this image talked about electricity. We have the same concept on the image before. We have the electric grid, that is the AC power supply. We have the secondary magnet coil and the magnet flux, magnet field induced current and the receive coil, which is turned into the same frequency. So here is an image of transform. We know that transform is a static device which transfers electrical energy from one circuit to another at different voltage level but same frequency. And here we know the V1 is a primary voltage and V2 is a secondary voltage. Same for I1 is a primary current and I2 is secondary current. So N1 is primary turns and N2 is secondary turns. And E1 is a self-induction EMF and E2 is a mutual induction EMF. So benefits of electric vehicle: energy efficiency, regenerative braking. We know that regenerative braking can increase the range of the electric car. Easy to make autonomous, easy to drive and safe technology, pollution free. We know that all the electric cars have the benefits of all the security technologies like lane assistance, brake, emergency brake system. This is the image of small comparison between electric car and a combustion car. We can see no tailpipe emissions, so no exhaust pipe. Is eco-friendly. So nowadays, here is they show under plus. Nowadays we have the example of Tesla Model S that have more than 300 mileage. Hours to recharge nowadays because of the improvement of technology, we can charge through wireless or plug-in. With fast charge, the time also can reduce, and is more cheap compared to conventional combustion car. So there are three types of charging system: conductive charge, inductive charge, and battery switch. So the first one utilizes connector between the electric power source and vehicle battery. This type of charge is utilized in residential areas or charging station, like in our homes or charging station. Inductive charging, wireless charging coupled with magnetic resonance to transfer power from a transmitter pad to a receiver pad. So the primary and secondary pad, it can be, that is a wireless charging. The third one is a battery switch. That is the most easy to understand. It's just exchange the discharge battery pack with a charged one. It can eliminate the time. Here we have the image of the first one, that is the conductive charging system. On left side, it can be in our home, and right side in power station, DC quick charge. You can charge faster than in our home. In home, we can take 6 to 8 hours charging time. Using DC quick charge, that is level 3, or DC fast charge, it can take 30 to 1 hour or 15 to 30 minutes to get 80% of the battery percentage. And this is the last one, that is the battery. This is the second one, that is inductive charging. Using wireless charging. The primary pad is placed on the road, and the secondary pad is placed underneath the car. From the diagram, we can see the AC supply, AC to DC converted, DC to high frequency AC converted, compensation unit. So the capacitor plate, that is the primary secondary pad, and again to compensation unit receiving in the BMS, that is battery management system. This is the third method, that is battery switch. That is very easy to understand. After using the battery, when the battery is discharged, you just need to replace with charged one. Same thing with our control remote at home or control for games. So the question is, why EVs and why not wires? So the first one, why EVs? So no conventional fuel, cheap to maintain, more eco-friendly, lower carbon footprint, less noise pollution. in smoother ride. You know that every year the price of petrol is increasing. And why not wires? As per study, most of electric energy transfer is through wires, and most of the energy lost is during transmission. On average, more than 40% is energy lost and around the world. In India, is exceeded by 50%. So different types of electric motors used in electric vehicles. So brushless DC motors, permanent magnetic synchronizer motors, that PMSM, AC induction motor, that ACIM, interior permanent magnet motor, and permanent magnet switched Kalutans motor. So now wireless charging system. Wireless charging uses an electromagnetic field to transfer energy between two objects through the electromagnetic induction. Energy is sent to an inductive couple to an electrical device, which can then use the energy to charge the battery of the device. So we can use the wireless to power directly the device or charge the battery and power the device. This is a simple image how the wireless charging system works in electric vehicle. On left side, we have ground assembly, and the left side, we have vehicle assembly. See, this image, we have already explained this before. We have a AC supply, 50 to 60 hertz can be identified with power factor AC to DC, high frequency inverter DC to AC. Again, primary compensation network, same thing from the vehicle assembly, that is a secondary pad. And the air gap, I did the project, a small prototype, and air gap can be between 230 centimeters. Again, secondary composition to rectify AC to DC, filter network, and battery management system, that is battery system. And a communication link is established between the ground assemblies and the vehicle assembly to give information how much batteries, how long it takes to charge the car, how is the power, if it's low or not, and if it's connected or not also, if it's properly, because to get properly charged, we need to place the car at same position, primary to secondary pad. So what is charging system? Electric vehicle are building with the onboard pickup device that allows IUVs to be powered underground power line while driving. That is a dynamic wireless charging system. Or while the vehicle is in park, spot, at home. That's a static wireless charging system. So this allows the vehicle to carry 4 to 5 less battery cells capacity because it only requires a small battery for minimum operation of the power grid in dynamic wireless charging system. So construction of roads for EV. Electric power strips are buried 30 centimeters deep under the road surface and connected to the power grid. In Sweden, the Arland, they built the first electric road with 2 kilometers. That is almost 1.2 mileage of electric road for trucks. And in same country, in same country, they built in Gotland, that is another city, they built the first wireless road for cars, commercial cars, and trucks also. They use level 3 or DC fast charge. This type of charging station or charging wireless on road is charged the car by 80% in 30 to 60 minutes. So I have the photo of the first electric road, how was building, and also some photos of the first wireless charge roads. That is a dynamic wireless charging system. Now let's talk about the BMS. BMS is battery management system. Battery is a device which stores the energy in the form of chemical energy and gives electric output. Battery have high energy density, however high low power density. For getting high energy, a number of cells are connected to form a battery pack. The battery for EVs must be low cost, long life, lightweight, compact, mechanical cell support, thermal management, and waterproof. The battery case is made of steel to create a solid structure. Facility structure. Packs use a robust interior of metal to secure the components. This helps maintain the pack structure in case of fire or accident. We know that nowadays the most safe cars are electric cars because of the weight distribution and because of the battery management system. It makes the car more, the center of gravity of the car more fixed during the accident. These are images of how all the components in battery for electric car. We have battery assembly adhesives. We have thermography, that is in case of the battery get heat, thermal adhesives. We have liquid cascading. We have battery structure adhesives. We have metal treatment. We have conductive coating and impregnation service. Again, we have some more photos of the battery. Here I'm going to explain how a battery pack is formed. We have a module, we have a cells. We know that these can be very component to component. I give one example. Let's assume that this electric car have 30 modules and each module have 20 battery cells. So the total battery cells in the electric car will be 600. So types of battery. There are two types of battery, non-rechargeable battery and rechargeable battery. We know that non-rechargeable battery can be used only one time. This cell works on the spontaneous forward reaction. Example is dry cells, alkaline cells, and lithium batteries. So for rechargeable battery, that is secondary type. The type of battery can use again and again. We need only to charge it when the battery is low. This cell operates near to the equilibrium and reaction are reversible. Lead acid battery and lithium ion battery. We have example of non-rechargeable battery and rechargeable battery. The photon left side up and down is for non-rechargeable battery, and the opposite side is for rechargeable battery. So most use batteries. For portable device, we use dry cells. For electric vehicle, use lithium and NIMH battery. For portable electronics like laptops, tablets, smartphones that we all of us are using is lithium ion battery. So the most common question asked is if wireless charging is bad for battery, if it can spoil the battery or not. Till now, this technology is not that long in market. It's very common now in cell phones, not that much in cars. So, but according to the cell phones, there is no problem using wireless charging to charge the battery. We assume that same thing is happening for electric cars, and is more safe than using wires or plug-in. I'll explain about battery packs, so I'm going to talk about a little bit more. For large amount of energy, we need a number of batteries. For this purpose, batteries are connecting in series and parallel, or a combination of both. Series connection, the voltage of batteries increase, and parallel connection is opposite. The current of the batteries increase. When the batteries are connecting series, the voltage is increased. For example, a 2-voltage battery connecting series produce 12 volts. When the batteries are connecting parallel, the voltage remains same. However, the current increase. This means that the battery would last longer. This is an example of the connection of series and parallel connection for the battery, in case if you want current or voltage. So advantage of wireless power transfer for electric vehicles. 90% reduce operation cost than equivalent gas power vehicles, lower maintenance cost, 0 recharge time if you are using dynamic wireless charge that I explained before. That is when you're using the wireless charge on road. It's more safe, convenient. Electricity can be, we can power the electric cars using renewable energy source like solar and wind energy and so on. It's less expensive and less frequent maintenance. So the disadvantage of wireless power transfer is for electric vehicle is energy lost. We still have some loss using wireless power transfer for electric cars. That is around maybe not more than 50%. Building infrastructure, I mean like roads, to to have this technology right now, we need to destroy all the roads we have and again build and again all the roads, and for wireless, and is a high cost and not economic sense right now, and health effects. So now I'm going to talk about the PSIM software, that is electric circuit simulation software, where I did my project simulation. Here is the circuit of, we know that I talk about primary, secondary, primary, secondary wireless coil. That is the wireless transmitting unit is in primary and the receiving unit is in secondary pipe. So, in transmitting unit, you have AC power supply. It can be a 12 or more AC to DC converters, high frequency oscillator, high frequency and half bridge driver, high frequency and half bridge inverter, again high frequency switching transform and resonant transmit antenna. Now when you go to the
Joel.
Yes, madam.
Yes, your presentation is beautiful presentation, but you are exceeding the time limit.
Okay, I go faster.
Try
Thank
to
you.
okay.
Sorry, this is the diagram we use. These are when you use the transmitting receiving circuit. This is the PWM powered modulation waveform, and it was the output. So I'm going. So I like to conclude that electric vehicles is getting the market is increasing year by year. So it's more cheap, more convenient, and more safe to the conventional cars. That is a gas power car. So thank you. This is the reference paper. Any questions?
Any questions?
Your presentation is very good presentation. Wonderful.
Thank you. Thank you so much, madam.
Thank you.
Should I close the presentation or they have some questions?
Ramurthy sir.
Yes. Any questions? You can close your screen, Mr. Joel.
Thank you so much for the opportunity once again. Stop sharing.
Sandan Das. Are you ready?
Yes,
Please
sir. Yes, sir. I'm ready, sir.
Make your presentation.
Good afternoon, everyone. At the outset, I would like to express my sincere gratitude for giving me this opportunity. My name is Spandan Das. I am currently studying at second year B Maritime in Amit University, and today I'm going to present. Excuse me.
Oh. Please share your screen.
Yes, sir.
Okay, thank you so much.
But it was clear, sir, when I speak. Today, I'm going to present the GSM-based induction motor control for agricultural sector. The author and the co-author are Mr. M. Bimal Raj, Assistant Professor of EEE Department in Adi Parasakti College of Engineering, and Dr. M. Tamilestri, Assistant Professor of Marine Engineering Department in Amit University.
Okay, so I do better next time. Yes, how long I could go next time?
The main focus of this project is to do automatic irrigation system by controlling a water. Soil moisture sensor is used to measure the amount of moisture content present in the soil, and water level sensor is used to monitor the level of water is high or low. The farmers can start the motor without even going to the field by using GSM technology. The GSM modem performs the task of receiving the message from the mobile and sending the message to the mobile from the controlling unit. Sensors output data can be fed into the Arduino board. It acts according to the control algorithm. On the next slide, the purpose system is drawn. Firstly, the soil moisture sensor will read whether the soil is dry or not. Once it detects the soil is dry, it will send the data to the Arduino. From the Arduino board, it reaches to the GSM, and then the command reaches to the relay, and water pump is turned on. After receiving the sufficient amount of water, the water level sensor detects it and again the data is passed to the Arduino. Then to the GSM, single channel relay, and the pump is turned off. Next, we have the working of GSM-based agricultural motor control. The GSM is a wireless technology having its own unique number. GSM is connected to Arduino. After receiving the data from the sensor, GSM forwards it to the Arduino, and then the Arduino will make the relay input high, resulting in turning on the motor pump. And in this way, our smart irrigation system will start supplying water to the crops. The procedure remains same while turning off the motor. Here, the Arduino makes the relay input low and cause the shutdown of the water pump. Then the flow chart of the project is displayed. Start, GSM will check the data is available or not. GSM will keep the reading, receive data. Then string will be motor on. Motor will be on in this, and it is called state 1. Once the sufficient amount of water is reached, motor state will be in its previous state. That is, string will be off, motor will be off, and it is known as zero state. And the motor will remain in this previous state until it receives further data. The water pump motor update will be sent to the recorded phone number in code by GSM. Next, on the right hand side, we are having the motor, and on the left hand side, the Arduino board and the sensors are displayed. At last, coming to the conclusion, the farmers can be hugely benefited if these projects get implemented successfully. More efficiently, the productive farming can be performed, and this project can bring dynamic change in the industrial level motor controlling system too. Moreover, it needs to be kept simple as possible, so it gets easy to interact with more farmers at a greater extent. Thank you, sir. Thank you for giving me this opportunity. That's all, sir.
Mr. Vel Murugan. Harish, sir.
Sorry, it's not in the other list.
Yeah, he is visible to me. Vel Murugan.
Sir, Vel Murugan sir has joined already.
Yes, sir, already.
Yeah.
Already. I'm in the list, sir, now. I'm able to see you, sir.
Yes, yes.
Okay.
Can you
Yes,
make
sir,
the
you can go ahead,
presentation? Please make the presentation, sir. Please start. Please start your presentation.
Sir, you're telling me, yes, sir, Vel Murugan, myself.
Yeah,
sir.
Vel Murugan. Yes, Vel Murugan, sir.
Okay, sir, I'll start it. Let me open the presentation. So is it visible, sir? My presentation, sir? May I know it, sir?
Yes, sir. Yes, sir. Yes, sir. It is visible.
Okay, fine. I made it full screen. Sir, is it visible?
Yes, sir. Yes, sir. Now it's full, sir.
Fine. Okay, now my topic, let me introduce myself. I'm Vel Murugan, and I'm working as an associate professor in the Sri Jayaram Institute of Technology, Gumudi. And myself and my co-author together have prepared this, and I am going to present the title paper, Artificial Intelligence Techniques in Robotic System Design Optimization. So let me give an introduction about that. The robots, particularly we are using the humanoids for extremely, we are using some complicated dynamic systems. And nowadays the robotics has been usage increased in both the industries as well as in the domestic purposes for doing some very routine jobs, as well as nowadays robots are used in many space and as well as in the defense sectors. So for this, we are going for some new types of robotics like that mobile robots, and in which the mobile robots having the problem in identifying the target, and if any obstacle comes in that, we are finding difficulty in going to the target. Beyond the target, we have to identify the obstacles, and we are having some different types of path. So we are going to make that path optimizations. So hence we are going to present that path identification. So here we are going to give the introduction first and how we are going to proceed with that by using optimization technique, how we are going to arrive at the final optimistic value of a path. So these are all the introduction about the robots. So different types of robots we are having, the picture robots as well as the moving robots, and here we are going to demonstrate the moving robots. So these are some challenges in the optimization of that. So the variables in that alternatives may be discreteness or continuous. So even the wing types. So these types of optimization we are going to do it, and there are non-linear relationships with the design variables. And it is expected that many local optima exist since the multitude of the robots combinations. And another one is the multi-objectives have been optimized. So these are some challenges in the optimization. So here we are going to optimization robotics applied to best fit solution for increasing the 3D space precisions. And nowadays we are using the mobile robots even in the space. So even any obstacle comes, it has to take a diversion and it has to go for that. And we are going to target that the optimistic path so that it can reach it very in lesser time so that we can have that ideas. So this is optimization. Directly we'll be going to the path planning strategy. So we are coming with some 4 types of categories: analytical methods, enumerative methods, evolutionary methods, and meta-heuristic methods. Each of having its own advantages and disadvantages of the path planning. And this gives us some description about the path planning and what all the versions. Let me go to what I have did, and different path planning is also available. So we can have the difference between the classical approach and artificial intelligence approach. In this artificial intelligence, we are going with some 9 types: neural network technique, fuzzy logic technique, genetic algorithm technique, and colony optimization, particle swarm optimization, bacterial foraging optimization, bee colony, firefly algorithm, and gray wolf optimization. In this artificial intelligence of this robotics, we are going to use the genetic algorithm technique for finding out the best pathway that the mobile robot can go. So this is the actual robotic arm or the manipulator, which is been created in the CATIA by using the bottom as well as the arm and the end effectors. So and these are some of the robotic layouts that is been for the fixed robots. And here we are going to deal with the mobile robots. So for mobile robots, we are going to analyze by means of. So this is the mobile robot. The part that we are having the downside is the wheels, and whereas the wheels will be having the ability to move, so that the top portion is the robotic arm in effectors, so which can go to the target and it can do the work. And one more thing is this robotic path sample we have shown. There are some, this is created in the CATIA, and it is been some obstacles are in between, so that the end point and the starting point are given. How we are going to connect it, and we are, by using the genetic algorithm technique, we are going to do some analysis in that. So genetic algorithm path is we already know it's a way of optimization technique. Path planning is we are going. So path planning is important research direction in the field of mobile robots, and it is one of the main difficulties in research is the path planning is safest and shortest path. That is important. It has been indicated that safest and shortest path. so that we are going to find out which is the shortest path, and accordingly we are going to do it. So here we are going to use the genetic algorithm here. So here the initial pop, we have to the steps in the algorithm of the AI interfaces. Initial population, calculating the fitness, which is the fittest, the selection of the parent, and the crossovers and the mutations. So these are the steps that you need to follow in the genetic algorithm. And we have shown the path. So one is the start point, and another one is the end point or the goal point. So there are various paths available, 1, 2, 3, 4. Accordingly, we are going to plan it, and we are going to find out which is the parent and which is the child, and how we can give the better paths, or in which we are going to optimize it. So these are in the part 1, part 2, which is the feasibility and obstacles we are going to see. Like that, we are going to tackle. So here you can see some maps we have drawn it. On the maps, we are going to have a map of square area, so that we are having a square area of say some the 15 square meters. So we are from the 0, we are going to locate the point number 15 where the target is. So here 0 is the starting point and 15 is the end point or the goal point. And for that, we are going to come out with some X and Y values with respect to the binary codes that is being generated by using the maps that we are given here. So you can see that various paths are available in that. In that path, the robot has starting point and goal point. So for example, in that part, you can see 0, 1, 4, 12, 9, 8, 15. So 0 to 15, we are going towards these points so that we are going. So whereas when PS is the starting point and PG is the goal point on the 15. Now we are going to check out what are all the ways that we can go to the goal point. So here we used to say that in between points or node points, we used to show that the chromosomes, which is represented by the string bits, and natural representation is the binary we are going to use. First of all, we are going to identify which is the better and having the parent, two parent strings, and based on that parent string, we are going to identify that. So the parent is like that 0, 1, 5, 10, 11, 12, 15. And another parent is 0, 3, 6 as per the given maps. 0, 3, 6, 4, 5, 10, 9, 15. We are going to. So here, in this map only, I have found out the parent. So 0, 3, 6, 4, 5, 10, 9, 15. Here we are having the 10 as the same value. So it is matching, so that we are going to have a common line over here, and we are going to find out the child. So in that beyond that 10 values, that common point, we are going to interchange the values so that 9 and 15 will comes over here, and the parent 1 and 2 level equal. So it is being intersected for the common point, and we are getting the child. So like that, we are going to do that. This is been done using the MATLAB, and we are going to find some iterations. So how many different types of path that can be generated using the binary values, and we are going to select which is the better one. And this is the formula for the chromosome CN equal to M into 2, so that we have to come out with the XY values based on the binary values. So in our problem, we use the two common genetic operators. One is the crossover and the mutation, which I was shown earlier. So the crossover is nothing but that parent and having a common point. Based on that common point, we are going to exchange the values, and we are generating the mutations of the children's. So the above is tested via the simulation using MATLAB. So the simulation environment has a powerful string manipulations, and we are going to come out with some points. So these are the iterations which are in the binary values, and these are the possible values which some like that we are going to generate one by one the path value, so which we are having the better one, a optimistic value, so that it can have a lesser time to find it. So as a result of the optimization by using the, I have not shown that the simulation that has been done in the MATLAB. Simply I have given the selected the values and I have put this. As a result of optimization, we are getting that 2, 0, 2, 14, 11, 13, 9, 8 and 15 as per the value of the map. I'm getting the better and best, which is having the lesser amount of time. It has been required for around 17 minutes or like that. and identified as optimization value. I have not elaborately discussed the matter, but it has been optimized using the path values. This is the best value. So based on the path selection of the robot and the parental values and identify the child is muted with the best possible solution, which the path of the robot can be optimized. The value is used based on the heuristic values. So this is my conclusion. From this, I end my presentation. I have quickly go through it. Any questions I can answer for that. Thank you, sir.
Any questions? Hello. Any questions? Sir, thank you. You please close your screen, sir.
Thank you, sir. Thank you, sir.
Next, Mr. Gurukeshwar.
Sir, Gurukeshwar is here. Can you hear me, sir?
Yes.
Can I start my presentation, sir?
Yes, yes.
Yes, sir. Thank you, sir. Is my screen visible, sir?
Yes, it is visible.
Yes, sir. Thank you, sir. I'll start with my presentation. Good afternoon, everyone. I'm Guru Keshav from Department of Marine Engineering, final year. I'm here to present my paper, Artificial Reefs and Wire of Tamil Nadu. It's an interesting paper. It's guided by Dr. Sendil Nathan. He's from Amit University. First of all, my project is regarding coral reefs. Coral reefs are nothing but an underwater rainforest. It's an animal, actually. It lives underwater. So many polyps to make some coral, and so many corals make some coral reefs. This is the zoomed picture of a coral. And coral reefs, they just grow like 0.3 to 2 centimeter per year. It's very low. And they are located in tropical region. They don't live in polar regions or where the temperature is too high or too low. They live in a moderate temperature. And the importance of corals are they are used in medicine purpose, and they are fixing nitrogen fixation and nutrition recycling, and they product shores, and they are like a home for fishing. And coral reefs are one of the most valuable ecosystem in the world compared to rainforest and other grassland, rivers, lakes. And coral reefs contains the most ecosystem in the world. It contains the most species all around in the world. And coral reefs contribute around 375 million US dollar every year. It's a very huge amount. It just present 1% of oceanic surface, but it contributes a very huge amount. And people usually think that plants gives more oxygen, but it's not. Ocean gives more oxygen, actually. Ocean gives nearly 50 to 85% of total oxygen we breathe. And most of the oxygen is produced by coral reefs, actually. It's not directly produced by coral reefs, it's produced by phytoplankton. It's an algae which is present in ocean. But coral reefs are dying, actually. 25% of coral reefs are already dead, and almost 90% of coral reefs are in danger. And my project is regarding how to save coral reefs and in Tamil Nadu. And corals die due to rise in temperature and decrease in temperature, salinity, and so many other reasons. And as I said before, trees don't give much oxygen as we needed, because there are so many greenhouse gases trapped in our atmosphere. We need to get back the greenhouse gases. So we need different alternative sources, which can be done by ocean, but we need to save ocean in a new technological way. As I said before, phytoplanktons, they produce more oxygen than plants. These are the phytoplankton, which is an algae which lives in ocean, which is mostly present in coral region. But corals doesn't grow fast. We need a method to grow corals fast. My project is to grow corals fast. So we can, in exchange, we can protect shore and some other activities. My project is Biorock technology. It's actually invented by two scientists, Wilfred and Thomas Gorio. And Thomas Gorio is my guide. He's from California. His organization is located there. And he's currently doing this project all around the world. I'm planning to do this projects in Tamil Nadu, and I have already did this project in India, in Gujarat. And this is the basic information of the project. We build an artificial structure, which could be in any shape. We use rebars basically, so it's a metal structure. We electrocute the structure using anode. It should be a DC power. It should be very low voltage, which is not affected to any marine organism or humans or anyone. It's very low voltage. Not even a single fish can feel the current. This is a structure I have told before. We build a structure and we place underwater, which act as an artificial reef in place of coral reefs. So it is a basic place for corals to live and where fishes and other activities can form. This is my team in Gujarat. We will attach corals to the structure so it can grow very fast. That is the nano structure I was telling before. The white pipeline which is going below, that's a nano structure. We place a mixed metal oxide anode. For power source, we have used solar power, and we can use any other source of power for powering. We have used solar power because it's very far from the shore, so we are using solar power. And we can use any kind of metal. We specially use construction rebars, which is cheap and also very efficient. It could be at any shape and any size, so it's all about the power source we are giving. This is the electrical process which is going underwater. As we power the structure, there is an electrolysis process in between cathode and anode, which forms calcium carbonate around the cathode structure. So the cathode structure is act as a coral reef, and corals come and settle over there, and they grow very fast. So it helps corals to grow very fast, and also they are resilient to climate changes and global warming and so many other sources. So we pick little fragments from nearby broken reefs and we place in the structure using metal wires or any wires. So you can see the picture, the corals grow very fast. This is like a very short time. Corals just grow 2 centimeters per year, but due to this structure, it can go nearly 20 centimeters per year. And what is the use of this project is, basically in Tamil Nadu, what I'm coming to say is we have so many problems in fisheries. People go to Sri Lanka and so many other places to fish because there are rich coral reefs over there. But if you're going to bring coral reefs to nearby regions, Tamil Nadu, we can achieve the fishes over here, and there will be a massive growth of fishes here. So economy of fishermen will be increasing, and there will be a good communication between Tamil Nadu and Sri Lanka also. And it protects the shore. Coral reefs act as a barrier where soil erosion and beach erosion can be stopped. It acts as a barrier. So you can see a picture. Still now 8 beaches have been restored using this technology. This is a beach in the Maldives. They are placed on structures over here. You can see a dead end over here. And they have placed structures over here. Then beaches have grown back in very short time, in 3 years. So you can see the massive difference. If you're going to bring this project in Tamil Nadu, we can bring back beaches in massive rate. The current technology Tamil Nadu and other Indian peoples are using is pouring rocks over here near the shore, so which act as a barrier and stops land erosion. What happens in this is there is a negative. What is negative erosion happens? Here there is no erosion. You can see in this picture, in this area, you can see a negative erosion which is 2 to 3 times faster than the protected area. So this is a very bad situation, and we are losing beautiful beaches over here. We can make more economical value if the beaches is available. So we're losing beaches and also land. So this is a very important problem in Tamil Nadu. Using this project, I have said before, we can save coral reefs and protect against global warming. This is a 4 years old reef in Bali. This is very big reef. You can't imagine. If you want to grow naturally, it will take like 100 years. But in 4 years, we have achieved a big success. This is also another reef. I told you before, it can be in any shape or any size. With this, we can build an eco-tourism also in Tamil Nadu. It could be an economical growth for Tamil Nadu also. This is a project done by my guide, Thomas Gorio, in Bali. There is 1% of coral living over here, and after building of biorock structure, there is 99% of corals have started living over there. It is a spawn of 7 years, very short spawn. Actually, if you want to do this natural way, it's going to take like 100 to 200 years. And using this project, we can also restore seagrasses and salt mosses and oyster reefs. There are like so many values for this project. This is a graph which represent soil erosion, which is going high. And India, almost like 45% of land is facing soil erosion. And what we in Indian scientists and all the institutions are doing is lay rocks like this and protect the beach. This is a good idea, but we are losing the beach where we can spend the day. And there are so many values and so many economical price will be rising if the beaches are there. We are losing our beaches and land, which is very fascinating. So as I said, this project can help to restore the beach without losing our like beautiful beaches. This is also a project done in Maldives. They are bring back the beach in 2 to 3 years, 15 meters of beach. You can see a wire of structure which is placed underwater. And as I said before, like it will automatically increase the fishery growth. If there is coral reefs over there, there are going to be millions of fishes roaming around that, and it's directly or indirectly going to increase our economy by increasing fishermen's economy, and it's going to increase Tamil Nadu value also. And I have officially collaborated with Global Coral Reef Alliance to do this project in Tamil Nadu, and soon I'll be doing this project. And so many other organizations from China and all over Tamil Nadu appreciated this work and is ready to support for this work to bring this project in Tamil Nadu. These are the main 7 core values of this project. If you bring this project here, first one is fishery restoration. As I said before, there is going to be more fishes if there is a coral reefs over here. So we are bringing it artificially. If you're going to do it in a massive scale, then you can imagine the value of this project. And second point is coral reef restoration. Coral reef is one of the most valuable ecosystem I said before. We are saving that. We are protecting against global warming. We are ensure protection. This is automatically forming a barrier. So it got a multiple use. It's going to protect the shore and beach erosion, and its adaptation to sea level, same as beach erosion. And sustainable aquaculture. We are not what to say. We are not doing artificial fisheries over here. We're not using any steroids or chemicals to grow fishes over here. We're doing it in the ocean and also in a sustainable way. So it's an artificial aquaculture. And we are saving at 530 million old species. Coral reef is one of the most oldest species in the world. So we are saving that species, and it's environmentally sustainable. No harm for the nature. Nothing. Still no negative points has been produced. Negative value has been noted with this project. This is the second project I've designed for Zoological Survey of India. This is going to be the second biggest project of India, which is 5 meters in long, which is already placed in Gujarat waters. This is my team, and thank you so much for this opportunity, and thank you for my guide, Dr. Senthilnathan sir. He's one of the most backbone for me for doing this project, because I'm a marine engineer and he supported me to do this marine biology project. And thank you for my dean, Bhupati Bhaskaran sir. He motivated me and he allowed me to do this project, and he was always being with my side, and he allowed me to go to Gujarat and explore the world. Thank you so much, sir. Thank you.
Any questions?
Thank you. Yes.
So any questions?
First and foremost, thank you, Guru Keshav. Can you hear me?
Yes, sir. I can hear you, sir.
Yeah, it's something great, because afternoon session somehow I lost the mic volume, and now I got it back, and I come to see this your wonderful participation in so much of a research work that you are doing.
Thank you so much.
I still remember, at times giving you a little caution. And one day when you brought your parents, your mother came along with you and took permission. That's the time I gained confidence in my heart, because, a career underwater sea is not that easy, because it's like walking on a knife edge or a thin string of a small wire, string of wire, I should say. It's, it can snap anytime, and it's life or death, because underwater pressures are very, very high. I did ask you about how depth it is and so on. I'm here very, very happy now you have achieved, and I want you to achieve more heights, because
so
I
much.
didn't know much about coral reefs. Now, when recently close to our Tamil Nadu coast, they lowered some buses and other things for development of coral reefs. That's the time, I recollected you and I went through in depth. And, it's something great. I hope you keep up your health well, because you seem to be slimmed down a lot. Yes, it's good, but at the same time, don't slim too much. Have your body mass index maintained well. Your breathing exercises, you have to be very, very careful with your breathing exercises, because you're going to you'll be using your SCBA sets quite often. Different types of sets, different timings. Don't take beyond certain limits risk. At the same time, with caution, with your guiding you. Wish you all the best. It's a great achievement. Keep it up. I thank you.
Thank you so much.
Now you have become an alumni. Is that right now?
Yes, sir. Yes, sir. I mean,
yes, good.
Yes, sir.
Yes, you have become an alumni. Wish you all the best in your lifetime. Thank you.
Thank you so much, sir. Without the support of Amit University and other staffs, and I could have not achieved this. Sir. Thank you so much, sir.
Thank you. Thank you very much. Thank you.
Sir, Dr. Suresh, shall we plan for the valedictory?
Oh, I'm sorry, madam, for taking
What about Ramurthy, sir?
Sir, one more participant is there. Mr. Aman Vishwakarma.
Good evening, sir.
Can I present my screen?
Please make it fast.
Make it fast.
Sorry, madam.
Aman, the time is only 10 minutes mark.
Sure, sir. I'll try to finish within the time, sir.
Yeah.
Thank you.
Is my screen visible?
Yeah.
It's visible.
Okay, thank you, sir. So, 1 second. Good evening, one and all present here. My name is Aman Vishwakarma. I am from Mechanical Department, final year student. And I've done my project on analysis of hull design and hull construction cost estimation. And so what is that project exactly? So this is project to how can we reduce the overall cost of the hull construction? Like for constructing a ship, it would take around crores rupees. So what parameters we should use and how we divided the cost in various parts, in various forms. So overall this thing cost should be reduced. So there's this thing. So how we can use the different of cost, like I've used here 6 parts, like the labor cost and timing analysis of welding analysis and the material cost. So these are all gives me a final cost, which will be accurate. And since we all know, we all are talking about technology and industry 4.0, but this is very important to understand. For making any technology, it would take like unexpected money. So how we can use a better system to to calculate the overall price. So what I've done here, I've divided in 6 similar parts, like the weight of the metal and the hull design and the cost analysis and the labor cost. So I've done more than 16 literature reviews, and due to the time, I've gone to the direct summary of literature review. I found something very interesting and common in all literature review, which is the shipyard labor cost and the material cost and the life cycle cost, how it will be benefited for industry 4.0, and how we can extend the ship hull's life. And this is the methodology which has been used. So the cost model and the material cost and time analysis, machining cost, labor cost, and data calculation. So this is the ship which I've used, a bulk carrier hull, so which is 147 meter long, and this data I've given here. So using this data, I've made this design. I've used a software called FreeShip. So FreeShip, due to this software, I've generated the perspective view, profile view, and the plan view, and the body plan. So this is my whole hull looks like, and this is the body plan, and this is the structural hull, which is I've plated the diagram here, like P1 to P20 and B1 S1. This is the plate I'm going to use. So this is the hydrostatic value which I've got from the this thing, free shift software, which is generated by the software. And as you can see, that area is given and the thickness of material I'm using and the weight and the total tonnage. So cost model. So I've divided in 6 simplified parts: the work, preparation cost, cutting cost, transportation cost, forming, assembly, and welding cost. So this is the generic formula which I've used to calculate the overall cost. So these are the formulas which I've used, and I've taken this formula using the rule book called Ship Construction. And this is the steel. I'm going to use stainless steel grade 304, which is widely used in marine, especially for making yachts and the big structure, because it would increase the ship's hull's life, and because it has ability to deal with the salt water. And this is how I calculated the total tonnage and the gross tonnage and the weight of the hull, which is 702.48. This is the total dead weight of my hull. So this is the total area. Through that area, I've specified like how many number of steel plates are required to make the hull. So this is the front part of the ship, which is called the bow, area of the weight, and how much area it would take and what is the weight of the bow to make the steel and to construct this part. And this is the stern, which is the back part. So I've divided in 3 simplified parts to understand how we can use this. So this is the mid, which is the center part of the ship, which is 229.3 tonnage. And what is the price of steel with a thickness of 15 mm, which I've mentioned, it comes around 24,93,360 rupees for 5,894 plates. And this is the standard thickness which I've used here. So as per the standard thickness, the cutting speed would it be. So this is, I've calculated value. Since I'm doing this project estimated, so everything is estimated, nothing is real here, because there is a difference between estimation cost and the real cost. And so I've done this thing, how much spend time on the cutting task. So for make it easy, and the distribution time, how much time it would take, I've converted in pie chart as a percentage form. As you can see that 48% time, 48% it would take for the cutting and the marking, and 22% for positioning. And this is the cutting job. And this is the pie chart for different parts of which I've used, like plates and part, cutting head, parts reference, CNC loading, and everything. And this is the fun part of the bow, which I've taken from Google. And so how much, this is the thickness and how much time it would take for the construct this. So this is the forming time for the front part. And it would take for assembly and welding for 35,124 man hours. And I've divided in this way. So how much take in 1 day to day 3, total time and the total clips. And this is for stiffeners. And so this is the welding blast, which is flux core arc welding gas, like how much time it would take and according to the speed and the thickness of the plate. And this is the block, which is, this is the real looks diagram of the block. So as you can see that stiffness is inside. So my main motto is doing this project is to, how can we reduce the overall cost using the specific things. This is the block width of the associated welding length. So I've divided in my parts and I estimated how much it would take for welding length, discontinuous length, and the continuous length, and the weight tonnage according to the requirement. And this is my total welding and the continuous welding and the intermediate welding. And this is the blocks which I've done. So for the measurement according to the breadth, height, and the mass, and the weld size. And so this is the cutting overall, the transportation resources, what things should be used for transport each part from one place to another. And so this is the preparation, cost, timing, and distribution of cost activity. And this is the man hours activity and result, and what I found in result. So this is my result and this is the total cost. And since I've told it is not possible to use 100% of steel because 75% of steel is only going to be used. Rest of the 25% still as a scrap. So what I've done, I've divided in 6 simplified parts here in order to get the final price of the estimated ship. And because it is really, since like I'm from the mechanical department, I know what is going to be happen after 10 years. I know what is the future. Same innovation is going in the shipbuilding also. Same. So since everyone is talking about new technologies and all, this is the main key to get a successful how would say, a good price. So this is the way we can reduce the total cost with the help of timing and the labor cost and the all analysis without wasting time. So thank you so much. And I'm open for the questions.
Sir, thank you. Thank you for your wonderful presentation.
Thank you, sir.
Yes, sir.
Yes, all the participants have sleep.
Hello. Hello. Good evening. Good evening, sir. Is it
Ma'am?
Register, sir, speaking?
Just 1 second, sir. Please come. Register has.
Oh, sir. Sorry, sir. Sorry to disturb you, sir. I have noted down your number. For the validatory function, we are looking for the register. Sir has not come. That's why I called up by mistake. I called you, sir. Okay, sir. Sorry, sir. Sorry, sir. Thank you, sir. Thank you, sir. Thank you, sir. Yes, sir. Yes, sir. Thank you, sir. Right. Madam, we can go ahead, madam. His phone is switched off.
Oh, yes, yes. The guest has joined, Dr. Vijay Kumar Banga from Amritsar. Sir, you can unmute your mic.
Yes, ma'am. Thank you.
And other speakers also available. I think our foreign speaker, Poland professor, Dr. Irak. Welcome, sir.
Yes. Yes. Welcome, sir.
Madam, you can proceed now. Go ahead.
Thank you, ma'am. May I now request Dr. Suresh Alex, Professor, Department of Marine Engineering, Ahmed University, to address the gathering.
Happy evening to one and all. I am Dr. Suresh, Professor, Department of Marine Engineering. Welcome you all for today's validatory session of International Conference on Disruptive Technologies in Maritime Sector Industry 4.0. It is our honor itself to honor this beautiful audience who gathered here. A very warm good evening, ladies and gentlemen, galaxy of intellectual, invited guests, faculty members, and all the participants from various prestigious institutions across India and abroad. On behalf of Ahmed University, I extend a very warm welcome all of you for this validatory celebrations. I could see a unique and talented mix of participants who made this happen have come to us from various places is the witness of this event. Once again, I welcome you all.
Thank you, sir. May I now request Dr. Tamilarasi, Assistant Professor, Department of Marine Engineering, to introduce the chief guest of the valedictory session.
Thank you, ma'am. Good evening to one and all gathered here. It gives me great pleasure to extend you a very warm welcome on behalf of the Department of Marine Engineering, which clubbed all of us for the international level virtual conference on disruptive technologies in maritime sector industry 4.0 validatory system. I take this opportunity as a privilege to welcome Professor Dr. V.K. Banga, Principal, Amritsar College of Engineering and Technology, Punjab, for this validatory session. Dr. Vijay Kumar Banga has 20 years of varied experience as principal, dean, professor, and head at various education establishments of repute. A young, dynamic, burgeoning personality, PhD from Shahpur University, Patiala, MTech from Punjab University, Chandigarh, and BE from Punjabi University, Patiala. Dr. Banga nourished his interest, accumulated his expertise, and keenly involved himself in research in the fields of artificial intelligence, image processing, robotics, and automation as well. As a career beginner, he took his first step as a distinguished dedicated teacher with LLIERT MOGA in EC department. Soon he demonstrated his edge not only in teaching but administration and management of vital areas. Dr. Vijay Kumar Banga has provided leadership as Principal Amritsar College of Engineering and Technology, Amritsar. His volume and research stick through 50 publications in international journals, 37 international and 28 national conferences, guided 42 MTech and 3 PhD theses. These achievements are highly motivating and enthusiastic for the young mind. Dr. Banga is a teacher, is a researcher, a guide, administrator, and a true humanitarian for excellence. Let's welcome Professor Dr. V.K. Banga to give his chief guest address for the validatory session. Sir, the stage is yours.
Thank you, ma'am.
Thank you for giving me such a warm welcome, and I am extremely grateful for joining this international event, a virtual conference on a disruptive technologies in maritime sector as per Industry 4.0. So first of all, I want to congratulate all the organizers and the team of AMET University for taking this initiative, and it's a wonderful conference. I have just listened few papers I have joined this session around 4:15 p.m. So very good work presented by both of the researchers. So it's a really good initiative by the university and the organizers. Regarding my presentation, although it's a different domain, but still I try to put some effort so that I'm able to come in such a big galaxy of people. So I am also contributing that a little bit. So here I am. I will share my screen with you. Yes. You are getting my screen?
Yes, sir.
Okay. So today my topic for this is AI robots in maritime. So just to try to relate artificial intelligent robots with the maritime, and there is a huge applications in a maritime. So it's like a combination of robotics, artificial intelligence with respect to maritime and marine engineering. So outline of my presentation as a brief, ocean, introduction about oceans, importance of oceans, some formation of oceans and marine pollutants, and some kind of role of robotics in marine, artificial intelligence, and some AI robots as per Industry 4, and role of soft computing in robotics, and AI robots 4 oceans, and just try to relate the boats with the oceans or maybe to the marine engineering, just a little bit effort in that. So, like we all know, 70–80% water is all around us on this globe is in the ocean. So almost 3/4 of our Earth's surface is covered by ocean. And even our body is also 70% contain of water. So it's a like a very big role everywhere in our body, in our Earth, of water. So ocean affect all living things and are important to life. They provide place of many organisms, like we know in ocean there are so many living organisms living there, and which will help us in numerous ways. And it also helps in transporting the things, or even allow animals to like live in this oceans. And similarly, we use a ship route. Through ships we can transport materials throughout the world. Secondly, oceans also help in providing food and medicine and salt to us, because we need a food. Like ocean, we will get so many seafood from it. I think so huge population will we get food from these oceans. And similarly, we may use some rocks and some sea like animals and all for using in various medicines, as well as we also use the salts which we can get from the oceans. Another way, like importance, we all know oceans are very important for all of us. So most of the earth, we know rain and snow comes from the evaporation of the water which we get from the ocean. So by the heat of the sun, a lot of evaporation occur through a sea, and which will becomes a cloud, and definitely we will get a rain, and definitely we will get a water. So 70% of another important factor is like we all are contributing. Like every day we say plant more trees, more trees. Definitely trees are very good for us, but on the other side we will get a maximum oxygen from the sea. So it means we have to preserve our oceans also to get a better oxygen, to get our environment healthy. So we have to take care of it. And we know from the like how oceans are formed. Like there is a volcanoes exist in the so million of years back, and then we get a like many volcanoes we get a lava, ash, and gases along with the volcanoes, and somehow we formulated so much land over the Earth's surface, and definitely we will get these gases evaporated, and then they like added in an environment, and they become like clouds, and definitely by raining, and we will get a clean water for drinking. Eventually, much of land was covered with the water and formed the ocean. So it's like a evolution of Earth through volcanoes and all, and definitely we will get this oceans as well as our Earth's surface. So the major issue is our marine pollution. So we all know like there are so many substances which is hazardous to human, as well as hindrance to the fishery, as well as for our marine like life. This is a greater concern for all of us. So like every year 8 million ton of plastic end up in the ocean, and by 2025 it's come to be predicted to be a double. It may be a 16 million ton every year. And currently there is a 245 million ton of plastic floating on the ocean surface, and some heavier material is already like sink in the, and which is in the sea floor. So again it is a great pollutant for us. So ocean plastic dissolves into a microplastics, which definitely comes into the body of fishes, birds, and even comes to our life also in the humans through these animals, through these sea organisms which we consume as a food also. So this is a great concern. I think through this conference, definitely marine pollution, definitely you take up this issue greatly in this, and it is a major concern for our survival on the earth. So like there is a different sources which again create this pollution, which is kind of sewage, pesticides, plastic waste, metallic waste, oil, sedimented plums, heat, radioactive waste. So every waste to be moving toward the sea. And definitely it will create a problem for us. Oils also, where ships we will, like our ships sink different oils in this, which is contributed again in a pollutants. So how we prevent all this? It's a great concern. And robots play a vital role in cleaning this because it's a huge task. It's not possible by a human being to do this job. And definitely it's a continuous job. And definitely we need to help robots. So there are a few robots like Crabster and Water Shark, and there is a marine Roombas. And these kind of robots which autonomously move in a like our ocean water, and they are cleaning regularly. And we need so many robots so that because it's a 70% area of our surface, it's a big and huge area. It's like whatever effort we are currently doing, it's very little as compared to our oceans. And similarly, robot crabs that monitor the sea floor, robots crabs basically move down in the sea, and definitely they clean up they pick up the plastic materials and all through various sensors and image processing, and able to clean the area in the sea surface. Similarly, a solar powered autonomous boats that improve ship fuel efficiency. And we also use a water shark kind of inspired robots that may be form of the drones also that eat a marine litter, which is floating over the surface. And there are also some lava boats that may be like disperse a coral babies in the Great Barrier of the Reef. So huge material is there, which is a pollutant, which we need to be cleaned with the help of this. Robot devices like these kind of devices improve wastewater treatment plants also. Like we need to clean this water and able to use it accordingly. So now we come to the, like we all know there is some robots. It's a kind of machine which is through some commands, it do some kind of jobs. But in robot, like in sea area or in a big ocean area, we need autonomous robots which moves on their own, which take decision on their own, which like move for a long time duration, and which will do their job for a number of days, so that we're able to get a clean surface, or even a clean like oceans within so many number of years. So there are and this, for developing this autonomous robots, we need to contribution of artificial intelligence that play a very important role in the robotics. So everybody like hearing the term AI. So definitely we have to combine this AI with the autonomous robots, or we can say robots and AI both become it gives towards the contribute toward the autonomous robots. So these are robots which help in developing which can operate independently and which can clean ocean faster and more efficiently than a human ever could. And similarly, Industry 4 is also using this advanced robotics and AI techniques for developing advanced AI robots. So now I just emphasize a little bit on our intelligence side. So what is this artificial intelligence? So it's a kind of property that mind encompasses many related mental abilities, such as capability to reason, plan, solve the problem, think abstractly, comprehend ideas and language, and learn. Like as we all think, how we take the decision in our life, it's by some reasoning. We do certain tasks like planning, and we make a problem solving when we get some obstacle, and so many like things we do. We have to incorporate this kind of intelligence in a machine. So that is called basically artificial intelligence. And similarly, more ingredient of intelligence is like ability to interact with the real world. Because when your autonomous robots moves in a big ocean, there is a problem which come on that spot. They have to interact with the environment, interact with the situation, and accordingly take the decision. Like perceive and understand the situation, language understanding information, visual perceptions, what kind of situation is there. Then we have a reasoning and planning also, like modeling in external world, problem solving, planning and decision making, ability to deal with the unexpected problem which may come while moving this autonomous robots, that intelligent robots. And similarly, there is the adaptation and learning. They have to adapt in which environment they have to work. And secondly, they have to continuously learn and continuously take the decision as per the prior learning. So AI, as we all know, we relate it with the computer science, which is like study of creation of computer system that exhibit some kind of intelligence. And we have like, it's similar to like human behavior. And sometimes it may be like better than human behavior. So AI in broader area consisting of different fields from like machine vision, expert system, and it's like able to make a machine which is able to think. And similarly, it's like a cognitive science, philosophy, psychology, economics, computer science, theory. All the things are like merged into one, and we make some machine which is AI machine, and that is to be there. In order to classify like machine thinking, it is necessary to define its intelligence. We define a machine like what is its thinking and what is its intelligence, and that we help to develop a computer software, computer program with respect to that, which simulate a behavior or which make it autonomous and make a decision on their own. So there is a two view on our AI goals. Like AI is about duplicating what the human brain does, like what human brain does in a normal life. So like it's a cognitive science, like how we think, how we behave, how we sense, how we like take a certain kind of how we respond to the music, how we respond to the like language, these kind of duplicating the behavior of human brain. And second is AI is about duplicating what human brain should do. And second, what is the capacity of doing the things. So it is like logically we are doing the things most of the time, so that we have to make with the AI, we have to develop such kind of that it take up the capabilities of human being and ability to how the human being to be taking it. So AI systems have a learn new concept and task. They can learn new tasks as per the situation, and they even take a reason, they take a useful conclusions as per the situation around that. And similarly, they can draw a conclusion from the situation and get some inference result from it. They understand some natural languages, perceive, comprehend, and visual scenes, and they look through various cameras and see what the things all around us, and then accordingly they decide what to do with that. So it's like a functioning and fundamental of AI is something like mathematics, neuroscience, control theory, linguistics. So many things are incorporated in a single AI. So it's a kind of like incorporating so many things which you normally, when you are just a kid and you're grown up with your family and you're learning so many things naturally, like mathematics you are learning, neuroscience you are developing, and you are making the control of the things, and you are learning language also. So same all things we have to incorporate in a machine, so make it artificially intelligent capable. And secondly, we like AI techniques which we use to develop such machine is like rule-based kind of we use a program. And secondly, there are so many techniques like fuzzy and neural and genetic algorithm, or there may be so many other techniques which we use which works on some rule-based like technique, rule-based database, and accordingly they take decisions as per the combination of different rules. There are so many numerous applications today, like AI can be help in a business to make a financial decision, taking so many parameters into consideration, which normally it's not possible for a human being to take a decision on itself. And similarly, like engineering, we check a design, various product we have to, which we are designing, the directly AI taken up for that, and take the like consideration or even checking the capability of that machine. Manufacturing also, now we are using like assembly, inspection, and maintenance also with that. Mining also, there is in a dangerous condition, we use AI there. Even hospital, we are diagnosing, prescribing, and monitoring also through AI. Education also, nowadays we have AI robots which are teaching, which are interacting with the students. Similarly, there is a household, like we advise in a cooking, shopping, etc. And so many things like Google Assistance is using nowadays for assisting in so many things. And similarly, robotic come to the autonomous robots, which are like a human being. They can move, they can take a decision, they can understand language, and all this is through the AI, which is possible with that, and which can help a lot in supporting the human life. So as per AI robots, we are talking a little bit on that, like Industry 4, with respect to like, it's a kind of, we all know it's a mechanical and a virtual artificial agent machine. Usually it's an electrochemical machine and guided by a computer. And robot can be autonomous or semi-continuous. It's depending upon what kind of application we are using for that. So there are, like, we can say robots are like using in industry, medical, mobile, walking, and humanoid. So if we come to the robotic science, humanoids or human working in the area is called robotics. So nowadays, if a robot is behaving like a human beings, we call it a humanoid robots. And when it take a decision on their own, taking using AI, we can say it's an AI, artificial intelligent humanoid robots. So here in this, like if broadly we classify robotics, and there is a humanoid robots in center using AI. So there is a end effectors like hands and various eyes and everything it is using through different sensors, and there is a control system. By combination of these two, and with the help of AI intelligence, we can develop a humanoid robot, and or we can say machines, AI machines, which can take decision, which can contribute as human beings are doing nowadays. And more in that, like artificial intelligence, robotics is like how it incorporate intelligence in that, basic on reasoning, learning, perceptions, problem solving, and linguistic intelligence. These things are to be understood by machine. And based on this, they take a decision. We can say this kind of machines are basically AI and robotic machines. And so more in that, like AI in robotics is like it's a like a ability of a system to calculate certain kind of reasons, perceive relationships, analogies, experience, store and retrieve information, memory, problem solving, and comprehending complex ideas using natural language, and so many things has to be adapt as per the new situations. So to develop certain intelligence, we need a linguistic intelligence, musical intelligence, logical, mathematical intelligence, spatial intelligence, and body statics. So these things, like which we normally not incorporate in a machine, like musical intelligence. The machine has to understand it is a soft music or it is a hard music, and accordingly they decides about the environment. Similarly, they understand the weather, what kind of weather are there. Accordingly, machine will take certain decisions. If weather is very much humid, accordingly machine will take the decision. So as per they have to make a little bit more advanced in this sense. And like more or less to develop this AI kind of robots, we need some use of aggressively soft computing techniques. We know this. It's very common today. So like we have to develop and accommodate and imprecision and uncertainty. Like whenever, like if you come to the human beings, how they learn, they always learn from accommodating imprecisions and uncertainties. We are not like, if we are a good cricketer, it's not from the very first day we will do a very accurate ball. It's not possible. We have to do with the practice, and definitely we become a very perfect cricketer. Similarly, we have to make a machine so that it can understand, it can accommodate imprecisions and like compensate what kind of uncertainties are there, and able to learn from that and make a perfection on their own through their developing their own program or operating their own programs. Soft computing techniques like fuzzy neural evolutionary computing techniques like genetic particle swarm and colony, bee colony, and there are so many other soft computing techniques which we have to incorporate in a machine so that able to take a decision on their own. So sometimes we use two or more three such kind of techniques. We make a hybrid kind of machines, and which able to develop a machine which behave or mimic the human behavior. And here is some machines which are using for oceans for cleaning, like water shark. So it is normally moving over the water surface, and they clean up the litter which is spread over the ocean surface or maybe in some water body. And this is flowed through the sea, and the mouth is open, and they are collecting the debris. And but we need so many such kind of water sharks for cleaning so much huge pollutants all over our sea area. And similarly, there are some sea swamps which are moving over the surface because, as we know, due to the big ships and all, there is so much oil spill over the our ocean surfaces. So sometimes there may be due to accidental chances, or some may be due to the normal routines like travel, transportation. So we have to clean that. So using the sea swam, they able to like move on the surface, and there is some kind of conveyor belt which can absorb that oil, and definitely they can remove it, and definitely we will get a clean water with the help of this. So these are machine which is be able to work over that, so that we can able to clean up our sea and clean up our water bodies, and definitely we will live a wonderful and a happy life on this surface. So this is something, just a brief outline of my talk, and I try to just to adjust in all of you marine engineers. And thank you all for your patience listening, and it's giving me a wonderful opportunity. And thank you all of you.
Thank you, sir.
Thank you, sir. Harish, sir?
Yes, ma'am.
Thank you, sir.
Thank you. Now I would like to invite Professor Bhupati Bhaskaran, Principal DGS courses, to deliver the valedictory address.
Yes, sir. Good evening to one and all. First and foremost, I have to thank our Chancellor, Vice Chancellor, Pro-Chancellor, Pro-Vice Chancellor, the Registrar, and above all, our Dean Academics, Dr. Sashlata Madam, who has arranged for this program. You know, it has been, I mean, beyond an international conference, I should say. It's beyond that, I should say, because I've come across various conferences, international conferences, national conferences, and so on. The international conference with technical aspects was in depth, and last 2 days was really, all knowledge sharing sections conducted, shared by all our participants. And it has been very energetic. And of course, our cadets, nearly 300 and above of them have participated. And they have listened to you, and a lot of comments have come from our cadets asking for various other doubts clearing sessions and so on. Sir, we will keep in touch with you, and we thank you on behalf of Amit for your valuable time. First thing is the time in this COVID situation, in a situation where the world is really in different sectors, worried or trying to come out of this, and thinking about how we can devise a mechanism to lead this world for the next coming sessions and years and so on. We heard a lot about the fuel technology developments. Now we are hearing a lot about artificial intelligence and the robotism, how it's going to play in. We thank you all for this wonderful speeches, knowledge sharing session, and and our Amit has created a wonderful platform. I undoubtedly put that in the screen. Now I also thank our participants who were with us throughout and listened to us and to grasp and ask questions in between. It was really energizing. Above all, it will be good. It will not be nice if I just leave this part. I should thank all our organizers. It's a team of organizers under the leadership of Dean, Triple E Dean Academics, Sashalata Madam. For nearly 1.5 months, the preparation was poured in, day and night, interacting and arranging the sessions. I have attended various marriage functions or various programs. Maybe the programmer would have arranged all the decorations and other things, but the members who are in sequence conducting the program and taking it up, they play a very, very major role, give a final touch on it. And each and every member of our team in Marine Engineering Department has taken part. They have taken their responsibilities and they have done it very well. I thank every one of them from my bottom of my heart, sir. Thank you very much. And I hand over the mic to our organizers. Thank you.
Thank you, sir.
I request Dean Madam to say a few words.
Yeah, good evening to all. At the outset, I would like to take this opportunity to thank the management, Vice Chancellor, Registrar, Joint Registrar, Principal of DGS courses, Professor Bhupati Bhaskaran, Director, Professor K.R. Chidambaram, our entire team of faculty and students. I take this opportunity to thank the chief guest of this particular 2 days international conference on disruptive technologies in maritime sector, Industry 4.0, Dr. Paneer Selvam Ramasamy, Principal Director of MSME Agra. And also I would like to thank the other chief guest, Dr. Sanjay Babnani, Director and Chief Operating Officer, MMS Maritime Private Limited. I thank the international speakers, Dr. Eric Zarnowski is available here, Professor Signia, Maritime University, Poland. Thank you very much, sir. Thank you for your support. I also thank Dr. Moshin Raza and Mohammad Awais from the Department of Computer Science, Edghill University, UK. I would like to thank all the speakers. Today's speakers are Chief Engineer I.N. Bose from Great Eastern Shipping Company Limited, Mumbai. Then Shivaram, Chief Engineer Shivaram Narayanasamy, General Manager of Cochin Shipyard Limited, Cochin. Then other speakers, Dr. Dinesh Babu, Director of Samhita Marine, Chennai. Then today's guest, Now the valedictory guest, Dr. Vijay Kumar Banga, Principal of Amritsar College of Engineering, Amritsar College of Engineering Technology, Amritsar. Thank you so much, sir. Thank you for being with us and sharing your expertise and experiences. I feel honored and happy to thank Mr. Anand Tripathi, Placement Director, Mumbai. With his guidance and support, we are able to get good speakers, chief engineers from Mumbai and other places, our placement director, Professor Srinivasan sir, and all the industry experts, chief engineers, conference coordinators, conference committee members, including system administrator, for providing the opportunity to speak, interact with you all, and to make this 2 days international conference on disruptive technologies in maritime sector, Industry 4.0 in a grand successful way. Thank you all. Thank you once again.
Thank you once again. Thank you.
Thank you, ma'am. May I request Mr. Harish, Department of Marine Engineering, to read the conference report.
To one and all gathered here. Now it's time to appreciate the participants, those who have won the best paper award. Appreciation is the act of valuing someone for their efforts who deserves it best. We offer it as the best paper award for their innovative results and their contribution towards their research. Track 1, Integrated Logistics, Materials and Production, was headed by the session chair, Dr. Edison R. Chandraseelan and Mr. B. Ashok Kumar. The best paper award goes to paper ID ICDTMS 0504, titled Ship Collision Prevented Using Emergency Collision Prevention Drag Radar, which was presented by Chief Engineer Soundararajan, whose affiliation is Ahmed deemed to be University. Congratulations, sir. Track 2, Meteorology and Weather Forecasting, was headed by the session chairs Dr. Suresh Alex and Mr. Aaron Glenn. The best paper award goes to paper ID ICDTMS 0501. The paper title is The Amalgamation of Technology into Arts and Science of Celestial Navigation Ways to Accurate Positioning Fixing at Sea. And the presenter is Commander Ramakrishnan Venkat. And his affiliation is Ahmed deemed to be University. Congratulations, sir.
Thank you.
Congratulations.
Track 3, Smart Technology, was headed by the session chairs Dr. Sangeeta and Ms. Selvarani. The best paper award goes to paper ID ICDTMS 0104. The paper title is Integrating of Mobile Sensor Network with Multiprocess of Palletizing Robots in Manufacturing Industries. And the authors are B. Ravindra Kumar, K. Maheshwari, and T. Divya Bharati. Congratulations, participants. Track 4, Renewable Energy Systems in Onboard Ship, which was headed by the session chairs Dr. Smiley Madhuram and Ms. Sindhuja. The best paper award goes to paper ID ICDTMS 0405, titled The Evaluation of Indian Power Market Chronological Approach. And the author are Anushri, Dr. Rashmi MR and Suresh Alex. And the author affiliation is Amrita Vishwadeepam University, Karnataka. Congratulations, participants. Track 5, Industry Automation, which was headed by the session chairs Dr. S. Utpaskaran and Mr. Amatraj and also Mr. Ramamurthy. The best paper award goes to paper ID ICDTMS 0602. Paper title is Artificial Reefs, Biorock, Tamil Nadu, which was presented by Mr. Gurukeshwar Sridharan, a cadet of Department of Marine Engineering, final year, Ahmed deemed to be University. Congratulations. Track 6, Marine Pollution, which was headed by the session chairs Dr. S.P. Saravanan and Dr. M. Tamilarasi. The best paper award goes to the paper ID ICDTMS 0312, and the paper title is Optimization of Machining Parameters in Turning of AA 7075. And the authors are Mr. R. Purushothaman and Mr. M. Ramamurthy. Congratulations, participants. Thank you.
Thank you, sir. Now, proof of the pudding, we will be interested to know the feedback from the panelists. So I request few volunteers from the panelists to give your feedback about the conference.
Anyone can come forward.
Very good evening to all, and I would like to give my feedback. I've been attending it for the last 2 days in various papers which are presented. My curiosity is to find a technological solution for finding the position fixing of celestial navigation principles used on board ships. And it I get boosted up by listening to even the last speaker who spoke today in the validatory function, Dr. Banga. And I think I'm going to do further research and find a permanent solution for position accuracy, which is suffering us on date. I think technology is growing, and it is going to have immense impact for position fixing, especially for mariners who are ocean passage. They are going to get benefited. And I would like to also thank the panelists and all coordinators and also young participants who have come up with brilliant papers. And it is really interesting to witness their contribution. And second, thank you all. Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Yes. Anyone else?
Professor Eirik, would you like to say a few words, sir?
Hello and good afternoon, all. It was for me very good experience and of course a pleasure to be at the conference, invite and give my opinion on the current situation in area of Industry 4.0, and my opinion that without the strong skills of the from research teacher to the workers, we cannot obtain the and we cannot achieve the aims, new generation and new technology in each area, and especially what is the main our interest in marine. So it is a very strong work to us. As I mentioned, that I work with the artificial intelligence 20 years, but now it is the time that all people understand what means artificial intelligence. But it is the key to the new technology, and so I wish all yes, for research, that when we will have a good understanding, good reasoning about this technology, we can go to the next maybe Industry 5.0. So maybe in future it will be the next step, the progress, yes, in this domain. Thank you very much, and I wish all health, and maybe in next conference, maybe we will have occasion to meet maybe in Poland. Thank you very much.
Thank you. Sure, sir. Thank you, sir. Thank you.
Thank you, sir. Thank you for the wishes from Poland.
Thank you, sir. Thank you. Thank you.
May I now call upon Dr. Edison, Professor, Department of Marine Engineering, to deliver the vote of thanks.
A very good evening to all. On behalf of Department of Marine Engineering, Ahmed University, on my own behalf, it gives me an immense pleasure to propose vote of thanks in this August gathering. First and foremost, I would like to thank our beloved Chancellor, Dr. Ramachandran, for supporting to organize this international conference on disruptive technologies in maritime sector, Industry 4.0. Thank you, sir. I would like to extend my sincere gratitude to our chief guest, Dr. Vijay Kumar Banga, Principal and Registered College of Engineering and Technology, Punjab. Thank you, sir. I also extend my sincere thanks to the eminent keynote speakers, Chief Engineer Sivaram Narayanaswamy, General Manager, Business Department, Kochi Shipyard Limited, Kochi, Dr. Aidan Zarnowski, Professor, Department of Information System, Idniya Maritime University, Poland, Dr. Muhammad Awais, Senior Lecturer, Department of Computer Science, University, UK, Dr. Dinesh Babu, Director, KUM India Private Limited, Dr. Moshin Raza, Senior Lecturer, University, UK, then Chief Engineer, Internal Course, and Advisor, the Great Eastern Shipping Company Limited, Mumbai. I would like to extend my sincere gratitude to our Chancellor, Colonel Dr. Thiruvasakam, for supporting to organize this international conference. Thank you, sir. I also thank our registrar, Dr. Jayaprakash Sway, for helping to approve the arrangements of this international conference in a grand manner. Thank you, sir. I extend my sincere thanks to our joint registrar, Mrs. Sangeeta Alvin, to help us make this event a successful one. I extend my sincere gratitude to our principal, Professor Bhupati Bhaskaran, to help us in organizing this event. Thank you, sir. I extend my sincere thanks to our Dean Academic, Dr. T. Sasilata, who has been the motivator and inspiration to organize this international conference right from its inception to till date. Thank you, ma'am. I extend my sincere gratitude to graduates, chief engineers, organizing committees, team members, heads of the departments, participants from various organizations and institutions, both from India and abroad. Thank you all. Last but not the least, I express my sincere gratitude to IT support team, PRO, teaching and non-teaching faculty of AMET, and all those who have supported us making this event a grand success. Thank you once again.
Thank you, sir.
Thank you, sir.
The pessimist sees difficulty in every opportunity. The optimist sees opportunity in every difficulty, said Winston Churchill. As a coincidence, we were able to conduct 2 days of the international level virtual conference on disruptive technology in maritime sector, Industry 4.0, in a successful manner, even during this new normal state. I would like to close my remarks and officially announce the end of the conference session, wishing all the spectators future prosperity and students good luck and positive vibes and prayers that the pandemic period gets over soon and we can all meet each other in our work and study place. Meet you all soon in one such sessions. Thank you for your attention. Thank you.
Thank you.
And now we will have the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंग विंध्य हिमाचल यमुना गंगा उज्ज्वल जलधि तरंग तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, sir. Thank you, madam.
Thank you. Thank you to everyone once again. I mean, for Of course, this will keep on extending. Very hectic schedule it was, and very well organized and very well done by the entire team of members. And thank you for all our speakers, for your valuable time, sir. And we will keep in touch in future too. And we will do a lot of interaction and a lot of research works from now onwards, sir. Thank you.
Thank you all.
Thank you all. Thank you.
Thank you. Thank you, madam. Thank you.
Thank you, ma'am. Thank you, sir.
Thank you. Thank you to all. Thank you.